90 seconds, yeah.
Okay.
Yeah,
We're here to see that in person.
I did inject my, I did inject some of my slides in this presentation. So this is, so you guys know before we go live, this is a brand new presentation for me, which is kind of fun because it's just as exciting for me as it is for you. Because all my other presentations I can do without even looking at the screen. So this is kind of fun, right? So we're trying to keep consistency amongst the 3 presentations we've done with this. Now, I'll ask you certain questions, and depending on the answers, I may take this entire presentation and wipe it out and go someplace different. So it's, don't be bashful to answer questions. So anyway.
Steve, you are live.
Oh, we're live, cool.
Kick off.
Good morning, everybody. Thanks for coming today to multiple training, to the advanced boiler room training here, where we have 3 manufacturers. We hope to make that 4 in the future. We won't mention who the 4th is, but it's going to get better as time goes on. You know, the problem is we might need more time. You know, we might have to make this a 2-day class to put all 4 manufacturers in. But my card is on your tables, on your desks. My name is Steve Whelan. Most people call me Wheels in this industry. It's just half my last name. It has nothing to do with my racing career. Yes, I was a pro stock, head wrench, drag racing for 5 years. And yes, it was fun and exciting, and I've been blown up, and I've had engines shatter on my feet. And it's just great fun, you know? But the reality of it is I got into this business as a plumber. I started when I was 13 apprenticing, went on to become a plumber, got my master's license around the age of 20. Sold that business, bought a supply house, owned that for 15 years, sold that, went into international manufacturing with a little company called Roth Industries. If you ever bought a Roth oil tank, you're welcome. I'm the guy who brought that into the States and got all the approvals on it. Roth Radiant was what I was hired for. And I went back in the wholesale business. I lasted 9 years. I appreciate a couple of the guys who are sitting here right now, like Kevin and Frank, because they're still in it. I got out of it and went into back into the manufacturing world. And that's how I got to NTI. So, but if you're like me, you would have no idea who NTI was. I mean, I've covered and sold and specified and manufactured every single boiler out there. And 17 years ago, I had no idea who the hell NTI was. I had not a clue. But I knew who New Yorker Boiler of Colmar, Pennsylvania was, because I sold a shitload of oil-fired New Yorker boilers, the SAP and the FRs, if you're familiar with them, out of my doors, and installed hundreds of them. And I still had no idea who NTI was. But NTI was New Yorker Boiler of Canada until Burnham bought New Yorker. We were building New Yorker boilers for the Canadian market since 1963. And when Burnham bought New Yorker, they said, like they do to everybody, we're not going to change a thing. Right? We all know this, right? PE comes in, we're not going to change a thing. You know it's bullshit. They just don't want you to leave till they have somebody to replace you, right? They want to know what you know before you go. Well, the first thing they did was send us a cease and desist letter on using the New Yorker name and logo. And we changed our name to NY Thermal with the logo of NTI. Well, the nice thing about that is we only had one boiler that came here. It was called the Trinity Boiler. Those of you who've been in the business a little while remember the Trinities. The Trinity LX and the Trinity TI. That was great, right? And I'd walk into places with my paperwork and go, hey, I'd like to sell you my boilers. They said, well, who the hell are you? And I go, well, I'm with NTI. And they go, who the hell is NTI? And I'd hand them a sheet of paper, and they'd go, oh, you're Trinity Boiler Company. Well, that'd be like calling Crown Aruba, right? Or, I mean, let's pick our poisons here, right? You know, calling Peerless the pinnacle, right? It doesn't happen in our life, right? So it took me a little while, but not much time, to get the NTI name recognized as NTI. Now we actually have a marketing department that does that, and that's pretty cool, because I don't have to do that shit anymore, right? 15 years ago, we didn't have any of that. I was it, and the regional sales manager, and now I'm the director of national accounts for USA Heating. Which the really cool thing is we hired a guy that I've known for the last 15 years to take my position, and he's doing a great job in the Mid-Atlantic. So that's a little bit about me. You can call me at any time. You have my cell phone number, my email address. You can call me, text me, shoot me a note, whatever. Frank and I go back to early Weersbo days. I meet just a couple years before him on radiant heat. If you want to get into any kind of boilers, or you want to get off the standard boiler installation, please don't be bashful to call me, all right? So, but I ask you to do this. I ask you to whip out your phones and take a little picture of this and register on our website. Why? Because then we can send you stuff. It's not a lot. It's a couple emails a month. And if you want to opt out of the email, you just opt out of it. If you don't want something, you just say, hey, Wheels, send me an email that says, hey, Wheels, take me off the goddamn list. I'll take you off. I don't care. I have no problem with that. I really don't. But if you register on this, I actually get credit for doing today's training. And they go, hey, Wheels, great job. You guys had like 20 people in the room. But if only 3 of you register, they only think I had 3 people here. Now, I used to hand out papers to do this and make everybody fill out the paper. And at least 4 out of 10 I couldn't read because they wrote so small or scribbly, and now I don't have to worry about it because you guys do this, and then I get an email saying, hey, Kevin signed up on your site, and this is cool. And if you're already in, that's all right because we don't duplicate. What's the worst that's going to happen? You're going to get 3 emails, put one to your personal, like I do for Ted Lowe.
Seems we've had this discussion.
Oh, yeah, we have. Anyway, I'll give everybody a second on this. If you guys have a question today, if I say something you don't understand, if you're not sure of the answer, do not hesitate to call me out on it right here. Don't hesitate to stop me. Say, hey, Wheels, could you back that up a little bit? I am from Philadelphia. I do talk a little fast. I do have an accent, though I don't think I have an accent. My wife is the Mainer, tells me I have an accent. I think she's full of shit, but anyway.
Now, can we send that to her?
Yeah, absolutely. Absolutely. Wouldn't be anything she hasn't heard before. So, cool. Everybody good with this? Can I move on? Good. So today, we're going to go through NTI. We're going to do something totally different that I usually don't do. We're going to go over what size boiler do you need, sizing a storage tank versus a combi, picking the right boiler for that application, sizing the pipe circulators, and controlling the navigation program. I've added quite a few slides to this just to make my life funner. Of course, we'll do Centrotherm after me, and we'll do Cytron after that. So I'm supposed to be on here from 9 o'clock till 2 o'clock. Centrotherm comes on from 2 to 5, and then Cytron finishes up from 8 to 10, right? Okay, so reality, 9 to 11:30, we'll take a break somewhere in between maybe, and we'll go 11:30 to whenever for Centrotherm when Rob will have some fun, and then hopefully Cytron will show up by then. If not, I do have my combustion analyzer outside, and I'll bring it in and I'll do the Cytron class. So I have 0 problems with that. So who we are. So, when I started with this company, it was owned by one guy, Kevin Dennison. Some of you know Kevin. Hell of a guy. He took this company, NTI, from bankruptcy in 1995 to being in the top 4 boiler manufacturers in just 10 years. Pretty hip, right? He literally, if you ask him about his story, he will tell you how he was carrying cash in bags to the bank so they wouldn't shut him down. Isn't that weird? And now look at us. And in 2025, he sold out to Ariston. And I love it. He built a beautiful house. I mean, we all built a beautiful company for him to build this huge, gorgeous house. Still a hell of a great guy. Still having fun. But now instead of being in the top 4 boiler manufacturers in North America, we're in the top 4 boiler manufacturers of the world. Because now we're part of a $4.9 billion a year company. Pretty neat, right? So, we have 29 production sites in 17 countries. We have 40 countries that represent us. We have 28 R&D centers. We're huge. We make all of our own electronics now. So when you get an NTI boiler and I show you the Series 2 controller, oh my God, where'd that come from? We build that. We have a division now that makes hardware and software. I no longer have to depend on Argus. I don't have to depend on Honeywell. And if you know anything about Honeywell, they have changed and moved their electronic plant 3 times, and they just keep getting worse. I just can't help it, but now we don't have to worry about that anymore, right? So, anyway, what Kevin was waiting for is our boilers in 90 seconds. So this is kind of fun. So, I get paid by NTI, right, to tell you this shit, right? So I'm supposed to tell you all about our boilers, so I'm going to. I sure wish that I had a pointer that went up there, but I'll do it anyway. So top left-hand corner, the TFTN. The TFTN is a phenomenal A fire tube boiler comes in sizes 85 through 399, not available in a combi, does not have an internal pump, but does have a 3-zone controller built in, 3 additional pumps included with it that you can, or connections so you can go into it. Would you silence that goddamn thing?
Airplane mode.
Like all of my boilers are cascadable to 8 out of the box, and anything with the NTI net sign on it is Wi-Fi compatible out of the box. What does that mean? That means that you guys get a free dashboard and you can do anything from anywhere in the world to that boiler control that you can standing in front of it, except for one thing. Do you know what that is? Reset a hard lock on a flame. Because that's a safety issue. You may have disconnected the gas line going to the gas valve. I don't know this. And then I go, oh, well, let's see what happens. Boom. And then you're happy because your wife's not around anymore. Isn't that cool? Yeah, we don't do that shit. So that's why it's a safety issue. Down below, second from the left, is the TFGN floor mount. That comes in 500, 600, 725, and 850. That is what I like to call my Lochinvar night killer. Their FTXL that absolutely kicks them right squarely in the butt. So on the top, coming across, second and third one on the top, the TRX and the FTVN, identical controls, totally different inside. One's a water tube, one's a fire tube. Do you guys know the difference between water tubes and fire tubes? Anybody not know the difference? Anybody not know the difference? Cool. All right, good. We'll move on. So they're available. What's that? All right. We'll get to that, hopefully. And if not in this presentation, I'll bring them up on another one. The TRX and the FTVN come in sizes 85 through 199 and as combis in 110, 150, and 199. They have an internal pump on them so that they pump the plate heat exchanger, your indirect inside, without having to add another pump. And they have the beautiful Series 2 controller and Wi-Fi compatible out of the box. My newest product, the Verta, coming out. It's going to be arriving in 3 weeks. The Verta is our air-to-water heat pump monoblock system. All you have to do, you set that outside. It's just water or glycol lines going inside to your heating equipment. Beautiful control inside with a beautiful touchscreen. Comes in sizes 3-ton and 5-ton, basically. Phenomenal unit. It's a R32 unit, if you're wondering what refrigerant we're using. And that's coming out. It's been phenomenally received in the industry. We've had it out in testing now for almost 1.5 years, and it's been very successful. The new ones, the current ones, are not cascadable. The ones coming in November will be. Don't ask me why. I have no idea. Anyway, Trin Store water heaters, indirect water heaters. We have the wall hung, the 20-gallon, has better recovery rate than a 60-gallon. And we have a quick hookup kit to take this and connect it with an FTVN heat only or the 2 larger TRX heat onlys, and you can hang them both on the wall in under 45 minutes. What don't you have? You don't have 60 gallon of storage to fill a 60-gallon Whirlpool in 5 minutes. That you don't have. Floor mounts come in 40, 50, 65, 80, and 120. All of them are lifetime warranty on the heat exchanger. Unless you're using it commercially, then it's only 7 years. The GF150. This is my TRX 150 water tube, 150,000 BTU boiler set on top of an air handler with a 4-row duct coil. Universal piping right or left. You can do 80,000 BTU worth of forced air heat. You can do up to 40,000 BTU of radiant or baseboard heat off the bottom. You can have your connections right or left on the bottom, which is kind of cool. And you can put up to your own 3-ton A coil and up to a 2-stage condenser on it. So it's 3 appliances in one, which is really nice for a condominium where you have no gosh darn room, right? So moving to the left, my compass. The compass is the floor mount FTVN. The compass is full universal piping. You can have your return and your supply, has the low loss header built in. You can have your return come in the right and your supply go out the left. You can have them out the right, both out the right, both out the left. You can have your domestic hot water or your hot and cold water going, your supply and return going to your indirect right or left. You can have your gas right or left. And I can tell you firsthand that you can take this boiler, tear out a cast iron boiler, and do the entire job in under 8 hours. And I've done that.
Yeah, I've done that.
With one other guy who's my age. So you know that we weren't moving as fast as some of you guys can. So anyway, moving to the left, the oldest boiler we have, the LXWH, one of my most favorite boilers. That will be going away in about 8 months, maybe a year. That comes in sizes of boiler from 150 through 800,000 BTU, and as a water heater from 200 to 800,000 BTU. As a water heater, 800,000 BTU, it'll give you 980 gallons, I think it is, at 100-degree rise. It is not a tankless water heater. You have to use it with a storage tank and a bronze or stainless steel pump. So don't think you're putting that in alone. Going to the left, of course, you know the TFTN, and then let's talk about the FTG, my fire tube giant. That little boiler is, it only comes in sizes 800 to 2.4 million BTU. So when people say, well, how big do you go? You can take 8 2.4s and put them together. You guys figure it out. That's 19 million BTU in one place, right? And they're all, my boilers are less than 33.5 inches wide, so you can roll them through any standard up-the-code man door in a mechanical room without having to blow through the wall. Now, I say that in a 2.4 million BTU boiler only weighs 2,140 pounds. So you're not going to just roll it in like it was on a hand truck. You're going to need a pallet jack. That is our beautiful manufacturing plant for our gas boilers. We do not make our steel oil-fired boilers here. They're made 45 minutes away at our noisy, dirty plant. If you ever go to this office in St. John, you would know that we're in a fully residential area. By fully residential, I'm talking $1 million condos all around this thing. It's a gorgeous place, but this is very quiet. And making a modulating condensing boiler is much a clean room, isn't it? Because we're not making mess. We're not casting. We're not welding. We're not doing any of this shit, right? It's all assembly work. It's wonderful. So it's a great place to hang out. So we have training centers in St. John, Vancouver, St. John, New Brunswick, of course, Vancouver, British Columbia, and New Bedford, Massachusetts. That's our training room up in St. John. Neat, right? Not much what it was like before, is it, Frank? They've put a lot of crap in there. It's a nice place. It's carpeted floors, so whenever somebody dumps a relief valve on us, it's always nice to clean up. Trust me, we've had people open up troughs and blow crap all over the floor, and then we take you for a factory tour while 3 of us clean it and vacuum it up, and you come back down, it looks like nothing happened. But we don't have that in New Bedford. This is our New Bedford training plant. Pretty cool, right? Just a little place. That's the training room there, much like this one. It's gorgeous. That's our live fire training area, and that's where we work on all the controls. So in New Bedford, we could take you from soup to nuts on installation, maintenance, and troubleshooting without a problem. If you ever need my tech department, how many people here hate calling tech departments? Because you never get an answer, right? And you're on the phone for like 2 hours, and the guy picks up and phone goes, did you remember to turn the gas on? And you're like, dude, really? You know, give me a break. We have one of the best tech departments I've ever worked with. When I started with this company, I thought it was bullshit. I started January 1, in the middle of the heating season, on one of the coldest years we've had. And I was scared to death I was going to be a one-armed paper hanger trying to answer all these phone calls. Because when I was in wholesale, I was your tech department for all of my boilers because I couldn't get through the tech department. So I learned them all. So I went there and I went 3 months without talking to anybody. Unless I went to your door, I didn't talk to anybody. I'm like, geez, maybe my phone number's not on the internet. It was. These guys are phenomenal. The 800 number on my card, 1-800-688-2575, extension 1, gets you right to them. We make them build these displays so that they have to learn all the controls right up front. And then we put them at a desk with all these controls. And then, of course, then we have all the boilers sitting there against the wall. So when they're talking to you and going, okay, I think maybe you have a loose wire, they take their wireless headset, go over, take the cover off the boiler you're working on, and they say, okay, so you see the top left, about 2 inches down and 1 inch from the left? That orange wire right there, grab that. It's very cool to watch. We have 12 guys doing this now. That's all the boilers that we have sitting up there. So that's everything from our first boiler to our last boiler. Isn't that cool? So it's a great, as I say, I am very proud of our tech department. They're open 7 o'clock in the morning to 8 o'clock at night, Eastern Standard Time, Monday through Friday in the summer, Monday through Saturday in the winter. And if you dial 506-636-0452 on Sundays from 9 to 4, you'll actually get somebody to pick up the cell phone. Now, my tech department's been enabled enough to be able to send you the part they say is wrong. If they say to you, I think your stepper valve is wrong. I think your stepper valve's busted. I think your little wheel on your domestic hot water sensing switch is busticated. They can send it to you. Now, out of Canada, that used to be 3 days because of customs. Isn't that a bitch? 3 days. So it cost me $86 to send you a $3 part, right? We still have to pay it, but it's 3 days to get it from Canada. So you know what we did? You saw how big that New Bedford area was, right? We put over $1 million worth of parts into New Bedford to send out just for emergency work in the United States. Isn't that cool? So for a couple years, I heard, yo, Wheels, I can't get these parts. You guys suck. Welcome to COVID, right? None of us could get parts, could we? You tell me a manufacturer could supply you a part January 1, 2021, and I'll kiss your ass. Because we were all short. We just weren't getting them. Now today, yeah, we got 240% parts in stock. That means if my demand's 100% for replacement parts, I got 240. You know where our goal is? 350. And every year we ordered, we place an order and we say, we really need 10, but we're going to order 15. And we're getting there. So they can send you the part right from New Bedford, Massachusetts, which means here in this lovely area, regular UPS is next day air. If you want it before 10, then I got to add extra freight to it, right? Ooh, big deal. We don't care. And if we want the old part back, you know what we do? We send you a return label, just like Amazon. So you can send it back. Cool, right? We have resources out the wazoo. You ever hear of this little thing called TikTok? You ever hear TikTok? You sons of bitches, what it's done to us is reduced our attention span to what, 35 seconds, right? If you can't get something done in 35 seconds, you're screwed. You guys are unique because we're going to sit here for 8 hours today and have some fun, I hope, right? But my goal a few years ago was to create the TikTok of training. So we talked about it quite a bit. We got somebody up in New Brunswick that wanted to take it under their belt because they said to me, and I quote, Wheels, it's not your job to do this. It's their job to do this. You're a salesman and you have to take care of national accounts, so you get out of that area. So I got out of that area. And they've done it, and we're up to over 180 videos. We have over 1,300 people that have subscribed. Please go to YouTube, go to @NTI Training, and subscribe. I had a guy call me up. He was putting 4 TFTN 399s on the wall. 4 TFTN 399s. This is a guy that for years would call me up and go, hey, Wheels, are you going to be available 8 o'clock in the morning? Why? Well, I'm going to cascade these 4 boilers, and I want you to hold my hand. I just need your verbal support to walk me through the control. I said, that's not a problem. But I'm not going to do it tomorrow for you. I'm going to do it at 10 o'clock tomorrow for you. He says, why? I said, I want you to go to YouTube and put in TFTN Cascade. Bring up the cascading on. I want you to watch that tonight. And you let me know at 10 o'clock how it went. I got a text message at 10 o'clock, almost on the button, saying, you made me look like a genius. You made me look smart. I watched that last night 2, 3 times. Watched it again this morning. I don't learn that quick, but I got it. And I did it all in one shot. How cool is that shit? You got a 501 air, that's a flame air. Uh-oh, it's listed on there. You got a 104 high temperature limit? Uh-oh, it's on there. You got dude, we've done, and we keep on going. And now they're starting to put Thursdays on it. They're 45 minutes long. See, 35 minutes, hour 19, they didn't cut that one down.
But they're pumping these out about 1 a week.
Yeah, well, our goal was 2 every Wednesday.
Yeah.
We're back down to 1. So yeah, we're kicking it, right, Frank? It's fun. Anyway, we have toolboxes. Oh yeah, we got toolboxes. We're up to about 40 different toolboxes. This is one of our toolboxes here. This is one of our older toolboxes here. When we only had 2 boilers, we had 2 toolkits. You could get a TI toolkit or an LX toolkit. Now the LX toolkit only went to 400,000 BTU. After that, you had to get the commercial one. So we had 3 really. Now we're up to about 40. Because now we have expensive toolkits and less expensive toolkits. The toolkits are nothing more than a parts kit. See, they got cool parts in it. There's no tools inside of our toolkits. All the boards, all the switches, everything you possibly want for general servicing. So, they're available, but how the hell would you find out what we got? Well, A couple different ways. First off, you start the partner login in NTI Boilers, and you get to go here and get the technical bulletins. And at 10 o'clock at night, if you can't find it on my YouTube page and you can't get a hold of me or anybody anywhere, you can go to the technical bulletins and you can actually search the tech bulletins and see if we wrote something on it and tell you how to fix it. Oh shit, that's easy. I guess I don't have a slide on the parts site. If you go to www.ntiboilerparts.com, you can look up all the parts. You can look up anything. That way when you're calling Frank or calling Kevin, you're asking for a part or whoever your wholesaler is, you can actually go in there, search the part, it shows you a picture, and you can order the right thing the first time. Instead of me calling it a rectifier and you calling it a flame sensor. And now you have no idea what you're getting. Holy shit. Now you can get the right part at the right time, right? Anyway. Thirsty Thursdays. This is a shameless plug for me. I started this in COVID. Yeah. Wheels, how are you going to prove why we're paying you? What are you going to do? So we got together with a couple of our guys, and I said, hey, why don't we do this? I mean, we're all drinking anyway. Why don't we have a drinking game? We'll get together on Thursday nights and do like an hour video. Let's just get on YouTube and just have some fun. And they said, oh, that'd be fun. I said, yeah. So we did the first episode. My boss called me up and said, Wheels, that was really great. He says, but remember, at all times you represent NTI. Now understand that I shoot this from my brewery. You see the 6 taps behind me. And I was getting up every 5 minutes and filling my glass up and then coming back up and continuing the conversation. And he said to me, he said, remember one thing, you always represent us, and I suggest you drink less. So I don't get up anymore. I pre-fill the glasses. Put them behind the camera. I mean, I'm not stupid. And they're all about hydronics. I've done 6 out of 83 episodes. I've done 6 on an actual product. This will make 7. Everything else is how to pipe, how to troubleshoot, how to work on any condensing or regular atmospheric boiler out there.
Great ones on water quality.
Yep. So, I mean, we just have fun with it. It's for you guys. It's just a way to share our knowledge.
One of the nice things is, and I shouldn't say this because we're here for NTI, but 99% of what you've talked about, you can use it for just NTI or you can go elsewhere with it.
Oh, yeah.
Absolutely.
You can take
Yep.
it as far as you want to go with it. It actually works great.
Yeah. I try to tell people, I mean, you don't have to buy it. I'd love you to buy my boilers, but we give you this resource. We're the longest running webinar out there. Taco is close. Taco missed a couple years because of some stuff, but they're getting better. But between Taco and I, we're the longest running heating webinars out there. And when it comes to boiler manufacturers, nobody's been able to duplicate what we do. And that's kind of fun to say, because I love to kick those sons of bitches right in the ass. Anyway, so this week, this Thursday, tomorrow night, and I'll be shooting it from Vermont because I'm not going to be home. I got Rick coming on, Rick Coster, who is my air to water heat pump specialist, coming in and doing tomorrow night just on this. And if you want to see that and you're not going to get through all the bullshit to get there, make sure that you give me your email address at break today, and I will, when I'm sitting back here, I will send you a link so you can sign up for it. So if you're interested in seeing the air to water heat pump, it's not the 4-hour class or the 2-hour class. It's a 45-minute quick class, but you'll get all sorts of information in it. It'll tell you everything that you really need to know up front. Anyway, hey, we're having a special. If you buy any 2 boilers, any TRX, FTVN, and I believe the TFTN or the Compass, you can get a toolbox for free. And then after that, every boiler you can get $100, or you can just keep saving them up and every 2 get another toolbox. I don't give a shit. How cool is that? And it's these toolboxes. What don't they have? They don't have a blower in them, and they don't have a gas valve, but they got every other service part in here. Why? Because they don't fit in the box.
Need a bigger box?
What's that?
Need a bigger box?
No, you don't want to go there. Because he had a bigger box at one point and you can't carry it in your van with the crap.
I find that in my service world, I get the big pack outs from Milwaukee, which my office won't pay the money for, and I repackage everything in there. But because I do so many boilers in the field, we had a whole stack of them made up, and one's just blowers for everything. One's just gas valves and switches. You know what I mean? So we didn't have one for each model. Of course, if you're a service tech, if you're going out for an FTVN, you don't want to grab this fucking stack of Milwaukee stackouts. You want to take just that, right? So, pretty cool. Anyway, you guys know what a heat loss is? How many people here do heat losses on their jobs? How many people have no idea what a heat loss is? Everybody knows what a heat loss is. Cool. Awesome. So we can blow through this pretty quick. I learned how to do heat losses on the IBR pink sheets back in 1972. Holy fuck, am I old?
Well, before that, it's count smokestacks. That's how many.
I got a picture here of something I actually had hanging on my wall. But and we used to take these, right, and put them together, and you would take the wall and you'd say, on the outside is asbestos shingles, and then we have fiberboard, and then we have 2x4s, and then we have drywall, and then you have insulation, usually rockable back then, and you'd actually build the wall and find out the R factor. Holy shit. Then you'd figure out the windows and the infiltration, and you had to figure that out. Oh my God. So you had a house like this, and you're looking at it, and Jimmy Carter got it so it was less than 25%, did it? For those of you who don't know Jimmy Carter, he was the president about 25 years ago that said, we really need to put R38 in the ceilings, and when you do that, we're going to give you a tax rebate for $100. Woo-hoo! Right? Anyway, but it worked. He just recently died. He was a great man. Anyway, 10% out the windows, out the walls. And the key here is, if it's 70 degrees inside and 70 degrees outside, does any energy or heat go through that wall? No. There has to be a temperature difference, doesn't it? And heat's nothing more than energy, right? I mean, in our boiler world, we're taking gas, right? That's an energy. We're converting it to flame. That's an energy. We're taking that flame, we're putting it into the water as heat, energy, and we're taking that energy back out the house, aren't we? Wow. All energy. Until we know what we need, we can't size it correctly. My last house I bought, I gave my first house away that I built. I gave it away. Well, it's easier to say than the court ripping it out of my hands and giving it to my ex-wife, right? So I gave it away. It makes me feel much better. It makes me feel like I'm philanthropic. So anyway, my last house I bought it, and of course I did a heat load on it right away, right? Didn't have to be manual. I used my computers, put it all in. 42,000 BTU before I did any improvements. How big do you think the boiler was?
120.
Well, I wish it would have been that small. 157,000. People tell me they can't use the heat pumps because they're too small. They only come in 3-ton and 5-ton. Well, now you got to do a heat load because you're going to find out that you can't use a lot of our rules of thumbs that we'll get to in a minute anymore because we have to do an actual heat loss. Why do we check the correct size? Because we need to get the right size boiler. What methods do you have for checking the heat load, right? Use an existing heat loss evaluation. When was the last time you walked in the house and the homeowner said, hey, I had a heat load done on my house 10 years ago. Do you want to use it? Said no homeowner ever. Use the existing radiation. Well, that's great. Because you're going to go through and you're going to count all the baseboard and you're going to multiply that by the active fin, because a lot of it's just a piece of tube inside. You take the active fin and you multiply that by 600 and that gives you your BTU. Or you go into Dan Holohan's site or you get the Burnham Heater Helper and you look up all the cast iron radiators in the place and you figure out the square footage and you multiply that by 213 and you come up with the amount of BTU you have for that. Isn't that great? Or you look up what your duct coil's doing and you go by that. And let me tell you this, anything that was created and put out there before 1990 is at least 30% oversized. Anything before 1960 was at least 50% oversized. And if you go back to the 30s, it's at least 3 times what you fucking need. Why was it that we had 3 times what we needed back then?
Bigger's better.
Well, that's part of it, Frank. But you know they used to leave the top floor windows open and bring the air in from outside down the basement. Why'd they do that? Swine flu. Holy shit, the last pandemic we goddamn had before we had that goddamn thing in 2020, right? So the existing radiation, you're going to be too big still. Using the old unit as the guide, or what I like to use as the finger lick method, and we've all done it when you get out to a job. Yeah, Kevin, I got a 142,000 BTU boiler here. What do you got close? 100 or 160? Oh, I'll take the 160. I can't go small. Said every goddamn plumber and heating man out there, right? Whereas my ex-partner used to say, you don't go smaller because I don't want a $2,000 fuck up. So we went bigger. Or take a guess, right? So 2 concerns. Undersizing the shit, right? Or oversizing it, right? Isn't that our 2 concerns? What we're trying to do inside the house is create an equilibrium, aren't we? To put just enough heat in to make up for the heat going out. To try to get everything the right size the first time. Not using the contractor anti-callback mode of putting a bigger pump in with a bigger boiler and hope that it's going to work. So heat loss evaluations are a gold standard for calculating the needs of the house. The existing radiation method is second best, of course. Match it with the current unit, that depends, and clocking the gas meter. By the way, clocking the gas meter is great, except if it's a standard atmospheric boiler, it's just going to pound the shit out of you, because half that heat's going right up the stack in it. When you have no need, it's going right up. Nozzle size, I hate that. And the rules of thumb, best guessed. So this is my last wholesale house. I did the hydronics division, of course, and I had this chart, but I had cut out the houses and I hung it on my wall. And there was a note on it that said, along the bottom, and you can't read it here, it says, stand on the opposing curb at least 100 feet away from the house. Hold this at arm's length, and whatever size house fits, whatever hole it fits into is your heat loss. It's all bullshit. It's like the 3-finger method, right? If it's 1 finger, it's 100,000, 2 fingers, it's 200,000, 3 fingers, it's 300,000. That was another way to do it, right? And so I had it there as a joke, literally a joke. And I get a phone call from a guy one day, a totally serious phone call. He says, hey, Wheels, can I borrow that quick design chart you have? And now, it's been on my wall now for like 8 years. I have no idea what he's talking about. I said, which one are we discussing? He says, that one hanging up on your wall over your desk. The one with the cutouts in it. And I said, and I quote, you're fucking kidding me, right? Because no, I need it. I don't have time to do a heat load on this place. I said, you're fucking kidding me, right? I'm laughing. I'm guffawing. I mean, I'm like, I can't even drink my coffee. And he was absolutely 100% serious. I couldn't believe it. I said, do me a favor. He says, what's that? I said, go out to the house and pace it off. What do you mean? Pace it off. Every step's about 3 feet, right? We do this all the time. We do gas lines this way, right? Who wants to take the 50-foot stick and sit, bullshit, you walk it off.
Got a good 3-foot step.
Exactly. You count it off, you figure the height of the house, and depending on the age, let's see my rules of thumb. 1970, you would take the cubic feet times 5. Some people used to use 40 BTU per square foot, but that doesn't take into account for today's cathedral ceilings, does it? Right? So anyway, so 1970 was 5, 1985 was 4, 1995 was 3, and today I use 2.5. You want to know how close I am? Pretty fucking close, but I'm still too big. But I can tell you how grossly oversized your house, your boiler is, right?
I usually say absolute worst construction, 30 BTUs a foot.
Yeah.
And it's big enough.
Yep.
Thank God for 10-to-1 turn down.
Yeah. But the rules of thumb are here, right? So here's what you have to do, right? Information needed. You need the design temperature difference. You know what that is? That's the coldest day of the year. Now, I'm from Willow Grove, Philadelphia, right? Just north of Philadelphia. ASHRAE says I can design to 16 degrees. I used to design to 0.
Kevin designs to -30.
It's really hard to do this, but you know what? You know how many hours it was below that on the coldest year in the last 20? You know how many times it was below that? How long of a time? 16 hours. And that's not all in one day. That's in the morning when the sun's coming up, when it's the coldest time of the day. That's it. So for 16 hours, 16 days, 1 hour, it was below 16 degrees, and I'm designing to 0, which is adding 30% to the size of my goddamn boilers. Now I can put in the right size boiler and charge the same thing you're charging, but I'm making more money, aren't I? Ha ha! Yeah, let's do it. Anyway, you need to know the room dimensions. A set of plans is nice. But a lot of times, if you're doing a new house, this is what you need. But a lot of times, if you're doing a whole house, you just need the whole house, right? You just need to do a whole house. You don't need to worry about everything else. You just need the whole house. Insulation factors. Now, when we're doing these projects, we like to use the U factor. Do you know the difference between a U and an R? Besides the fact that it's a STUV, right? You know,
1 over.
right? So this is something that you learned long ago, right? U equals 1 over R, and R equals 1 over U.
And the engineer will use the U to try and sound smart to you, and you're using R values.
Yep.
You can go, F you.
Exactly. So you need the insulation values. You need the infiltration factor. Do you know when I did my original IBR work with the Hydronics Institute, do you know how they figured the infiltration? They said if you have solid pane windows, single pane, you have a 1.4 multiplier. If you have storm windows that are movable, it's a 1.35 factor. And if you have solid storm windows, you know, the ones you hung on the wall that your grandparents made you bring out of the basement, then you could use a 1.325 factor. And they're all wrong. And then when you got done all this great calculating of all the little shit, when you got to the very bottom, it said, and for safety, add 30%. Oh, and wait a minute, and add 15% for heat loss. Because for some reason they think all the boilers are out in the barn and the pipes are coming across and we're losing 15% heat to get to the house. And you think that's weird? That's what we're working with, right? So anyway, heat load factor, infiltration factor, U factor, heat loss, and 1 over R, right? So design set points, just a difference in outdoor temperature to here. We like to use the AHR standards, right? You can look them up, they're online. You can find out what your design day is. This is a simple design day chart, what it looks for. Here's New Bedford, Massachusetts. Here's St. John, that's our 2 training rooms. And it tells you what the coldest month, the hottest month, and what your degree day is. Pretty easy, right? That's all your design temperatures. So the infiltration factor. I love this. 1 outside wall with openings, 2 outside walls, 3 outside walls. They don't even look at windows anymore, right? Because they just assume that you've made the windows good. Again, they're rules of thumb. So heat loss equals the infiltration factor. Here it is. Times the room volume, which is the width, the length, and the height. Room volume. And, of course, your design day temperature.
And that's going to be your biggest number.
Yep. So this is just your single pane, dual pane, low E glass, your vacuum insulated glass, your R factors in the wall. This is all stuff that comes into it. Oh, and you can see that R19 is actually equal to 0.053. This just says 0.05, we're rounding off. So if you like to be precise, it's 0.53. Anyway, so here's your room dimensions, your ceiling heights, your infiltration factors, your walls, your ceilings, your floors. Length, width, height, design day, design temperature, infiltration factor, and you find out that this is going to need 1148 BTU, right? Cool. That's all your figures for all your things, right? And you can figure this all out. So 1148 with a design day temperature of 15 degrees, or what would be near my house, or be in New Bedford, Massachusetts. If I take the same room and drop it into St. John, remember 2970, right? Let's take the same room and take this off. And now all of a sudden, at 40 degrees, we only need 1447. You know what this is telling us, guys? It means as it gets hotter out, we don't need as much heat. That makes sense? Is that strange to listen to? When it gets hotter out, we don't need as much heat. Makes sense, doesn't it? We said a lot of shit goes through that wall at 0 degrees outside and at 70 inside. Nothing goes through a wall at 70. So make the curve. We don't need that much heat. If you don't want to do the manual way, which I absolutely despise doing it manually still, there's all sorts of programs out there available for you to use. RightSoft, you just take the blueprints on a new house, import them in, and just draw over it. Automatically does it for you. It knows the difference between a floor and ceiling. It knows if there's another ceiling above it or another floor above your ceiling, so it doesn't give you ceiling loss. Isn't that cool? It globally looks at the house and stacks it up for you and builds the entire house. Elite is close to that. I've never used HeatCAD, but I'm told it's pretty good, and CoolCalc for Manual J I've never used either. So there's some free programs out there. I think Zillow at one point you could actually just scope the house and it would tell you what the heat load is. I think that's about as accurate as my finger. So heat emitters. So here's our heat emitter selection chart. You know, we got 7,503 BTU loss, right? You want to use radiators? When was the last time you've installed a new radiator?
2 months ago.
Was it to replace a broken one?
Yeah.
Yeah, there we go, right? But you had to find one, didn't you?
No,
They
we actually
specialize in steam.
we were able to get one.
Really?
Yeah, APR.
Nice.
Brand new.
Wow, it was a Burnham.
Burnham used to sell
Yeah,
them.
yeah, that's awesome. But you know, you can put a new radiator in. You know how many segments, sections? You just have to add up the sections. Go by the square feet. It's 325 BTU a section. You just add them up, right? So 325 into 7503. It tells you how big you need to get. Now, how do we actually do it today? My pipes are 3.5 feet apart. I need something 3.5 foot wide, right? So it fits in the hole. I can't put a 4 foot one in because the pipes are going to be like inside the radiator, right? And you're not going to cut the house apart to change the pipes. You can extend them, can't you? And take the angled valves off and put an elbow one and put a straight valve on. That works too for those of you who don't know anything about radiators. So, and baseboard. You know, so baseboard, you know, I always figured 600 BTUs a linear foot because I always figured at 4 gallons a minute. And it's just easier to remember 600 instead of 580. But I want you to see this while we're looking at this. I'm going to point something out here. So we're at 580, right, at 3/4 inch. And we drop in half by the time we get to 130. And we almost drop in half again when we get to 110. Holy shit. That means it's not a linear curve on the amount of temperature going out to the system. Keep that in mind for later. Radiant heat. How many people here do radiant heat and floor heat? You know how you decide how much BTU you need? For every square foot of house, for every square foot of floor that's heated, for every degree over ambient temperature, you're going to deliver 2 BTU. Does that make sense? So if my room temperature is 70 degrees and my floor temperature is 85, which is your maximum you can do before you have discomfort or you break marble, you're delivering 30 BTUs a square foot. Does that make sense? 70 and 85, difference between that's 15 degrees times 2 is 30. Now reduce it for where your toilets and cabinets are if you didn't run it underneath.
But that will cover your shitty insulated house.
That will cover your shitty insulation, absolutely. And that's, you know, so that's radiant heat. So now 20 times 400 here, you got 8,000 BTU. We're looking at 7,503 is what we needed. So now you have to decide which one you want. You know, what we don't show you here is these beautiful steel radiators.
Well, what about panel radiators?
Yeah, panel radiators. Panel radiators are some of my favorite. Have you seen panel radiators? The steel panel, powder-coated radiators? The coolest one I saw ever was in Germany when I was over there. It was the railing on a grand staircase that came down and around, wrapped all the way around to the grand floor. It's 2 stories high. And the entire railing on both sides was a radiator. How fucking cool is that? And then in the corner to make up for it, because this ceiling was 40 foot, they had these 6 foot wide ones that went straight up 40 feet. Isn't that amazing? You can get them in any size you want. The only thing that's restricting us is our imagination. The powder-coated steels are great, and now they're available for more than just one person, which is kind of cool. And you can get them any color one. And you can get them in a towel warmer, which is kind of nice. Anyway. So select what you want based on what you need, right? If they already have baseboard, maybe baseboard. Maybe they don't have enough room for baseboard. How many times have you gone in a house where all the walls are goddamn windows? Holy shit, isn't that not a thing going on today? And you go in there and they're giving you this much foot of wall, but you got this much trim. So that means you have this much baseboard. What the fuck are you going to do? Now you got to look at doing radiant ceiling, don't you? Because their floor's already done. You can't raise the floor height. It's going to be different than the rest of the house. Radiant ceiling's pretty cool. And it works great. So you got to be creative in order to get it. Boiler selection. First, we got some questions we got to ask you, right? Yeah. First off was, what was your BTU answer? Right? What was your BTU heat load? The second question you have to ask is what? What's my domestic hot water load?
And it's going to be more BTUs than your heat load.
Most times. Most times. How many temperatures are you going to run out to your zones? Because that's going to determine which boiler you want to get. You know, my little boiler there with the touch buttons can do 2 different temperatures with 2 different priorities. The one with the beautiful touchscreen can do 3. So this might decide that you might want to spend a few extra bucks on the boiler instead of going out and getting a second Techmark control. Huh. Or worse yet, putting in 15 goddamn thermostatic three-way valves, which if you ever do that, please come by, because I have steel-tip shoes I like to wear as I'm kicking you in the ass. Please do not use thermostatic valves unless you have one zone and you're trying to create a cheapism for radiant heat to turn temperatures down. Please do not use them. How much space is available? Mario Andretti. Everybody know Mario Andretti, race car driver? Yeah. I designed his heating system for his new house up in Nazareth, Pennsylvania. Pretty cool. All radiant. All poured floors, too. Yeah. We had this big boiler room. It was a magnificent room. We had 2 500-gallon tanks for chilled water. We had 220-gallon indirects. We had 48 zones of radiant. And 5 cast iron boilers, because this was before we had modulating condensing boilers. We had all this room. It was great. And then his wife says, I need a closet for my minks. So she took a room this size and she cut out, see those boilers down there? She cut out this much of it. And now if you want to service any one of those zones, if it's one zone that's in the back, you have to reach between 4 lines to get back to it, because they're all stacked this way on one wall. If you have to replace boiler number 2, you got to remove boiler number 1 to get it out. If you got to take boiler number 5 out, you got to take 4 boilers out.
That's a nightmare.
Whatever you,
How much room do you have? That's the question, right?
whatever you want, dear.
Combi or heat only? And I will go on right now, on camera, to tell you that I absolutely 100% hate fucking combi boilers. I do. My biggest nightmare, because you motherfuckers always oversize them. Oh, they might want to use 3 showers. Fuck you. You put a 200,000 BTU boiler in that starts at 80,000 BTU, which is 2 gallon a goddamn minute, 70-degree rise, and they can't wash their hands with this pounding shit out of itself trying to wash a fucking dish. Because they might want to take 3 showers at a time. Fuck you, they're not going to take 3 showers at a time. Your dad's going to kick your ass. You don't have a 3/4 water line coming in. Fuck off. Goddamn size them correctly, and I have no problem with it. And let me say this, 60% of my unit sales are combi boilers, so I absolutely love, my fucking pocketbook loves them. But my troubleshooting hates them. All right, or,
Cheaper than an electric hot water heater and a boiler.
absolutely. Or do you want to get heat only, use an indirect water heater?
Your wall hung is awesome.
Thank you. I'm loving that thing so much.
That S20 is
Yep.
I've used it on non-NTI boilers. It's very nice.
You just have to learn how to use an electronic aquastat, which if you ever want to do my S20W with somebody else's boiler, unless it's a Buderus, because a Buderus can take my sensor. Did you know that? None of the other boilers I know of can. But if you want to do it, just send me a note and I'll send you a picture of what you need to use my sensor with an electronic aquastat that will talk to your boiler. How cool is that shit? Okay, anyway, do you need future capacity? You know, I installed a boiler at a buddy of mine's house, a GV6. Anybody know what a GV6 is? Juan McLean? Thank you. 38 years ago, we did this. He doubled the size of his house.
Still had plenty.
Literally, double the size of his house. And I said, I did a heat load on it. I said, well, according to my heat load, you're going to be 40% too big. He says, well, what do I do? I said, you do absolutely fucking nothing. He says, why? I says, because I get to play. If that boiler ever shorts you, if it can't keep up, we'll have it replaced within 8 hours. He goes, oh, yeah, 25 years it ran that way without ever having to put another boiler in. So future capacity, nah, you can. But with cascading, you can always put another boiler in later if it's too small. So how big does the boiler need to be? Of course, you know, you got to look at your heat load. You ever climb inside of one of those guys? You ever clean one of these sons of bitches? Oh, you ain't lived. So how big does the boiler need to be? What's your hot water load? What's your combined load? Do you combine your loads? Do you take your domestic load and add it to your heating load? Do you? And everybody's afraid to answer this, because if you are, let me kindly ask you to stop doing that. Because everything has priority built in right now, and it says, oh no, wait, domestic's calling, I have to turn off the heat. And then when the domestic's satisfied, it comes back on and does heating, and people go, oh my God, I'm not gonna have any heat for an hour? Have you ever turned your heat off in the middle of winter? Have you ever turned your heat off in the middle of winter? Have you ever gone over the top of the steps, flipped the goddamn switch, turned it completely the fuck off and gone to bed? Oh my God, the house might freeze. Fuck you, it's gonna be 62 instead of 72 in the morning when it's 10 degrees outside. You're not gonna miss the heat for a goddamn hour. Oh no, the radiant heat, it doesn't feel, bullshit. Anyway, don't forget your elevation when you're sizing boilers. You know, we need 3 things for combustion, don't we? We need gas, we need spark, and we need air, or oxygen, right? You'll find this out when we do combustion analysis later. But the air gets thinner as we get higher, doesn't it? And if there's less air, there's less chances of combustion, because now we have to turn the gas down or we'd be too rich, wouldn't we? Yeah. When does your boiler fire better? When it's cold outside or when it's hot outside?
Cold.
Denser air. When we were racing cars, if it was below 40 degrees, I'd jet it up pretty heavy because I could run a shitload of fuel in there and gain another 0.3 of a second. Isn't that bitch? Hot, humid day, I'm screwed. I'm dropping 0.4. I don't even have to look at anything. And glycol. Why do I have to worry about glycol?
The heat transfer.
Oh, Rob, what?
It affects the heat transfer.
Ooh, Mr. Cotta, yes it does. Not only does it affect your heat transfer, it affects your pumping because it's thicker, isn't it? It reduces your heat transfer by 15% and increases your head factor by 15%. We'll talk about head here in a little bit, but you have to worry about this. You sons of bitches who are putting in 60% glycol, please, would you leave now? Your glycol should be between 20 and 40, depending on where you are. No more. In Philadelphia, I should be at 20%. I don't need 40%. And you know how many jobs I go out there, they wasted all that glycol and stuck it in there? And if you're not pre-mixing, you're just making a slug. You have water and glycol going around independently. Do you know that? Yeah. You got to mix it first and then pump it in. Son of a bitch. It's called a trash can and a sump pump. Oh my God, I don't have those. Yes, it's not hard. But glycol's a son of a bitch. How did my system freeze? I pumped 60 gallons of glycol in there. Well, it's because you got 60 gallons of glycol and 20 gallons of water. And the water just happened to stop where it was cold.
Well, or you have a leak and you didn't put a glycol pump in, but you let the makeup water replace it.
You know, he says that, and do you guys know, have you ever read the directions? I'm a big lover of this. In fact, I wanted to get this as a license plate, but the state of Pennsylvania would not give it to me because they said it was foul.
Read the manual.
Oh. RTFM first. You ever read the manual for a hot water feeder? For a water feeder for your boiler? You ever read the manual?
Long time ago.
Yeah, never. Why? Because we install them every day, don't we? And we've been installing them ever since the guy said to us, hey, Kevin, go put this in today. And we said, okay, and we went out and we did it, didn't we? It's just 2 half-inch connections, done, right? Go home. Yeah. If you read the manual, it says once your system's full, turn the valve off. Turn the fill valve off. But because we didn't, now we have to put in 911S's with backflow preventers in, don't we? Because you never turned the fucking valve off. So now we have to increase the price by $60 for a goddamn drip on the floor air fucking vacuum breaker, don't we? Backflow preventer. Yeah, thank you very much. Turn the valve off and put the valve handle on a goddamn nail. You know why? Because a homeowner may at one time get Alzheimer's and go down and want to turn the water on the house. Yeah, just do it. Just take the handles off, you don't have to worry about it. But you know if you have a leak because it drops the pressure, doesn't it?
Yep.
Once you drop the pressure, if it's a 2-story house, once the pressure drops below 12 pounds, you don't have any heat upstairs, do you? You'll get a call. If you have if you have a modulating condensing boiler, they all have pressure switches or pressure sensors. Once it gets down between 7 and 12 pounds, depending on the manufacturer, it's going to shut off. You'll get a call. you know you have a leak. God, I could show you pictures. Maybe we'll get to that if we have time. Anyway, which rating? So we give you an input rating, then we give you a thermal efficiency, or an AFUE. If it's below 300,000, it's the AFUE. Over 300,000 is considered commercial, so we have to give you steady state efficiency. The heating capacity, and the net AHRI rating.
Where is all that pipe loss heat going?
If you take 120 and multiply it by 1.15, you'll find out the answer is 138,000. If my boiler is in the house, and my pipe is in the house, and I'm losing heat off that pipe, where's it going?
In the house.
In the house, right? Then why the fuck are we taking 15% off our goddamn boilers? Because the Hydronics Institute says we have to. Fuck you.
Because you put one of the new hot water heaters down there next to it, and it's running an air conditioning mode and
Yeah.
soaking up that heat.
Exactly. Exactly. Thank you. Yeah, where's that heat coming from? Anyway, oh, it's free.
Yeah.
So again, just go through this. 15-degree day at 2,970. And then here we go. 40 degrees, we drop it in half. So again, I ask you, before we go into this, why are we putting boilers in and constantly running them at 180 degrees, which is our design, for our design day temperature, isn't it? And we're running that boiler at 180 degrees all year long. And why are you putting that much energy in the goddamn house?
Love a boost setting.
Right? So, water tube boilers. In a water tube boiler, the water goes through the tubes. It's not a trick question. The burner comes on, and this insulation here is not a target wall. It's to insulate the hot side from the cold side, or the working side to the condensing side. 2,100 degree heat right here, 1,800 degree heat here. The water's coming in from the return here, coming out to the supply here. If this water's moving too slow, what's going to happen to the water?
Boil.
It's going to boil. 1,800 degrees, guys. It gets fucking hot pretty quick, doesn't it? That boiler will go from cold to holy shit in under 10 seconds. Oh, yeah. Then it goes out, then it wraps around here where the cold water from the return's coming in. As long as that's below 130 degrees, it's going to condense, it's going to drip and run down the condensate drain. Cool, right? If you're running the boiler at 180 all the time, you put in a modulating, condensing goddamn boiler and running 180 degree all the time, right?
88%.
You just put in an 89% boiler. Modulating. Ooh. Ooh, isn't that great? And you've cost your customer 14% of their heat, of their savings. Do you know that? And you're beating the shit out of the boiler, and you're going to turn all your PVC venting, which I just so barely want to tell you guys to stop doing, and I don't want to take Rob's pleasure out of this. But if your PVC is turning color, go fuck yourself. I'm starting this now. I'm just getting ready. I'm warming these guys up for Jason for this afternoon. You know? So we're just ramping this up. If you go on a job, do you know the color span of PVC? Okay, so before I started working 100% for a boiler manufacturer, I didn't know the color spectrum of PVC. It comes white, it turns yellow, it turns tan, and then it turns brown. You know what comes after brown?
Purple.
Nope, not yet. Pink. Thank you. Pink, then purple, then black.
And then
And you know what comes after black?
flame on.
This is when I go out and have to do forensic fire work with the firemen to figure out what the fuck you did to jump out the safety so it would do that. And yes, I've seen it in all those cases. The people with the black one, the boiler next to it was black and the pipe was an inch bigger. It looked like marshmallows the way my wife likes to have them. You know, when they get black and gooey and shit. It was an inch bigger than the goddamn connector on the boiler. Isn't that fucked up? The one next to it was gone. It's the first job I went on, then I was convinced that double 5/8 drywall does pay. You know, we all bitch about that, right? Ooh, fire safety walls. Someone doesn't bitch about it because he knows where I'm going with this. It's the only thing that saved this house that was built in the 1700s because the boiler room was outside in this additional room. Otherwise, the whole place would have gone down.
It's like that time you and I were talking about the oil-fired boiler. They put a gas burner in, put a Fernco on top, and ran PVC out the wall.
All gone.
Oh, yeah.
Yeah.
All gone.
Say what? No, we see it every day. Go ahead, tell them, Kev.
Now, 10 years ago, we got a call one night. I'm a fire chief in my town. We got a call, carbon monoxide in the house, well suspected. We get there, the guy says, this carbon monoxide detector doesn't work. He said, damn thing keeps going off all the time. So, we walk in, we're in the first floor, we're not even in the basement yet. My CO2 detector that, because of Steve and.
Yeah, wear one on my hip.
I carry one with me all the time now. It's in my truck all the time. Walk in, I was over 100 parts per minute. There's a foul odor in the house. What the hell is this thing? So we go down into the basement, and
But you put your Scott Air pack on? and
no, we
everything?
walked in.
Okay.
There is a
Personal CO detector.
oil boiler
Carry that
in
on.
the
He's got one
bottom
too.
of the basement.
Yep.
Oil fire. They pulled it out. They put in a Carlin easy gas burner in it. Took a furnace on the top of it, tightened up, and ran PVC up out of the top of an elbow and outside wall. And the guy says, I bought that. They said that if I wanted gas that was high efficiency, I could get a PVC pipe. There was blobs of PVC here, here, here. We took his wife, him, his 2-year-old daughter, and his newborn daughter to the hospital. They ended up airlifting them out to Syracuse because they had carbon monoxide poisoning.
Carbon monoxide, and I don't want to take too much out of Rob's thing, but those of us who have done, I used to train a lot of rescue personnel in scuba, and he does the same thing, but not with scuba. And carbon monoxide collects on your bloodstream just where oxygen's supposed to be and stays there 10 times longer, which is why we all carry these now. And you'll see all of us doing this, right? So Rob carries one, Eric carries one, Frank carries one. I'm sure Kevin probably has one. If not, he'll be getting one. And this, though it says 8, that's 8 months I have left. The new software doesn't do that. This is one of the first ones they had out. So I was told to bring it back and they'll give me a new one. So it says the carbon monoxide. But I'm sitting in a restaurant in an airport. And I have my backpack sitting on the floor next to me. And there's beeping going on. And I'm like, who the fuck's beeping? And now everybody's looking at me. I'm like, uh-oh. I pick up my carbon monoxide detector. It's 195 parts per million in the fucking restaurant in the middle of the airport. And then I heard the fans go on.
Because the sensor ticked them off.
And then it went back, and then it went away. But you want to know something? You know what I did? I paid my goddamn bill and left.
Yeah.
I ain't sitting there for that shit.
And
I got.
about the fly where you're going to
Yeah.
get less pressure.
I get into a taxi at O'Hare Airport. Yeah, I do a lot of flying these days. And my fucking carbon monoxide goes off. It's 115 parts per million inside the cab. I said, open up the goddamn windows. Says, it's cold outside, sir. I said, let me ask you this. You can either stop or open up your fucking windows. So I opened the windows. And then I continue the conversation. Do you have a headache when you go home?
Everything.
Are you sometimes nauseous a little bit? Are your fingernail beds a little bit redder than normal than your wife's? Do you have confusion sometimes? Maybe get a little vertigo? I carry these everywhere, even up in the attic for doing air conditioning. You know why? It's at a job 3 stories up. The exhaust pipe of the condensing boiler comes out and the soffit's right here. You know what wasn't above the pipe anymore? The aluminum soffitting was worn out. And all that carbon monoxide is going right up in the attic. And so now you go up there as an air conditioning guy not carrying one of these because we're doing air conditioning. There's no heat, blah, 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 blah. Tankless water, all of them have combi boilers in this particular development. And you go up there and you're like, oh man, this 120 degree heat's really getting to me. It might not be the heat, bad.
Yeah.
I carry these everywhere. So clip them off, I have them on my backpack. I get to a job site, I take one of them, I put it on. Why do I have 2? Well, because I'm testing them for 2 different manufacturers, and I really like the Citron. Not because they're here today, but because I do really like it better than the other. I could have trashed anything I wanted, right? Exactly. Anyway, they're good for 2 years and you throw them out. Let's get back to this. Fire tube boilers. This is what a fire tube boiler looks like. If water goes through the tubes in a water tube, what goes through the tubes in a fire tube? It's not a trick question. Fire. Burns here, still burns out. Goes in, starts to circle, goes down through these tubes where the water comes in here, swirls around, comes up, gets the hottest point and goes out to the supply. But as it's coming in, because it's coming down the tubes, it's cold water coming in, it's chilling the tubes, which is making it condense inside the tubes, which washes the carbon out the bottom. Which is why we say that a fire tube boiler needs less maintenance if it's set up properly and if you're using outdoor reset, because it will wash that carbon out. Who was the first person to have a fire tube boiler here in the United States? Triangle tube.
Yep.
They came here and they took 60% of the market overnight. You know why? They did it on 2 lies. Never needs maintenance, never needs primary, secondary circulation. Both lies. Today, their installation manual says best practice is primary, secondary circulation, and best practice is every year go out and do a combustion analysis, and if your stack temperature ever gets close to 30 degrees over your supply temperature, it needs to be cleaned. See, a water tube boiler needs to be cleaned every year inside the combustion chamber on propane, every 2 years on natural gas. But on a fire tube boiler, you just do a combustion analysis and check the supply and the stack temperature, and if it gets close to 30 degrees, you need to clean it. Huh. Might be never. Might be tomorrow. So outdoor reset, when it's 70 and 70, you don't need shit, but as it gets colder outside, we raise the temperature going out to the system. Does that make sense? That's outdoor reset. You know what we build into our boilers so you don't have to disconnect the outdoor sensor anymore? Y'all done it. Anybody who works on modulating condensing boilers has gotten that phone call 10 o'clock on a Friday night going, my heat's not getting hot fast enough, because they won't leave the thermostat alone.
Yep.
And so you guys go out and go, doink, disconnect the outdoor sensor, now thinks it's 0 degrees outside, runs 180 degrees all its life. That's great. But now we've built boost into all of our boilers. We always have, but now we have AI boost.
Oh, what's that doing?
So AI boost says for every 10 minutes of call, it's going to take this curve that you set up, it's going to raise it 10% if it calls for 10 minutes, but it's going to drop it 1% for every 10 minutes it doesn't call. Because we're afraid to set them down where they're supposed to be. You know, if you set your radiant temperature the right temperature, your circulators should never shut off going to that radiant heat and the people should never be cold. Did you know that?
It's perfect.
But no, do we ever set it at that point? Said no man ever.
I've got a Magnum circulator that turns on at the beginning of heating season and never turns off. Period.
But most people, the design temperature for that radiant heat was 130. You set it at 140, so it'll never shut off. But now it cycles all the time. Yeah. If you were good, you'd go back and reset it if the people were too cold. And you'd be going at 120 instead of 130 to see if they would live there. Huh. Saving the temperature. Anyway, creating the equilibrium. So as it gets colder and we need more energy, we send more energy out. Who the fuck came up with 180 degrees? And who the fuck came up with a 20-degree delta T between supply and return?
Some baseboard manufacturer.
Nope. You know what they did when they wanted to get rid of steam boilers? You know why we wanted to get rid of steam boilers? Coal-fired steam boilers. You know why they wanted to get rid of them? The explosions. See, we didn't have automatic feeds back then. In the late 1800s, only the rich people had them, and mom would go down there and shovel half a shovel coal and half a shovel coal every few hours. And Dad would come home on Friday and wanted to drink beer, and she'd say, well, now you got to feed that thing coal. And he'd go down and open the door and fill that motherfucker till you can fit another goddamn pelt in there and close the door. But now they have no heat, but they got plenty of fire. Why? Because all the water's gone, because he forgot to fill the water back up. So he goes down and turns the valve. You know what happens to glowing, hot, melting cast iron when you hit it with cold water? And if you go back and you look, or you go to Dan Holohan's heatinghelp.com site, you will find all sorts of clippings of boilers blowing up and going through 3-story Victorian homes and always landing in a parking lot or a school playground.
Next to the water heater that did the same thing.
Never did we ever see one that said it went through another house or landed on the Wicked Witch of the West. Ever. But so we said, okay, let's make this safe, so we're going to do it with hot water. We're just going to fill them with hot water. But we designed it to 212 degree steam, so you got to have 212 degree water. Here's the problem. We didn't have a system to be able to handle the temperature coming back for seals on circulators, so we put them on the return. So if you want to know why we have circulators on the return today, not where they belong on the supply, it's because of that, because that's where we put them. Son of a bitch. But here's the problem. You're running the water at 212 degrees at 14 pounds, and some asshole goes down and turns the draw off open. Goes right to steam, don't it? Flashes right to motherfucking steam. So I said, maybe we should turn that down. So they went to 180, didn't they? and dropped it to 180 when nobody ever said, oh, my house is too cold. Said no woman or man ever in a house dropping their temperature 30 motherfucking degrees on their aquastat.
Because it was 5 times oversized to begin with.
And now the circulators can handle the temperature because the return temperatures come back at 160 degrees and the circulators are lasting longer and everybody's happy and all things are good. Wow. That's how we come up with 180 degrees. But why the fuck are we sending 180 degree energy out there when it's goddamn 70 degrees outside? Everything you put in can handle outdoor reset. Did you know that? Everything you put in. If there's one person in this room who says, well, you can't do it with cast iron, I'm going to politely tell you, go fuck yourself again. Why can't you do it on cast iron? This is the reason. You shovel snow, you come in to have lunch, you put your gloves on the radiator, you have lunch. And for your entire life, you come back and they're hot and dry and you go back out. But now they're just warm and wet because you're only sending 140 degree water temperature out because it's 35 degrees. Oh, fuck. And that's why people don't want to have outdoor reset on cast iron radiators. Oh, my child's going to burn themselves once. How many times do you touch a pilot light or hot radiator and do it a second time? This is called natural selection. Maybe you should have touched it a third time. Right? Where aren't we going to condense? Heating up a pool or doing domestic hot water production. I love taking snow melt boilers, holy shit, 99% efficient, 135 degree water coming out, 60 degree coming back. Holy shit. By the way, do you know how much condensate will come out of a condensing boiler when it's condensing?
1 gallon per 100,000.
1 gallon per 100,000 per hour. Fuck you. Isn't that great? And as we move up the ladder, here we go. But people put these things in to do pools and spas with heat exchangers. And I go, well, why don't you put snow melt in? Or do snow melt and heat your pool in the summer? Keep that boiler working all year. It's just another heat exchanger. High mass radiant floor, that would be poured floors, cast concrete, staple up radiant floors, cast iron radiators, fin tube baseboard. Fin tube baseboard works by convection, doesn't it? Cast iron radiators work by radiation. Cast iron radiators are 90% radiation, 10% convection. Baseboard is 80-20. 80% convection, 20% radiation. 90% convection, 10% radiation. Think of this. The cold air comes across the floor, goes through those fins, and up it goes, right? 180 degrees. 180 degrees gives you 600 BTUs a linear foot. You drop that down to 130. Now all of a sudden that temperature of that tube is closer to the room temperature. The air doesn't move so fast, and you cut it in half. So it goes from 600 to 300.
You put carpet up underneath that one that wasn't.
You're kind of fucked, yeah. You block the hole, it doesn't get air. But when you go from 130 to 115, it drops in half again because you're getting closer to the ambient temperature. It's not a linear curve like our outdoor reset curve. It doesn't do this. We don't drop the temperature and the BTU follow. It goes down and goes loop. At 115 degrees, it's kind of like water expansion. If you're only heating water to 130 degrees, it doesn't expand for shit. From 130 to 150, it expands like a son of a bitch. So that's why on radiant heat systems, we can have all this goddamn tubing and all that water out there, but we're only heating it to 110 degrees. You can put a little number 30 in, where you'd normally be putting a floor mount 90. If it was baseboard, we don't have to worry about it. Anyway. Just because you see condensate coming out the drain doesn't mean it's condensing. Could be condensing in the flue too, couldn't it?
Depends on how your exhaust condensate is piped.
You could have your flue going up through the chimney and it's condensing in that and it's coming back down. But let's say the boiler's cold and hasn't been running and there's still condensate coming out. What's your problem?
Got a leak.
You shagged the dog. See, our boilers love outdoor reset to keep them clean, but that's not how we make the bulk of our money. We make the bulk of your savings off of modulation. Do you know how modulation works? How many steps does a cast iron boiler have? How many speeds?
1 and maybe 2 if you put a really expensive burner on it.
Oh, yeah, you can call it 2 because one's off and one's on, right?
There is actually a control where you can actually modulate big
Yeah,
commercial
big
gas
ones.
boilers.
Yeah.
Big commercial, but we're getting way off the track. So,
Sell PowerPoint.
do you know the gas valves on a condensing boiler are male? And on a non-condensing boiler, they're female. Do you know that? Cast iron boiler, they're female. Because when you energize a gas valve on a atmospheric cast iron boiler, it gives you everything you don't want immediately. Right? Just like your wife sometimes. But on a condensing boiler, when you energize it, you know what it does? Just leaks a little bit. Because we use these things called venturis that attach to this. And we attach a venturi here, and then we attach a blower to it, right? And the more we pull on the vacuum here, it goes through this hole, right? All the air through that 4-inch pipe comes through this hole and comes out the other side, and it's much bigger, which drops the pressure, which sucks the gas out, right? So the faster we move the air, the more we suck, the more gas we get. Does that make sense? Hence the reason this doesn't work if you're not sucking with this. Does that make sense? You sons of bitches are always replacing the motherboard and then replacing the blower, and you have no idea what the fuck you're doing, because then you call me up and go, hey, Wheels, can I get the $800 for that motherboard because I didn't need it? You know how you troubleshoot one of these?
Unclip the back.
Well, do you see it has 2 sets of wires going to it, eh? Fat ones and little ones, right? Fat ones and little ones, you see that? See the fat ones and little ones? Fat ones are big electric, little ones are little electric. We can be really terminal here, right? We should only be sending our boiler 120 degrees, 120 volts. If you send it 240, you let all the smoke out of everything. Ask the Pennsylvania Petroleum Association's Technical Education Center. Their electrician came in and wired 240 volt to 8 boilers and let all the smoke out of every single one of them.
Magic smoke gone, no good.
Anyway, so this is attached to the blower, right? This is attached to the burner tube. This is the venturis built into this one. The gas valve's underneath this, right? So far, so good? So you go out to the job, and the first thing you do is you remove all calls for heat. Remove all calls for heat. Turn the domestic water off if it's a combi, and remove the hot water. Remove the wires coming from the thermostat. So far, so good? On my boilers, it's just pull the Molex. The next thing you do, you take your hand, your best friend on a Friday night, and touch the fan. If the fan's running at 100 RPMs, which I can't hear because I'm mostly deaf, ask my wife. If the fan's running, you need a new fan because it should be off. Next thing you do, you remove the low voltage wires.
The more power, the slower it runs.
When you remove the low voltage wires, you're no longer feeding it a DC voltage. And it says, uh-oh, you want me to run at 100%. And this should run at 100%. If it doesn't run at 100%, when you remove those, you check your high voltage wires and see if you have 120 volt to it. If you don't, then you check your fuses. If your fuses are good and you don't have 120 volt, you need a new motherboard. If you have 120 volt and it's not running when you remove those, you need a new blower. These work by pulse width modulation. You want to have some fun? Come up to my office in St. John and ask my head engineer, Jason Thompson. Jason, could you explain pulse width modulation to me? You'll be there for 2 hours, and within 15 minutes, you'll be doing what I was doing. Because you have no fucking clue what this guy is saying. None. I asked him after that, I said, Jason, I'm a plumber. Could you put it in plumber's terms? He got up, he walked over to the light switch, and turned the lights on and off. And then he did this. He did the jazz hands. He did, I'm pulse width modulation, which for an engineer is pretty goddamn funny. Because engineers aren't funny. Notably, they're not funny people. The more I remove the DC voltage, the faster the blower will run. We talk about our boilers being 10-to-1 turn down ratio today. By 10-to-1 turn down ratio, that means that 150,000 BTU boiler will fire at 15,000 BTU. Does that make sense? 15 divided into 150 is 10. That's 10-to-1 turn down ratio. It's not 10 stages. It's 3,500 stages, because that's the number of RPMs I can increase and decrease this by speeding up and slowing down the amount of DC voltage that I pulse into it. I remove it completely, it's 100%. I put it in completely, it's 0. Now you take your chances in between. Isn't that cool? It's no mystery. You guys look at these things, you go, oh my God, what do I do? Fuck you. It's easy. It really is easy.
And there's a video.
And it is on my YouTube. One of the biggest problems I have today.
Ooh, those things.
Max Venturi's?
Brass one or stainless one?
No, I had the one stuck. To get a 10-to-1 turn down ratio, we now use these for Venturis. See, this has no moving parts. Does that make sense? 5-to-1 turn down ratio. 10-to-1 turn down ratio. There's an up spot on this. Has a flapper here and a flapper here. Flapper here, flapper here. There's an orifice on the top, orifice on the bottom. At low fire, it pulls from the orifice on the top. At high fire, it lifts those little flappers and it pulls from the orifice on the bottom. Isn't that cool? Problem is that front flapper, I find, gets stuck and you can't adjust your combustion, which we'll be talking about this afternoon. The other thing I find is if you don't have your post-purge time on your fan running long enough and that shit's coming back in, it'll block up the top one because it's at the top and the NOx comes in from the pipes and comes back to the boiler and goes in here and says, oh, I can't go lower because the flapper's in the way. Goes to the top one and you pull this out and it looks like a spider has made a web in here. Blocks the whole thing up. And you see that through your combustion analysis. Pull them out. You can clean them, but I suggest, 10 o'clock at night, I'll clean it. 8 o'clock in the morning, I'll go get a new one. Or you get a toolbox that has it in it already. Anyway. How's that for having a little fun on technical? Now, why do we do this? Why do we modulate the boiler? Remember my house, 157,000 BTU, I need 42, right? That means my boiler was 3 times the size it needs to be. Atmospheric, modulating, condensing. You know I can't call that ModCon? I can now. You know why? Because we bought HTP. Okay. And they had trademarked the word ModCon. So now we own it, so I don't care. ModCon boiler, cast iron boiler. 1972 IBR book. Said if my boiler's running 3 times the size I need to be, I'm running at 39% of its rated efficiency. See, when I first got in this business, I didn't know that it was 10-to-1 was 3,500 stages. I thought it was 10%, 20%, 30%, 40%. I was wrong, wasn't I? It's infinite because we have thermistors in there that say, oh, my temperature is this, my temperature is that. Oh, I got to adjust my flame and get a little higher because I want this based on outside temperature. And it just modulates itself. Off it goes. It's just having a great time. But if my boiler's 3 times the size I need it.
But oil 68 cents a gallon back then.
Oh, true. But think of this. My boiler will run.
With airplane mode.
My boiler will run between 89 and 95% efficient. Unless I'm returning really cold water, then I'll go up to 99% efficient. But in normal applications, 89, 95. And here's a question I had as a wholesaler way back when. How the fuck can I sell a boiler at 3 times the price of a cast iron when I'm comparing 84 to 92%? Because back then it was only 92, right? Now we're 95. But let's go 84, 95. For 10% more efficiency, or what would be about $200 a year in fuel, how can I sell a boiler for 3 times its price? But see, what I didn't understand is when it's 3 times the size it needs to be, let's just go twice, I'm running half its efficiency. Now all of a sudden my 84% efficient boiler, when it gets to be 39 degrees outside my area, is twice as big. If it was exactly the right size at 14 degrees, which it never is, but if it was, I'd be running at half its efficiency or 42%. So I'm now considering to tell you that when you sell a condensing boiler to someone with an atmospheric boiler, you can tell them we're not comparing 84 to 95, man. We're comparing 89 to 42. Because don't we spend over 70% of our winter over 39 degrees, which is half of our heat load? Aren't we? So why the fuck are we selling these huge boilers? It's great money, but you're just costing them money. You're costing them fuel. And you can charge just as much and put in a smaller boiler and save them more energy, and people are happier and everybody's living well. But now we have to consider domestic hot water applications, don't we? You know, I ask these questions to guys who are looking for a boiler sizing, and I say, well, what's in the master shower? And they go, I don't know. I said, do you understand that as a heating guy, you can walk anywhere in that house, right? You can open up any drawer, look behind any cabinet, you can go into any closet because you're trying to fix the heat, and to them it's a mystery. You understand that, right? As a plumber, they understand plumbing. That's the pipe that goes in, and that's the ship pipe that goes out. See, people know that, but heating's a mystery to them. But you go to the master shower and you look. You see what the hell they have.
I was a Kohler wholesale. We sold a lot of those.
Yep. Where's possible indirect best option? If they have a shower like this one, you got to go for a tank. Any large load.
Tanks.
Notice the Whirlpool tub. If you don't fill that Whirlpool in 10 minutes, the candles have burned out, the wine's drank, and the person you were going to get in there with is in bed already, saying, go fuck yourself. Or they're in watching football in the other room.
Depending on which sex you are, yeah.
We need to fill this in 10 minutes. It's what I refer to as the 20-minute dump, and that's not something you do at 5:30 in the morning. I could be if you're taking a shower at 5:30, but the 20-minute dump. You need to know your dump volume for a 20-minute period. Period. That means if I'm going to fill this 80-gallon pool and I'm going to take a 10-minute shower, I need a 120-gallon tank. But if you're going to sit in the tub for 20 minutes and I can go down, if that's an 80-gallon tub, I can put an 80 in because you're not going to jump in the shower right away. Does that make sense? Oh, now we have to talk about people and how they live. Holy shit. Well, I could have all my children over and we all want to get showers at the same time, and I might be in the hot tub at the same time, and maybe I want to do my laundry at the same time because God knows my kids bring home laundry, and I just fucking kill me.
How many indirects?
But this is the questions we have to ask. We're no longer, just like radiant heat, we're an integral part of the building, aren't we? And what's the worst thing you could do? Put something in and not give them what they want. Because now you're a shyster. And now they want their money back. And they call me and they say they want their $25,000 back for a $2,400 boiler. And I go, well, ma'am, my boiler's not worth $25,000. That's what it cost me to install it. Welcome to Manhattan. 150 combi, $2,500, $25,000.
Nice. Of course, you did have to hire 2 guards to watch your van out on the road while you.
You had $500 a day in just tickets. So this is a great ASHRAE chart. It is a great ASHRAE chart. This tells you got to add all this shit up. I'll be honest with you. Said no man for a residential job ever. Commercially, you should do this. You know what I do commercially? Okay, little secret. When I'm doing a commercial job, I go to www.bradfordwhite.com. I go to their right spec program for domestic water. I go down and I pick what I have: dormitory, gymnasium, laundry. Right? You pick what you want, then you fill in all the questions. It tells you how much you need.
State has the same one.
Yeah. I just like that program because it's written by RightSoft, and I happen to love RightSoft. But you can do it the hard way. You can do it this way. And they all work. You can go to A.O. Smith, use their program. You'll be 40% oversized. You go to Lochinvar, you'll be 35% oversized. You go to Bradford White, you dial in what you want for making sure that it's okay for domestic hot water. By the way, that's my S20W with a FTVN and the quick hookup kit. Well, that's pretty cool, right? 45 minutes on the wall. It's what I like to call my fuck you tank. You know why I call it that on that kit? And one of my top contractors calls me up Friday at 1:30. I pick up the phone. He goes, fuck you, Wheels. Not like it's not the first time I've heard this, right? So I said to him, fuck me what, Tom? He says, fuck you, I didn't believe you. You said it was going to take me under an hour to put this shit on the wall. It took 45 minutes.
Yep.
Fuck you. So what's the problem, Tom? He's 1:30. Finish the job. He says, you don't understand. I didn't believe you. So I left all the shit I need to finish this job at home. I said, okay, so go home and get it. He says, I'm an hour and a half away. I'm not finishing this job 4 o'clock on a Friday afternoon. I'll come back Monday. But I repeat, fuck you, Wheels, and he hung up the phone. We're still friends today. We've been working together for the last 10, 15 years as contractor, manufacturer, and wholesale.
And the bracket they send you for the top exactly matches the spacing for the headers.
Yep.
On the bottom.
We give you a template, the whole thing works. But so showers at 2.5 gallons a minute, washing machines 10 gallons, washing basins, blah, blah, blah. I'll tell you this. You can follow these instructions, and I'm going to tell you right up front. Get the number of gallons a minute it's going to take for a shower, or her shower, the master bathroom. 10 gallon a minute rain head. That's the ones without the nozzles, right? The new ones with the nozzles are like 5. Body sprays, 1.5 gallons. Add them up. Regular shower head, 2.5 gallon a minute. And you multiply that by 20 after you add them all together, and that's what you need for a 20-minute dump. That's the size of recovery you need, or storage you need. Whirlpool, working gallons of the Whirlpool, that's the size of your tank. Well, why the same size? Because you're going to mix it with 30% water, and by the time you get down to 30% of the tank, it's already cold. But you get the top 70 hot that's mixing with the cold that's going in the tub. See what I mean? So it always works out 1 for 1. 110 gallon Whirlpool, 120 gallon tank. 85 gallon Whirlpool, don't put an 80 in, go 120. Does that make sense? All right. So house is a 50 gallon hot water tank set to 140. The incoming water is 50 degrees. Showers, faucets are mixed to 105. How much usable hot water is available? 105. How many people have done this where we've put a tank in, and because it's too small, we raise the temperature to 160 degrees and put a 3/4 thermostatic valve on the discharge, don't we? Right? Now I'll tell you this, that there's a lot of shit about storing our water at 140 and should be to keep Legionella away, isn't there? Legionella was invented in Philadelphia. We're very susceptible to this. I don't put in water heaters without putting it at 140. And then I put a mixing valve in. And if I'm in Maine, I also have a backflow preventer, a vacuum breaker, and an expansion tank. So we'll just add another $300 to your 800 gallon tank, right? Plus the installation. But anyway, how much you get? Well, it's easy. The volume of water is 50. You're storing it at 140. You got 50 degree coming in. You want 105, so you just take the 50, you take the 140 less your incoming, 105 less your incoming, you multiply it out, and you've now taken a 50 gallon tank and made it 82. Isn't that cool? Come on, that's pretty neat. Take a picture of it if you want, because you're going to use it. All right. Uh-oh, wait, I'll get back. I'll get back there in a minute. Give me a sec. Nope. I went too far, didn't I? Nope. I gotta go back. Give me a second. I'll get it for you so you can take a picture of it. There we go. I got all excited and pushed the button too long. I did that one time. I was working on one of my boilers, and there's an orange cable that goes to the igniter on the TFT boilers. There's an orange cable that comes down long. Don't ever have the thing firing and hold on to the stainless steel pipe while you have one of these remotes in your hand, because you'll go through 35 slides. I was like, fuck! And by the time I got my hands off of everything, it was like I had no idea where I was. I just started over. Anyway, so there's your rules of thumb. This is how to get shit and add it up. I think you guys understand the whole theory of how to add up your demand, right? Anybody not understand it? Good.
Now you take that and you add that to your heating load.
Yeah. So this gives you the universal BTU GPM times delta T times 500. That little triangle T is delta T. That's just your difference in temperatures. That's all it is. So all of our tanks give you rating charts like this. So you have 1 hour, your first hour usage, right, at 140, 115. Then we give you continuous. If you notice, the continuous is less the amount of storage, usable storage in that tank. That's all it is. That just means that if you ran that out of hot water and it was continuously running, that's what it would give you. I just want to point out one thing here. If I look at my continuous flow rate of an S20W wall hung tank and compare it to a 60, pretty fucking close, isn't it? Isn't that cool? Come on. But if I look at here, look what happens. See the difference? See, with 60 gallons of storage, I gain another 35 gallons of first hour, but on my continuous, I'm less on a 60. Is that cool? The 20 gallon indirect is kick-ass for a family of 5 with 3 bathrooms and no all standard shower heads and all that shit. Here's the problem sometimes. Frank was talking about selling Kohler. Kohler has this add-on thing that you take the bathtub faucet off, you know, the bathtub spout, and you put this shower tower in, and you put it onto the bathtub. And it runs at 10 gallons a minute. which no combi will ever keep up with, right? Because that's just physics. 45,000 BTU will give me 1 gallon a minute and 90-degree rise. So that means a 110 will give me 2 gallon a minute, a 150 will give me 3 gallon a minute, and a 199 will give me 4 gallon a minute. Was that right? 3, 4, and 5 actually is what it is. 3, 4, and 5. 3 at 110, 4 at 150, and 5 at 200. That's a 70-degree rise. If it was 90-degree rise, take it down a gallon. You can't fool physics, and it doesn't matter whose combi you're using. I don't care if you're a Navian, a NI, an NTI. We're all within 0.1 of each other on combis. When it comes to indirects, we kick their ass. Sizing pumps. Isn't this fun? Pressure drop is head loss. That means how much restrictions on that tubing, how fast you're trying to move, and how far is it going to go. Dan Hollihan would like you to believe that he wants you to put a bowler cap on and become an English guy and go walking through, because it's a British thermal unit. That's why he uses the guy with the bowler hat. And go through the pipe and figure out where you're going, how much restriction there is, right? Flow rate's your GPM, or how fast you're going to move the water. So now we have to worry about the size of the pipe, the length of the pipe, the number of elbows, T's, fittings, valves for flow restriction. That gives us head. And GPM, which is based on BTU. Please note, I said nothing about head factor. I love it when I say, well, how much head do you have? And I love this answer. Oh, it's a 3-story house. It's got nothing to do with shit except for static pressure, doesn't it? Because I know in a circulator, if there's no pressure at the top floor, I have no flow. So that means a 3-story house, every 2.3 feet is a pound of static, whether you're a 1/2-inch pipe or a 400-inch pipe. Every 2.3 feet is 1 PSI at the bottom. And I have to overcome that to get up there, which is why in a 3-story house we run an 18-pound system. Interesting. Flow rate, GPM. To properly size a circulator, we need to figure out both of them. You know, I'd love to kick Kevin Dennison right in the ass for this one. He came out with this TRX and the FTVN, my 2 residential boilers with an internal pump, and said, you don't need to have primary or secondary as long as you don't need anything more than 6 gallon a minute, 9 feet ahead. You know how many problems I have with people on over temperature on that unit because they have no idea how to figure flow and head? This is why we have TACO after dark. This is why the guys at Emerson Swan do TACO classes so you can learn them. This is why you can go to TACO, which is right around the corner from my New Bedford plant, my New Bedford training area, and go to TACO for 2 days and learn about pumps and how to size them correctly. This is why when I'm on a job, I carry a B&G system sizer. Anybody ever use a B&G system sizer? Never? It's a dial. It's just a wheel. I should have brought one with me. And I can walk onto a job and figure out your head loss using it. It's amazing. Charts like this tell you how many linear feet that every fitting is worth. Isn't that fun? And you can sit there and figure it all out, or you can just take your length of run and multiply it by 2. That's that little quick chart to do. I multiply it by 1.5 if I know the place. But you can just take your total run. That means going out, going across, coming back, every drop between the floors and coming back to the boiler, every piece of straight pipe added up. And if it's 200 feet, if you want to add all the fittings, I just make it 400. But you can do it the long way and come up correctly.
CV factor.
Why I hate 3-way thermostatic valves. Remember I started today with that? Remember I told you guys that if you're installing more than one of them on a job, I'm going to briefly kick you right in the, I was going to say balls, but I said ass. So, because it was early in the morning. You know what CV factor is? That's the flow rate at 1 PSI drop. 1 PSI is equal to 2.3 feet ahead. Do you know if I double the flow on this, so this is saying that it's CV of 8. Now you can read all this shit, but let me put it in your terms. If I take this 8, which it isn't, because a thermostatic valve is 2.6 on a lot of them, so the CV factor equals 2.6. And if I want to get 5 gallon a minute through that, that's going to multiply that by 2, right? Does that make sense? So now my flow rate's going to be 5, which equals 2 times that. But you know what happens to my pressure? Which means that now I have 4 pounds of pressure drop, right, instead of 1 PSI. 4 times 2.3 is what, 9.2. Now I have 9.2 feet ahead for just that one fucking item. 9.2 feet ahead for that one item. Interesting. Figure out your length of run, all your fittings come through it. This is just, I don't know why we ever put this chart up here with the types of copper, but the thicker the wall, they're all the same outside diameter. You can get different pressure drops for each one. We mostly use M, don't we? Sometimes use L. Some places require to use K. I haven't seen K copper on a heating job ever. I've seen M and L, and usually the L's only there because the guy didn't want to run for a stick of M and he already had a piece of L in the truck.
Or some engineer was specking.
Yep, true. So this is just the head factor because it's smaller diameters. You add it all up, 15 elbows times 2, 30 feet, 4 ball valves, 8.5 feet, 150 foot of copper, you add it all up. Equivalent of 89 feet. So now you go to your 4 GPM at 189 feet and you find out your pressure drop per 100 foot. Actually, that's per foot on this one, per foot. So you take 189 times 0.016 and you have 6.9 feet ahead. Now add your 3-way thermostatic valve at 9. You have 15 foot ahead, which means you're putting in a 009 $300 pump instead of a 007 $200. So there's these wonderful charts for flow and velocity. And you can see that each one has a place to stop, doesn't it? Because you don't want the velocity to go over 12 feet per second, which is a pressure for pressure piping for domestic. In heating, we never want to go over 4 feet per second. Why?
Laminar flow.
Laminar flow, but how's that equate to us in the living space, Frank?
Basically, it puts the skin on and you don't transfer the heat to the outside of the pipe.
Doesn't transfer the heat, but it also gets noisy. If you go over 6, it gets real noisy, 6 feet per second. That's just showing you where the velocity falls in so you can start to look on our previous one where you want it to fall into on the 9 gallon a minute. The universal hydronic formula, or why we came up with a 20-degree delta T. Right? Don't we always use 20-degree delta T? And if you go to my chart for my boilers, we have 20, 25, 30, 35, don't we? So you can adjust the size pump you need based on the boiler and what you can put up with a delta T. But in the house, we go 20. Why 20? Because the difference in output of temperature for 20 degrees through the first piece of baseboard to the last piece of baseboard at a 20-degree delta T is almost minor change. Almost insignificant. But the 20 was easy because if I take this universal figure between the gallon per minute equals BTU divided by the difference in temperature in 500 degrees, which 500 degrees is nothing more than the weight of water in BTU, right? And I put it all together, I know that 1 gallon a minute is worth 10,000 BTU. Isn't that easy? 1 gallon a minute is worth 10,000 BTU. If I double the delta T, what happens to my flow? If I double the delta T in temperature, I go from 20 to 40, what happens to my flow? What can I do? Cut it in half. It's linear. Does that make sense? I want a 10-degree delta T because I'm doing radiant, I have to double it. 1 gallon of water weighs 8.33 pounds times 60 minutes, which actuals 499.8. So if you want to know where the 500 comes from, that's where it comes from. Does this is something that in the hydronics world comes up every single day, the universal hydronic formula, blah, 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 blah. And as a plumber, I can do it by sight. If I have a 20-degree delta T, 1 gallon a minute is 10,000 BTU. If I have a 25-degree delta T, I'm not moving fast enough, am I? Right? If I have 10-degree delta T, I'm moving too quick. And you know you guys always put in the wrong size motherfucking pump.
Most of the time, the delta T doesn't hit the 20 because we're over pumping it.
Yep. So, all sorts of boilers, all sorts of circulators are available out there, right? We have delta T pumps, we have delta P pumps, we've got multi-speed pumps, we've got single-speed pumps. So this pump will only give you 2.5 gallon a minute each. Then you got this one that has 3, 2, and 1 on it, and that could equate to 3 zones. This one can variable its speed, and this one goes by delta P, so it can do whatever it wants and dial it in. Today's pumps are not your $29 007. Do you know in 1972 I was selling 007s for $29 and making money on them? Ain't that a pisser?
2000, we were selling them at $70 and making money on them.
Yep. So it's quite amazing. So how do you decide what pump you use? Well, first let's see what size pipe you use. This is my quick and simple chart for tubing. 1/2 inch is good to 2 gallon a minute. 3/4 is good to 4. 1 inch is good to 8. 1.25 is good to 14. Are you guys following this along? I'm doing this by memory. 1.5 is good to 22. Have I missed anything yet? This is what you do for sizing your tubing to make sure your velocity is right and make sure your head factor is within our terms that we want it. How does that change for PEX?
Slightly smaller diameter or internal diameter, so you get less, you get a higher head.
I specify a job so the duct coil is in the attic. 1 inch copper running to it. Right? So far so good? A duct coil is a lot of little tubing running through a fin tube, isn't it? And the motherfucker put 1 inch PEX in it and says he's not getting enough flow. And I said, you're right. I said, what do you mean?
Put a higher head pump on.
I said, what 3/4 PEX is, 1 inch PEX is equal to 3/4 copper. That's the difference between 4 gallon a minute and 8 gallon a minute, the head factors we're looking for. That means you just fucked yourself. He said, well, the drywall's already up. I can't change it. What do I do? I said, I sell you a bigger pump. I make more money. We take the old pump back. No, you keep it as a spare, as a remembrance of today. Do not create a cheapism and be stupid, right? Anyway, 2 to 4 gallon a minute, 3/4 pipe, 4 to 8, 1 inch, 8. Do you know I have a whole segment in my area that all the baseboard and all the tubing run for their hydronic heat is 1/2 inch?
Really?
They're all slab-built homes. They're under 1,000 square feet, and there's 4 zones. They don't need more than 1/2 inch. You ever buy 1/2 inch baseboard? You know the output per foot's actually more on 1/2 inch baseboard? Do you know why?
Bigger fins,
Fins are bigger. Yep.
but you can't run as many feet of it.
No,
up
you
on.
can't. You're absolutely right, Frank. Thank you. Anyway, keep it under 4 feet velocity. Here's your PEX, right? 3/4 inch, I said goes to 4. Nope, not in PEX. 2.76. Ain't that a bitch? See, if I want to get 4, I got to go to 1 inch for 3/4 inch. I got to go to 1.25 to get 1 inch, don't I? Son of a bitch. Now let that just open up your eyes a little bit that you just can't exchange PEX for copper. You can't do it. I love PEX. Don't get me wrong, when applied correctly. I love people who put in 1,000 foot of 1/2 inch PEX on radiant heat without a break, and they want to know why it won't flow. But it came, thank you, came in a 1,000 foot coil. You gotta love it. Velocity above 2 feet per second will carry air through it.
But that's what you learn if you put two circulators nose to tail, you can double the head.
Yep, yes you can. We won't get into that. We're not going that far today, Frank. Select the pipe diameter between 2 and 4 feet per second. If I'm moving it too fast, the air just goes. Now this is why we came out with microbubble air absorbers. You might call them a spire vent. You familiar with microbubble air absorbers? You know how a microbubble air absorber works? Do you?
Bigger volume, slows it down.
Absolutely, some of it.
And
But when the water comes in this direction and goes into a vertical piece of pipe, it spins, doesn't it? It creates a vortex swirl. The vortex swirl drops pressure in the center. Okay, in a hurricane, where does the test pilots fly? On the inside or the outside of the goddamn hurricane to test the pressure? Where do they fly? Do you know? The F-15s go down through the center where the pressure is dropped, and that's how they measure how big the goddamn hurricane's going to be. Well, you drop the pressure, the air comes out of solution. The air comes out of solution. Inside the spire vent are all these little cages, right? In the Takeo one, there's balls. What do they call them? They're little pieces of stainless steel wrapped. Anyway, it doesn't matter. It's a place for the air to grab onto and climb to the top. Then the top's built like a toilet valve. You guys all know what a ball cock is, right? A toilet valve, a little lever up and down, but it works in reverse. When the lever's down, it means there's air, and it lets all the air out, and it comes up and shuts the hell off. So the little seal never sees shit. And there's no place for you to put your pen in there either, and go psh, 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 like a 67 tomato mist that you assholes come back and say they leak because you put all this shit on the goddamn seat when you did it.
Say, but the nice thing is your stainless steel boilers don't gum them up anywhere near the
Yeah.
oil-filled cast iron ones did.
But we used air scoops for years. Remember the air scoops, the big old cast iron air scoop?
And how many guys put the 18
That
inches
we,
in front of it?
well, yeah, you're taking my theory away, but it's, you know, we had the expansion tank on the top and the expansion tank on the top and the fill on the bottom because we used sealing tanks back then, and we never had them put in right, or they would have worked. And that's why we worry about the air being entrained and not getting out of anything because we didn't have micro bubble air absorbers. Today, you can put those sons of bitches anywhere. They're phenomenal. This is a flow chart. This is a Taco sizing chart for all their pumps. This is 009 through 0014. Our flow on our previous was 9 gallons a minute at 4 feet ahead. So you come out here to 9, you come up to 14, and you see that we fall right below a 6. Well, what the hell is a 6? Oh, a 6 is a 0014. By the way, I just want to step back for one thing I forgot to say. When you're working on a house, you total your GPM. If your zone's 4 and your zone's 4 and your zone's 4, I got 12 feet ahead. I got 12 gallons per minute, right? So far, I got 12 gallons a minute. If your head's 8, your head's 6, and your head's 2, I'll use the 8. You don't add the head. You take the head of the worst zone and the total flow. We clear with that? Because I have people adding the head up going, I need a base mounted pump for this house, and it doesn't fucking work, okay? But you just take it and you find it on the chart and you find out what pump you need. It's not real difficult. This is the dual curve of the 1400 to see where it falls into its sweet spot, to make sure you're running at its efficiency level. Blah, 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 blah. Said no plumber ever. So there's 2 points we know. The design point was 0, and the design point is 6 gallons a minute, 6 feet ahead, right? Not hard to do, and this is how you run your curve. And you chart it. You go through your different head factors of all your zones, and you chart it in. And that's where we come up with our 6 GPM at 6 feet ahead, or where it's actually going to be running at. So, slab on grade, 40,000 BTU, garage is 20,000 BTU, hot water with an indirect and snow melt, 60,000 BTU on the driveway. We take this, we add them all up, right? You got 60,000 BTU for snow melt, you got 40,000 BTU for slab, that's 120. So we got 120,000 BTU and the indirect, right?
No. Snow melt's gonna run for about 4 hours a year,
Well, yeah, but you still have to add it in because you don't want the house to get cold while it's snowing.
for all 4 hours.
So you take the 120, yeah, Frank, I hate to say it, but you take your 120 and you drop it in here, right? Your 120 doesn't, 138 fits in there, but 101's not enough, and 120 happens to be the AHR reading. There's my boiler size right there. And FTVN 150 is actually going to help satisfy a 40-gallon indirect very easily. So if all you need is a 40, then that's great. If you're doing a 60, 80, or 120, you're going to want to get a bigger boiler. But at a 10-to-1 turndown ratio, it helps you get so it doesn't overgo. So the FTVN can provide 2 different temperatures. We can, using zone valves, it's harder because now we have to put relays, but if I used multiple zone valves with multiple pumps, so if I had 3 attached to one and 2 attached to the other, I can do 2 different temperatures on this.
Then you have to put, if the zones are like radiant, you have to put a mixing valve on the lower temperature zone.
Well, if they're with plus or minus 10%, it don't matter on the radiant. By the way, that's plus or minus 10% on radiant to put them all on one mixing valve. Do you guys know that? So you can't put underfloor at 140 with slab at 110. That should be 2 different temperature zones. You shouldn't be running 140 out to your slab. Anyway, radiant 110, those 3 zones, we put 1 mixing valve on it, or 1 zone on it, zone 1 and zone 2. Snow melt, fan coil, this is the 3 things that we're doing. Does a fan coil give a shit if I send it 180 degrees? No. Does the radiant give a shit? Absolutely. Does a snow melt? Absolutely. Do my snow melt and my radiant work? No. This is not an application we're going to use a 2 temperature boiler for. So Controlling it, we can take 2 circulators going off to our different temperatures, using a mixing valve on the one, the 4 zones at 110, the duct coil and the snow melt, using a mixing valve on the snow melt, because you're going to go through a plate heat exchanger anyway, aren't we? Because you don't want to glycol the whole house for the snow melt. So we're going to use a plate heat exchanger, go from there. So there's umpteen ways we can do this. We can use a TACO zone control panels. We can use TACO I valves. We can use thermostatic mixing valves. I wish we had the time to get into all the piping that we can possibly do, but the new TACO control boards are phenomenal. Look into them. But the TFTN, if I do this, I still end up with a 150. Now I have 3 temperatures. I can have thermostat 1, 2, and 3, or I can have TACO panel 1, TACO panel 2, TACO panel 3. On this boiler, on my output, I can have 3 different zone pumps. And those zone pumps can be pumps or zone valves. I just have to put the jumper on the output side of it to determine what these 3 are going to be. Then I also have a boiler pump, a domestic hot water pump, and 2 auxiliary pumps. Isn't that a bitch? This boiler will do buffer tanks instead of low loss headers. This thing can do domestic hot water recirculation based on timer. And central heat, 3 different zones, and you get a 3-zone expansion module that looks like that. So, some resources for you. I love resources, don't you? My at NTI boiler training, right? My NTI training website. Use it. Pumping away. You know, I was 35 years into this industry before I read Pumping Away. You know, it changed my life. It did. I mean, that sounds weird, right? But it changed my life because I found out what I was really fucking up with primary, secondary piping. Though it worked, I automatically, after I read that book, and it's really easy to read, could imagine your shit and save myself money on pumps and do it the right way the first time. And I have to go back and fix it. 25 bucks, best 25 bucks you'll buy this month. Modern hydronics. You want to learn everything about hydronics? I used to use this book for tech school when I was teaching tech school. You know, in Pennsylvania, you have to have 5 years as an apprenticeship program. One of them must be hydronic heating. And I would take these guys from not knowing dick about a boiler to being able to do a heat load, size their heat emitters, decide what they wanted to use, size the boiler, size the expansion tank, size the venting, everything for the pumps, everything. Every goddamn thing in the world, in the book, in your hydronic anything, when it comes to hot water heat, there it is. And now we added air conditioning to it, and the price dropped. When I was buying these 10 years ago for my tech school, they were $140. I found them for $106 for the 4th edition on Amazon. 106 bucks. That's cheap investment. And it's a great reference guide. Oh, I don't know if this expansion tank's right size. Go to the index, go back, expansion tank sizing. Oh, that's page 85. Take the volume, blah, 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 blah. Okay, cool. And you're done. Of course, you could just go to the Amtrol site and bring it up and put the same information in. It does all the arithmetic for you. It's no more than a spreadsheet. And TACO after dark. You know, I was lamenting, and I really hope that you guys come to my Thirsty Thursdays because it's a fun time. I have a lot of fun doing it, but TACO after dark, these boys are funny shit. Johnny Barba and Dave Haldorf, these boys are every bit of me, just doubled. I really suggest you do it. I'm going to give you 5 minutes on the prayer boilers, which is going to give you a 15-minute break while Rob gets set up and gets ready to go. Ready for this? Hold on tight, because this is really hard. This is really difficult. This is the most difficult programming you guys will ever see. How did my boss used to put it? These are the most technical, involved controls you'll ever see. And everybody's like, fuck, I don't want to touch that. I said, Kevin, tell them it's easiest to set up, but it can do anything you want it to. See, now that's different, isn't it? So look, isn't this a cool screen? This is on my TFTNs. You know why it's so cool? I was part of the design team for that. Yeah, I'm part of the design team for almost every one of our products, which is pretty fun. But look at this, in the bottom left-hand corner, there's a setup button. But look at this, wait a minute. First off, look, it shows me my flame signal. Do you know between 75 and 150 is good? So if you got there on the job site and you saw a flame signal was at 25, you know your igniter or flame sensor is dirty, right? Fuck, better clean them. Gives me my inlet and my outlet temperature, where I'm supposed to go. Tells me the pressure on the system, what my domestic hot water temperature at, and what my boiler's running at. Isn't that cool shit? And it gives me zone 1, 2, and 3, what's calling. Can do up to 6 zones, 3-zone expansion module. Tells you what pumps are running. You ready for this shit? You can touch any one of these, and it takes you right to that zone to set up all the parameters on it. How cool is that shit? And you do it all on your computer with their free dashboard, and if you hook it up to Wi-Fi. If you use the NTI Net app, it takes less than 5 minutes to put it on the internet. Son of a bitch. Yes, we're making it easier as day goes on. Oh, you want to set it up, so you touch setup, and there's a thing called a setup wizard. This isn't a guy with a baton that's going to sparkle your room. It just makes it easy. You touch it, and you have to put in your password. You know, on my old TFT, this is funny shit. My TFT boiler, the password was SOLA, because that was the name of the control panel. It might make you think that Honeywell named it that because it stood for shit out of luck asshole, right? But it's not. I mean, we are now, because Honeywell's shagged the dog on that control, but I don't care. So this guy's trying to put in SOLA on my TFTN. This is a guy who puts 40, 50 boilers a year and calls me on all his TFTs to walk him through setting it up. So I showed him the setup wizard. And he goes, I can't get into this control. I said, what? He says, I keep on typing in SOLA and it doesn't do shit. I said, Joe, are you working on a TFT or a TFTN? Oh, it's one of the new ones. He's not worth a lot of money. I said, oh, a TFTN. Try NTI Net, works much better. Ah, fuck. He says, he hung up on me. Homeowner's laughing in the background. Anyway, NTI Net. How many zones do you have? Was that a tough question? Wait. High temperature, medium temperature, or low temperature? Select it. What's your minimum max temperature for that zone? Ooh. Tank set point. What temperature you want it if you're using a sensor. If you're not using a sensor, it will automatically detect you're using an aqua set. You don't have to worry about it. Do you want to put this on the internet? Fuck no. Good. And you're done. Was that hard? Now wait, let's put it on a more competitive boiler for residential use. And let's go to our Series 2 control. Now when you first get it, when it's running and you come down the boiler room, it looks like it's on, but it's not woken up yet. You have to touch the button and it goes from this to real bright. And there it is, it's on. Now what this doesn't show you is on the Series 2, it now shows you PSI in this blank spot because we went to pressure sensors on these boilers, which is a godsend. So you hit the menu because you want to do something, right? Doesn't that make sense? You want to get to what you want to do, so you hit menu, and the first line item is, ah shit, setup wizard. And watch this, wait a minute. You hit enter, and you use the dial to turn it, and select how many zones you got. And when you got it, you hit enter. And at the high temperature, low temperature, you hit it and hit enter. Do you want to control with outdoor temperature? Yep, hit enter. Domestic hot water tank sensor, AquaSet, click it, enter. What do you want to set at? 124, great, hit it. Would you like the password? Protect it. Hell no, because I don't remember the password. Hit it. Would you like to connect it to the internet? 5 minutes later, you're on. Wasn't that tough? Come on, guys, I can't make this any simpler. You guys got any questions? Rob's going to come up here and put his computer where my computer is. So let's take a 10 to 15 minute break, right?
Yeah, so you guys can feel free to go down, wander around. The only thing I would just remind everybody, it's an active office, so if you're taking a phone call, you wouldn't mind trying to find somewhere a little bit quiet. You got people on the phone chatting, so everybody know where the restrooms are. Feel free to use them. Fun fact, if you don't know where they are, down there, they'll
All my boilers come as natural gas, and all of them come with a propane conversion kit. All comes with a kit. I literally, if you ever need a propane conversion kit for a 150, call me. Because of my buddy out on Long Island, who does 40 boilers a year, I go over his shop one night, I'm taking him out to dinner, comes up and hands me a box of all these fucking Venturis. I'm like, Jesus Christ. Yeah, he's all natural. Although that was a place where they would, because it was so long to get the gas line run, to get the tap. You know, he ran the gas line already, he's just waiting for the tap. But he hooked them up propane, and when they came through the gas line, then he converted them back to natural. Pretty cool? Do you need my remote or you got your own?
I got my own.
Okay, cool.
Thank you, Bill.
Yeah, wait a minute. Let me, if you disconnect my power. Oh, this is yours.
We're about to get starting with vented. Turn again.
You want to take a second take or should I post that?
No, you should 100% post that. We're about to get started with the venting. Hopefully, I will do better presenting. Join the live stream.
Perfect.
You can hear my sister in that one.
Morning, everybody. Welcome back. Hope you enjoyed your break. Pizza's going to be here in a little while, but we're going to go ahead and get started in the meantime. And then we'll kind of decide whether to just power through my presentation and eat pizza while I talk, or sit down and kind of just have pizza all together. Either way is cool with me. Figure that out when it gets here. I'm going to tell you guys a little bit about myself. This is kind of the outline of the way I like to go through this. I'm going to go over what I like to call the Centroverview. I've been making this joke endlessly for like 2 years now that I want to kind of like the Centrotherm overview to be the Centroverview, and not a single other person has adopted it yet. Might be time to give it up, but also maybe I'm just going to keep calling it the Centroverview until it takes over. I'm going to go over code inventing history, right? I'm going to give you guys kind of a timeline of how we got to where we are, why PVC is the predominantly used material, and then we're going to talk about the reasons why you shouldn't be using that to vent, okay? I think it's important to understand that. I think that one of the things that I will say like right off the bat to begin that whole conversation is code enforcement should not dictate what you guys are doing in the field. You should do what's right. Best practices, right? It doesn't matter. I hear this all the time. We go out and we talk about this and they're like, oh, nobody's enforcing it by me. That doesn't make it right or wrong, right? And I'll tell you a couple stories about that when we get to that. We're going to go over the product itself. We got a lot of it here. There's a whole set of boxes in the back, so maybe even when we take a break for pizza, maybe we'll just kind of get some of it out, play with it, put it together. You guys can get your hands on it if you haven't yet. It's kind of a fun thing. You can take a look at our common venting stuff back there as well. There is a section in here for a new product. We'll kind of talk a little bit about it. We're running it in some test markets. You know, it's not readily available here, but kind of is. We'll talk about that when we get there. Commercial product, support, and then some time at the end for questions. All right, pretty straightforward stuff. So, introductions. I always kind of joke here. The first slide came where it was supposed to, right? I said introductions was the first thing, and sure enough, here we are. So I'm off to a good start. Means my slides didn't get messed up. My name's Rob Mahoney. I've been doing HVAC for basically as long as I can remember. My family had a fuel oil and service business down in Newburgh, New York called Abbott & Mills. I got on and off my school bus when I was just a wee little lad, right at our office. Our house was actually right behind the main building there. Brendan remembers that, actually. Yeah. So I've been doing this forever, right? I kind of joke that I knew my nozzle sizes before my ABCs. When it was time to actually get serious and get a job, I walked right down the hill and started doing installs. Worked my way through that, ended up managing our fuel oil department for a couple years, then got back onto the service side of things, and I did all of our residential sales. So I was, you know, the in-home sales consultant, whatever they call, home comfort specialist, whatever they're calling themselves now. Basically, I was the guy who came in and consulted with you, sized up your house, you know, did all the, I never did quite the 3-finger technique to figure out the size of the boiler. I actually did load calculations, so no big deal. After we sold the business, which is far longer ago than I care to admit, I went on to work for FW Webb. And after I worked for FW Webb, I went to Ari Michaels, so spent some time on the wholesale side of things, was grand total probably about 6 years. Then I worked most recently for Viessmann Manufacturing, so I worked for a boiler manufacturer, for those of you who are not familiar with Viessmann. And then 2 years ago, I came on board with Centrotherm. Okay, that was right after kind of the Carrier acquisition of Viessmann. I came over here, and now I manage the entire East Coast for Centrotherm. Okay, so I cover from Maine all the way down to Florida, in case you're bad at geography and don't know what the East Coast of the continental United States is. And then the eastern half of Pennsylvania as well. I like to kind of add fun facts and hobby stuff in here. So fun fact about me, I once cut a car in half with a Sawzall. I think that's pretty rad. Anybody else? Show of hands, cut a car in half with it. You have?
Uh-huh.
You have too? This is like the first time. Get out of here.
Yeah.
Where? When?
My backyard.
All right.
I was 21.
Yeah?
Yeah.
Why?
Why not? It was a junk car.
Good answer.
Yeah.
Great answer.
Fire department.
Lennox display.
That's when I did mine. Yeah, we did. I was doing the Lennox contest. How'd you do time-wise?
3 minutes and I think I can't remember, 3 minutes and something.
Yeah. Did you know you could be bad at cutting a car in half with a Sawzall?
You could be bad at it?
Yeah.
Sure you can.
Yeah, I found that out. Terrible. You would think it was simple. Actually, they played me, so they didn't take the brake line out of my car. So when I got to the bottom, and it just sat there, and people, you know, there was a crowd around, probably when you did yours too. And they're like, come on, man, cut the car. I'm like, I had already cut the roof in half. And I'm like, you think I forgot how to cut? Like, I'm almost done. And then they finally come over, and they're like, oh, we got to DQ your time. And I'm like, that's bullshit. Whatever. 'Tis a poor craftsman who blames his tools, right? Something like that. When I'm not doing that stuff, I play guitar in 2 bands. If you like metal music, holler at me. My favorite band, Every Time I Die. And then another favorite of mine is Circa Survive. Not metal, but if you guys like anything in that genre, we can talk about that. Kara's booing my choice in music for some reason. I don't know what that's all about. So the Centro overview. So I like to kind of give you a little bit of kind of the scope of our company. This is nice. This is the one of the 3 trainings that we've done with this. We've been doing this NTI, Cytron, and Centrotherm training a couple times now. This is the 3rd one, and we've kind of traveled around to each person's facility. The nice thing about doing it at ours is, right, you got to see our facility here. You got to see the inventory here. I think the inventory is something that's pretty impactful because a lot of places we go, you know, you guys will get this, and I'm sure you guys deal with this, right? I worked on the wholesale side of things, and you'll go in and you'll be like, hey, I need something, and they'll be like, oh, it's going to take, you know, a month to get here. We're shipping out 2 to 3 days. That's it. You saw the inventory there. We got pipe, right? We're not back ordering stuff. We're well stocked, right? You guys can say that with a good degree of authority to anybody who kicks you back that at a wholesaler. Most of you guys, Plattsburgh, Newburgh, right around the corner, Campbell Hall, you guys are all in a realm where you should be able to get our pipe really quickly, right? So don't let a wholesaler tell you otherwise, and if they do, you guys will all have my card. I didn't put them out on the tables, but I will. If you get a wholesaler who says that, call me up, because I need to have a conversation with them. Overall, our company is, we are owned by a company called Centrotech. We've been doing polypropylene venting for more than 30 years. Okay, this is something that we've been doing around the world. It is slightly new in the grand scheme of things to us here in the United States, but overseas, this is all they use. You don't see PVC or CPVC on venting overseas, right? They have a different standard, a European standard, CEEN 14471. Memorize all these numbers. There'll be a quiz later. There will not. I was terrible in high school, so I would never quiz you guys like that. We do flue gas systems, condensate management, medical tech and plastics. We actually have a medical tech and plastics division here in the building. They're kind of like a small little office in the back, nothing that we're really going to run across. And I really only illustrate this, and then climate systems, air distribution, and ERVs and HRVs. At the end of class, we already had a conversation a little bit. You can see our kind of branched systems for ERVs and HRVs in the back. It's not what we're going to talk about today. If you guys want to hang and talk with me for a little bit about that afterwards, we can certainly do that. The idea is to kind of give you the scope of Centrotherm. Again, we are represented on 4 continents, 50 plus countries, and millions of influence installations around the world. Again, this is just to kind of put your mind at ease about what we're about to talk about the product, because I just had this actually happen a week ago. I was down in Virginia. A guy who works for all of the national builders down there, and I went in, first time he's meeting me. So I walk in, all tattooed up and everything, and I walk down, I sit down, and I'm like, yeah, you shouldn't be using PVC. And I tell him all the stuff you're about to learn today, and he's like, why has nobody ever told me this before? And I'm like, that's a great question, man. So we started getting into the stuff here, and he's like, where did this stuff come from? Like, he had kind of no idea who and what we were. And I kind of explained all of this backstory to him. I think it's important to know that it's been around forever, right? The new facility, I'm not going to bog down a lot of time on this. You guys got the tour today, so I get to kind of skip over this slide. You saw what was out there. Hopefully you enjoyed the tour. I love going on the tour. I pick something up new every time. Since 2019, we've had 450% growth, which sounds like a super impressive thing. It is basically what facilitated this new building. Again, we're not going to bog down much on this stuff. You guys took the tour. You guys, had anybody been to our old facility? Show of hands. Okay, so you guys saw.
I didn't see the facility, I just picked stuff up.
Okay.
In the warehouse.
Okay. Steve, comparatively, old facility to this one.
That would be like
Yeah, yeah. Just to give you guys an idea, there's an independent record label now operating out of our old facility. They use it as basically their screen printing shop. So we had all this growth, right, which is great, right? It's a good thing to have growth, but growth at that rate, you need to be able to scale, right? You heard TJ talking about it earlier. We've got room for 2 more extrusion lines out there. Injection molding is coming back here to the States. So we're really able to grow in this building. Additionally, over the past year, we added 3 new warehouses across the continental U.S., right? So, and then up into Canada. So we got one in Vancouver, one in Salt Lake City, and then one right around Nashville, Tennessee. As we've grown and the market has put more demand on us and we are trying to supply people as quickly as we can, we wanted to get down to 2 to 3 day lead times across the entire country. 2 to 3 day lead times in this kind of radius right here around New York was no problem, right? We're here, we're manufacturing it, we've got space, that was not a big deal. We had to expand out and get warehousing. Now we cover just about all of the country in 1 to 2 days, which is awesome. That means more product available at the ready if you need it, right? If a wholesaler is running short on something, know that we're here and we're going to be able to get it to them. We've done a lot to do that. We deliver 95% on time and full for the past year. It's actually higher than that. I think at one point we were tracking 98% on time and full. All that really means to you guys is it's rare that we are having back orders. Again, you can see that just by the scope of what we've got in stock, right? Good to know that stuff when you're in the field. We'll ask this very simple question because it's fun, right? The significance of this. If you go and pick up a boiler, you know, hopefully you're going and picking up an NTI after hearing Steve today, right? You go pick up your NTI boiler, are you going to wait 2 days for the venting? Right. It's ridiculous, right? Like that's the reaction that's supposed to happen, right? You're not going to, right? You need to get the venting material. We are what we call a flow good at a wholesaler. We have to be on the shelf and readily available for you guys in the field. That's part of what I do when I'm out there talking to wholesalers is try to, you know, get them to understand that we need this pipe here in the field for you. Because if you don't have it, you're going to revert back to the old stuff. So we can kind of get into that. We have all the national wholesalers. We don't really, I try not to play any favorites on that specifically. We have all the national wholesalers. Regionally, FW Webb, we got Johnstone, we got Ferguson, Howland, yep, VP Supply. We're pretty well stocked. We got quite a few here in the backyard, so. Again, not any one over the other. I prefer it to be on everybody's shelf, you know, so. So we're gonna kind of talk a little bit about the code and venting history, right? I think this is important to understand, especially when you're saying, you know, I've been using PVC forever, right? And some people will say, you know, I get this kind of like my dad used PVC and his dad used PVC, so that's what I use type of deal, right? Which is not really the right way we should be thinking about that, because odds are your dad was sweating pipe and his dad was sweating pipe, and now we all use ProPress for the most part, right? When high efficiency boilers first started hitting the market, right? And you guys can come up with whatever the name is for the first one that you guys remember hitting the market. NTI? Yeah. First boiler.
So, I mean, the Munchkin here in the United States, but the first one made in North America was
Yeah.
AL29C on
was the Trinity.
Yeah. Yeah, I usually say Munchkin as the example. That's just the one in the back of my mind. That's the one that I remember like being here. Yeah.
resolution for a floor mount was AL29C required.
Yeah. Yeah. So when that came over, right, we didn't really have anything. We didn't really think about the venting. We still don't to this day, honestly. It's funny that it is kind of the last thing that everybody thinks about. It's the last thing we put on the boilers, and it actually is handling the most, in my opinion, the most dangerous part about it, right? We got CO going through that. Jason does a whole part about the VOCs that are in combustion, so I'm not going to steal any thunder from that. He has a whole presentation that explains what's in there and when you're doing the combustion analysis, what you're looking for there. But it's very dangerous chemicals, most specifically CO, because the story earlier was an amazing one about CO poisoning. And to stress again, I have one of those personal CO monitors. Jason tells me Jason from Citron tells me they list for about $100 to you guys, worth every single penny. Like, those things will potentially, hopefully one day, save your life. They're great. Mine went off the other day. I was following this like truck that was off, like loading some gases, and I guess I had enough vent coming in, and it actually went off in my car. So I thought that was pretty cool. So anyway, first boilers came over, and we started using metal venting because that's what we had, right? It was on our trucks. It's just what we vented all our atmospheric stuff with. So we just kind of started doing that. Boilers got more efficient, right? You talk about, you know, modulating condensing as a technology, right? So we started to create condensate, right? That creates a problem with metal venting, right? You start to reach your dew point faster, right? I always say this, you know, not to get too super technical because I don't like to do that because maybe I'm not smart enough, whatever. Think about a beer can or a soda can, for those of you like me, if you're just a soda guy. You take it out of a cooler on a hot summer day, right? You set it out there. Other than the water that is on it, you know, from the ice, if you were to wipe that off, it doesn't instantly start to condensate, right? You have to reach the dew point. The temperatures have to, you know, equalize to get the condensation on the outside of it, right? The same thing happens in your flue, right? As your hot and cold flue gases intersect, that's happening much faster because you've lowered flue temperatures. Steve did a great point of illustrating a couple things. This is one that I always bring up at this. One of the things that affects that is antifreeze. You know, a lot of guys don't realize that. I didn't realize that until far too late in my career, that antifreeze actually affects that. So basic concepts of combustion, right? You've got a flame, whatever is fueling that flame source, you're trying to take all of that energy, right, as Steve was explaining earlier, and put it into whatever the heat exchanger is, right? Anything that doesn't go into that heat exchanger, where does it go? Up the flue, right? So up your exhaust, right? So all of that temperature that goes there. As you lowered that temperature, as we got more efficient and were able to transfer more of that heat energy into high efficiency equipment, we were able to lower our stack temperatures, right? That's why we now have condensation in our flue pipe when we didn't. You know, when your stack temperature, what was the stack temperature on like a, you know, a cast iron oil boiler? 300. Yeah, easily, right? Easily, yeah. So this is the problem that was created then. So what was the natural thing to use as a venting material? Keep in mind the Munchkin was probably, what, a 3-inch vent? Anybody want to guess?
Galvanized stovepipe? Oh, PVC.
PVC was the next logical thing. It's what we had on our trucks, right? So we were already rotting away the metal, right? And people went over to like people went over to stainless steel in some cases, but
it was 100
but here's
bucks a stick.
right. So we started going over to PVC because it was what we knew, it was what we had available. Also, it was cheap, right? High efficiency condensing boilers, expensive. The expense went up. We started looking for ways to cut costs, right? Because it's hard to sell against atmospheric boilers. So we put on PVC, right? Manufacturers, right? This is right out of a manufacturer's book. You can look in just about any manufacturer's venting section, which hopefully you guys read thoroughly. I know you're doing it for every boiler. Where is it? RTFM, right? So we're reading the venting instructions when we get there. If you get to the venting instructions, this is where the very interesting thing happens and the very confusing thing and the bulk of the problem of what we have today. Manufacturers adopted it, right? They said, okay, PVC, schedules 40 and 80. CPVC, schedules 40 and 80. And then they've got two standards listed there, right? For PVC, it's ASTM D1785. For CPVC, it's ASTM F441. You don't have to remember these numbers. It's not terribly significant. You can if you want to. I'm going to illustrate what the issue is here, right? So what this is telling you, right? There's a material. We list an approved material, quote unquote approved, in accordance with a standard, okay? You'll see when you get over here to like your polypropylene, UL 1738, right? It's not listed as UL 1738 on this. I should probably get a more updated graphic. Trust me, it is UL 1738. Oh, because they allow other polypropylene. That's why. So you've got a material and a standard, right? So ASTM D1785. 1785. I'm going to read this right off the screen for you guys, right? This specification covers polyvinyl chloride, PVC pipe, right? Made in schedules 40, 80, and 120 sizes and pressure rated for water. It goes on to say the product covered by this specification are intended for use with the distribution of pressurized liquids only. I highlighted that in a bright Centrotherm green. It's kind of important there. Liquids only, right? Which are chemically compatible with the piping material. Quick question, not a trick question at all. Is combustion gas a liquid?
Is combustion gas a liquid? No, gas. Right, right. So this tells you that standard that they have listed for PVC tells you that you can only use this with liquid. You cannot use it with gases. Furthermore, in ASTM D1785, they call out a listed venting standard of UL 1738, which is the standard our pipe is listed to. We'll get all to that in a couple minutes, right? So now what you're thinking is, okay, so I'll use CPVC. Well, here's ASTM F441, right? So this is ASTM F441, very similar. I'm not going to read all of this part of it, right? But you'll see again, when it goes into the details of it, pressurized liquids only, which are chemically compatible with the piping material. Again, liquids only. This is a liquid product. CPVC and PVC are specifically made for that. They don't call out UL 1738 in the standard for CPVC, but they do say specifically, standard is for liquids, not for venting combustion gases.
Is that PVC as well, or just?
This is for CPVC. So F441 is the CPVC standard, and ASTM D1785 is the PVC standard, right?
How do the manufacturers ever put in their manuals it's acceptable?
So here's the thing, right? So as a manufacturer, I say this very jokingly, right? And this is just something to kind of like take its tongue in cheek, because that's kind of the way I operate. Very technically, you know, the center of a roll of paper towels, if you want to send that to a manufacturer and have them test it as a venting product, they'll test it if you pay them, right? Like, it's just like, it's not, and I'm obviously joking, right? Like, this is kind of like, I'm being a little silly, but
$50,000 to $250,000, they will test it.
yo, they are testing a venting material to see if it will vent and move their gases. It's a round pipe. It will move the gas, right? But then they give you a standard. All this does, this is kind of a wild thing, and this is kind of like the terrifying thing for me, and I don't mean to be scary about this. I'm understand through this whole presentation, I'm going to say this quite a few times. I'm just going to present you guys with facts. What you do with them is up to you afterwards, right? Like, this is really on you guys to decide what you think about this stuff. This, to me, is just a liability wipe, right? This is just, they say, the manufacturer says, you can use this as long as you adhere to this standard, which means, as the manufacturer, not our problem if you did not read that standard and then you use that pipe, right? Not our issue. We told you what pipe and what standard to follow. If you did not follow that standard, that's your fault, Mr. Contractor, right?
But the standard says liquid only.
Ding, ding.
Exactly.
Hey, so you didn't
And
follow
they say you can use it, but it's for liquid only, so can you use it or not?
the lawyers and the judge will decide.
That's the part, right? That is the, like, legitimately, I go around, right? I travel, again, the entire East Coast. I give this presentation. I talk to people about this regularly. I talk to manufacturers about it. Manufacturers all agree. Steve, would you say that that's accurate? The manufacturers agree that PVC and CPVC are not really venting materials?
Absolutely. In Canada, you can only use CPVC Schedule 80 fire rated, which is not CPVC, it's Schedule 80. It's about 3 times the price of that. Industry standard here used to be ABS, believe it or not.
Yeah.
They outlawed that, and it's not grandfathered in. So they allowed you to use PVC by regional approval. Though we've never, ever, as a manufacturer, said, oh yeah, great product.
Yeah.
But it is an industry standard. Unfortunately, it is going to court as we speak. I mean, there's a lot of shit going on in the background.
Yeah, I mean,
Yeah.
in Kevin's example, those people could certainly be going to court if they felt like it.
Well, so, you know, we're going to get to a little bit of that. Do you guys want to grab some pizza? Do you want to just like power through, or do you guys want to sit and eat for a couple minutes? How do you guys want to do this? The pizza's here. I don't want it to get cold.
While it's hot, guys.
Yeah.
Okay.
Go ahead and grab some slices and I'll power through if you guys don't mind eating while I present. Cool, right on. Cool, let's grab some food and I'll keep going.
Maybe jumping ahead, what's the temperature rating for PV and CB? Jumping ahead?
A little bit.
Because I see your Centrotherm is
230. 230. We'll talk about it in a second here. It is actually the most insane thing in HVAC. I shout this from the rooftops, and I just don't understand. We're going to talk in a second about another piece.
code fathers saying, you manufacturers can't tell these guys to use this stuff, it's not great.
Who's going to tell them that? It's not up to, there's nobody to tell them specifically to do that.
ASTM police, right?
I mean, there are people who exist in these organizations, but they're not, there's nobody, hold on to that thought, because I want to say this to everybody.
That no PVC manufacturer says you can do it.
Yes,
Okay.
yeah, yeah.
Yeah, that's not, he's right. The manufacturer of the boiler said, if you read ASTM, which says you can't use it for gas, only liquid, you can use it for our boiler.
Yeah, it's crazy. It's
I
crazy.
know that I've looked at.
So are these codes,
So-
are they gonna change now?
So we'll talk a little bit
Somebody
about that.
has to die,
So
lawsuit has to happen.
so
Well,
here's
the guy, the fire marshal dude, that people could have died.
well, so here's the thing. I talk about this very often, right? That's what if you heard at the beginning, right? So I was saying that despite code, right? It's about what we want to do, right?
Last guy in
Be-
does the work.
here's the crazy part. Like, I got a story about this in a second. We're gonna get into all of this stuff.
It's also, three-story building, residential, has to be sprinkled. Nobody enforces it.
Right.
Oh yeah, there's no police in this.
Well, I mean, like, down by me in Newburgh, I mean, like, yep. You guys, how often does a code guy come and check on, your HVAC stuff? Right? Like, it's just, like, back when I was doing it, I never saw a code enforcement. Like, the city of Newburgh, maybe. Yeah. So, like, right. There's a lot of places that are like that. Yeah.
Which is a great program. For hot water heaters.
But they still want you to put them in.
All right. We're gonna roll along here. All right. So while you guys were grabbing some food, guys.
We're trying to
No, I know. I'm playing.
triangulate Jason's location.
Oof. Okay. All right. So a couple things that were coming up like while we were grabbing food, right? So this is a very wild thing, right? So I started at the beginning of this. This is actually like the bulk of the shocking part of the entertainment for today, because a lot of people hear this, and this is the reaction I get very often: is like, that's actively insane. There's no way that is possible. A couple things that I want to point out here, right? So when I worked for Viessmann, right, we had a discussion about this. If you look in Viessmann's manual, in the venting section of the manual, they do not have any unlisted material for venting, right? So there is a minor technicality here. There is a manufacturer out there called IPEX, okay? They're a PVC and CPVC manufacturer. They made pipe listed to the UL standard of 1738. They also made one to ULC, which is the Canadian standard of S636. Their UL 1738 product is a PVC product. Their ULC product is a CPVC product.
Is that the Fire Ridge one you were talking about, Steve?
Yeah, if it's in Canada, it's going to be the ULC. It's going to be I don't know if it's definitely IPEX up there. I don't know if it's but it would be the CPVC rated to ULC, because they have ULC S636, and that's enforced. They enforce a venting standard in Canada. Our standard is UL 1738, and it basically goes unenforced. So kind of what we were talking about here, just to kind of catch everybody up who wasn't in our part of the conversation. You cannot wait for code enforcement. Code enforcement is such a diabolical thing to change. I will tell you guys a quick story about being somewhere in the northern part of my territory. I was at a show talking to a code enforcement official who also happened to be a first responder. Again, I will preface this, not a scare tactic. I don't want you guys to think that. This is just the way that this went. Like, make your own decisions, please. But here's the way this went down. Code enforcement official comes up to me at the booth. We start talking, and he starts telling me this story. This woman went to her home. She felt sick. Husband came home. They went to the hospital. Hospital checked her in, wanted to hold her overnight. Husband went home to get clothes. Husband died. Okay? This code enforcement official, also a first responder, was the first one on scene, found the gentleman there. He had died of CO poisoning. So I turned to the guy and I'm like, so I assume you are telling me this because you want to enforce UL 1738, right? You would think, we would all think that that's the case, right? He looks at me dead in my face and goes, no, it's too much of a pain in the ass. I said, okay. I don't know how, I'm good at debating, guys. It's what I do for a living, basically. I had nothing left to say. I've never been more just like, I don't know how to explain this to you. You literally pulled a dead person out of a home and you don't think we should enforce this as a code? That's insane to me. I'm never gonna move here. Like, what are you doing? We go out and we give these types of presentations to code enforcement officials all over. We've recently done VPMIA in Virginia, I've done BOAG in Georgia, but code enforcement is such a weird and like just amorphous blob of mishmash, right? It's just all of this, guys are all over the place for what they want to do. You know, these gentlemen are from the town right next to mine, and I was just asking them, I'm like, when's the last time you saw code enforcement on an HVAC job? You don't down by us.
Can I add something?
Yeah, please.
Just randomly, our friends in Wisconsin called us the other day and said, hey, just FYI, we're enforcing UL 1738 as of next month. It came out of basically nowhere. And PVC is now going to be basically banned across
Yeah.
statewide. In Wisconsin, it doesn't really affect you guys, but to his point about how the codes are chaotic, it just came up. Somebody pled the case at the Department of Safety, which is literally what they call it in Wisconsin.
Yeah.
They made the decision very similar to Massachusetts. They have like a plumbing board, and they ban PVC basically, you know, en masse for this type of application, almost completely ran out.
Yeah. So, again, not to be a scare tactic, just understand that this is the fact of it, right? So we're probably going to cover some of this, so we might end up skipping a couple slides. I prefer this, by the way, I prefer back and forth when we're doing these presentations, so please just fire away. But very specifically, all of the national code bodies right now have UL 1738 language, and typically what the kind of consensus amongst all of them is it UL 1738 or manufacturer's recommendations, which this is the manufacturer's recommendations. This is the weird loophole that exists in code enforcement right now, where guys are going out and they're saying, well, the manufacturer says you can get away with it. And we're trying to educate them that the manufacturer, and this is, I don't mean this is not a shot at manufacturers by any chance, but the reality is, why would they take this out of their venting manual?
Unless everybody does.
Unless everybody does it. And this is one of those things, like you're going to be the first one to throw yours into the fire? Probably not. I'll happily stand by and let everybody else do it, and I'll be the last because I'm going to sell more units in that time. Because it's just a habit that people have, right? We're used to venting with PVC and CPVC because we've been doing it for a long time, as I said, with kind of this timeline that we're looking at, right? So just keep that in mind. And the story I was getting to before we broke for pizza, when I worked for Viessmann, I said, right, they only have listed products in their venting manual. We talked about adding internally about adding PVC and CPVC and listing to those standards because we were afraid we were losing unit sales, right? You can't blame the manufacturer for that. That's what it is. The market dictates that, right? If people don't start changing, if the market doesn't start changing, if code enforcement doesn't start changing, there's no reason for a manufacturer to change what they're doing, right? And again, that's nothing against them, that's just what it is. So PVC came in. We talked a lot about some things that affect these temperature changes that lead to kind of this, right? Like, you know, this beautiful little picture of, you know, some foam core PVC, I'm sure, right? Just clearly melted. This is where we start to talk about what ends up happening, right? Because our pipe is rated to 230 degrees. That's part of the UL standard. Anybody know what PVC is rated to, temperature-wise?
140.
140. I think it's actually 149.
What's that?
149, right?
Last one I read was 140.
Interesting. I thought it was 149. CPVC? Anybody?
I haven't read this 80.
180, I would think, because you see it on hot water piping.
194.
Okay.
So we're rated to 230, right? So what a lot of people will say, and again, this is we're gonna talk a little bit about this, right? We talked about that color chart of PVC, right? We talked about all of that stuff that happened. That happens because of equipment failure. right? Anybody ever have a piece of equipment fail? Right, like it's a thing that can happen,
Never
right?
had a service call?
Right, so exactly, right? So you're venting with a material that was not made for higher temperatures, and meanwhile it could potentially happen. Now again, it's not happening in all cases, right? Which is why a lot of times you don't see this, because one of the exceptions that I get from people all the time, I talk to them about, you know, the pipe discoloring, et cetera, becoming brittle and breaking, which I think is important. I think it's an important part of this discussion. I don't think it's the end all be all, and we'll get to that in a couple seconds, but typically something went wrong to get you there, right? Something went wrong with the piece of equipment, especially on a furnace, because your exhaust temperatures on modern equipment are not necessarily reaching that all the time. The fact is that they can though, right? We're going to talk a little bit about some other things that go. And all of these things can lead up to this, right? You guys all, you know, you guys have been doing this. I heard the conversations earlier. You guys know the things, right? Build up on the heat exchanger. Antifreeze, this is usually where I bring up the glycol mix, so kind of cool that that was already done for me. That affects your heat transfer, right? And you can have higher stack temperatures, right? We all get that. Cool. So, again, this might be the last time I say this. Not a scare tactic. These are just the facts, right? So we had a gentleman who worked for us, Isaac, and he was our code enforcement specialist. He would go out and kind of get all the data for this. So he got this from Consumer Product Safety Commission and the National Center for Health Statistics. There are 19 deaths per year in the United States because of failed venting and CO poisoning, right? That's just for failed venting, okay? This is kind of a double-edged sword because, again, that exception that I get very often from people is like, I've never seen it go like that, right? Especially down south where they don't have as much heating demand as we do. I get down south, anything south of Jersey, and guys start saying, oh, my PVC doesn't discolor, it's fine, it's no big deal. Okay, they got a valid argument. They're probably not seeing it, right? There are other things that happen. The bigger number to me that I thought was wild was that 7,590 poisonings, right? It was interesting to hear you talking about the one that you were thinking about earlier, right? That the taxi guy and things like that. I mean, there's just, has anybody ever been to a service call? I've been thinking about this a lot recently. A homeowner complains about headaches. You guys ever have that? I used to get those. I don't know if you guys, if you don't, more power to you. But I think about specifically this one lady who she would sit in her kitchen and she swore she had a leaking heat exchanger because she was like, I get a headache if I'm there every morning. I didn't even think about venting back then. Like this was, you know, early on in my career. I was on The Wall, Dan's, you know, page. I was on there. I asked questions on there. I'm like, anybody got anything? I got this guy who was like, drop mint oil in the chamber and run the blower, like to see if you can smell the mint. I was chasing everything I possibly could for this. It was probably PVC venting or something like that. I don't know. There are two major things, and this is the big one for me. This is one that we didn't talk about for a long time that I think is the most important part about that, and that's disconnected venting, okay? We're gonna talk a little bit about this. I want you guys to remember this rock down here, hence the little remember this in bright Centrotherm green. Disconnected vents, which we can actually try and help with. And improper venting. I can't fix stupid. If you do something stupid with our product, you're just as likely to fuck things up as you are with anybody else's, right? Like, I can't change that part of it. The cool, like, not cool, but the interesting fact, right, is the average age of the appliance was 9.6 years. Think about that for a little while. This isn't something that happened instantly, right? This is something that took some time, right? It wasn't the first day you hook it up that you had the problem, because hopefully you would have seen it or noticed it before you left the house. 9.5 years was the average age of the appliance in any of these cases. So, again, kind of timeline of where we were, how we got to where we were. Everybody kind of understands why we were using PVC and CPVC at this point, right? Like we've had some side conversations, but you understand why we got there. So what ended up coming out of this was a rise in codes and standards, right? So UL listings for pipe. ULC S636, that is the Canadian standard. The C stands for Canada, right? It is an entire venting system, right? This is something that is out there. I bring this up because you will see competitors of ours. There's other polypropylene on the market. They have the ULC standard. Some of them will go out there and they will just tell you that they have a UL listing. The C is fairly important because, as I said, in all of the national code bodies, they have adopted UL 1738. So to Matt's point earlier, right? You heard about Wisconsin, right? They're turning on the switch. That, to me, that's not enough notice for the field, but They think they want to do it that way. I recommend a much longer runway to kind of let people know and say, hey, listen, this change is coming 6 months from now. Be aware we're going to be enforcing UL 1738, but they're turning on the switch. The terrifying part about this is technically any boiler, furnace, hot water heater you guys put in today with PVC or CPVC could be red tagged. If a code enforcement official gets a bug up his butt, I'll tell you guys this story about an oil tank, Campbell Hall. You ever meet the code enforcement official out there? I don't even, it's probably not even the same guy. Pain in the butt? You don't, no, we're live streaming. I don't know if he's watching. If you're watching, I remember you. Okay, good. I shouldn't say good. He'd be my best friend now. So we did an oil tank out there, and we did 2-inch fill, 1.25-inch vent, right? That was kind of standard practice at that point, right? So we went and we did it. I get a call from him. He's like, hey, you know, you just did this tank over here. He's like, you got to go with the 2-inch vent. And I'm like, well, you know, with all due respect, can I send you some information, right? So I sent him stuff from the National Oil Heat Research Alliance, the current code. It all said that you can do 1.25-inch venting. And National Oil Heat Research Alliance had done a study, 80 gallons a minute from your oil truck. You dispel no more air at 1.25-inch versus 2-inch vent. It puts no more pressure on the tank, et cetera, right? So I sent him all this information, and I'm like, hey, man, I just, you know, we do oil tanks all the time. It's what we do. So I just wanted to kind of hopefully have this dialogue. He calls me back. He's like, read it. You ever want to put an oil tank in my town again? I said, well, yeah. And he goes, 2-inch vent. I said, okay, we'll be out tomorrow to change that then. I was so mad at that guy that day, but that guy would be my hero right now for this type of thing because he would probably want to enforce letter of the law on this once he found out and was educated on that. Right. So as we go out and talk to code people, because that's part of what we do here, know that at any point they could technically turn on that switch, and if they want to, just be aware of it, right? Again, not to be scary about it, it's just you guys should start being like aware of who in your area might be the type of person that does that, and we can talk about that.
They have the last say, right?
What's that?
They have the last say.
That's really it. I mean, ultimately you can try and fight them, but like for me, you know, my trucks were red and orange. Like, you saw them coming down the road. You know what I mean? Like, it's like, I couldn't hide on a job if I was going through Campbell Hall. Like, you know what I mean? Like, he was gonna see us coming. I could have tried to fight him, but like, dude, was it worth it? Like, because every time he saw one of my trucks go out, he was gonna stop in, see what we were doing, make sure, you know, it was gonna be everything. And that's in an area, we don't have a lot of code enforcement by us. It's at least back when I was doing it. Like, there's just not a lot of it there. But again, and that's also part of this whole thing too, right? Even if you don't have code enforcement, you know, you got to determine whether you guys think this is the right thing to do, whether it's the best practice for your business, right? So UL 1738, this is the gold standard. It is the US standard for venting, right? It is an entire venting system. You're going to hear me say this over and over and over again. A venting system. It starts at the termination of the unit, and it goes to the termination outside. So when you get outside to something like a snork and snout, bazooka type termination, pipe and pipe, right? Concentric venting, anything like that. It's the whole entire system. It is a standard for all of that. The materials, how it's installed, et cetera, et cetera. It is extremely strict. We're gonna go over a couple pieces of it that I think are the important and cool ones. But it is requirements for material and installation, okay? One of the cool ones that I don't have listed on the next slide is they put the whole system together and they hit it with 20 pounds of force and it can't deflect more than 1%. So to give you an idea, there are hangers that are required for the system. So true UL 1738 standard, again, very, very strict, right? So here are some of the ones that I like to point out. I'm just going to point out a couple of these that I think are the important ones. I'll be all right, don't worry. Nobody jumped into action. I could have been choking up here. Dylan looked like he was ready back there. He was ready. The only one. Thank you. Load tested the elbows. So once our product is put together, fairly simple to put together. We're going to go over this a little bit when we go into the product section. You have a connector ring on small diameter. You're going to hear me repeat that a couple times. Once our pipe is put together, I like to take the gasket out when I'm doing the demo. Makes it easier to kind of get things together and apart. Because as I'm going to tell you, once this is together, it has to pass 100 pounds of pull test, 100 pounds of force for I think it's like north of 48 hours. It has to like hang there, something like that. That is, for me, very impactful because when you guys first get this material, how many of you have like actually like used this or touched this at all? There's a couple of you? Okay. one of the first things that we do as contractors, I'm guilty of this myself, I say this all the time, people pick up the pipe, right? And you're used to picking up a piece of PVC, right? So let's actually just kind of send this around as kind of a fun example. You know, and they're not quite the same, obviously, but if you guys wouldn't mind passing that. Well, that's exactly it, right? So everybody's guilty of this, whether you guys want to admit it to yourself, but notice you do this. You'll pick something up and you'll be like, oh man, you know, it's not as sturdy. Whose hands can actually gauge structural integrity in here? Maybe Steve's. I believe you, Steve. For some reason, I don't know why, but I believe yours could. Mine can't. But I did the same things. Like, you know, at one point, like, there was a whole thing, domestic versus imported fittings. And, like, I would pick up fittings and I'd be like, it doesn't feel as strong. Like, what does that even mean? So that load test is kind of an indicator, right? How strong our pipe is. We can handle 2.5 times positive pressure. You're not going to see anything more than that in a system unless something goes terribly wrong. Extremely corrosion resistant. A thing to kind of keep in mind about polypropylene as a material, the container that your car battery sits in is made of polypropylene because it is resistant to battery acid, right? So it's extremely resistant to that.
You mean on today's cars?
On today's cars, yeah. Yeah, I should clarify, I guess. Yeah, I'm sure there were cars made at some point, you know, before I was born, that don't, that may not have polypropylene as it. But yeah, today's cars, yeah. And it is the most recycled plastic in the world additionally, which is just kind of a cool factor. Low temperature handling. This one is really cool for me. They put it in a chamber, -4 degrees for 5 hours. They take it out of the chamber and they drop it on concrete. Can't crack, right? So cold temperatures don't affect us, nothing like that, right? We are UV protected. You will see that we have gray pipe and we have black pipe. You guys saw on the tour different color granulate that we have, right? So there's a mix of granulate that goes into this stuff. All of our product is UV rated. All of it gets tested to UL 1738 standards for UV rating, right? There is a slight difference in extreme temperatures. Not really anything that we get in this particular neck of the woods, but like really extreme cold, you know, like Antarctica.
Well, okay, so Saranac Lake at -30 for 10 or 20 days.
We'll be fine.
Okay.
We'll be fine. I would say probably there. I would use the black stuff outside just to be on the cautious side, but the gray pipe should be fine out there as well. But and then extreme heat is also a little bit more resistant to that in extreme cases. But all of it can be used outside. It can all be painted if you want to paint it a different color, but really resistant to the elements. Fun fact, do you guys know where you're not supposed to store PVC?
In the site.
Direct sunlight. Where do you guys usually pick up your PVC?
In the yard.
Weird. So we're taking a material that's not meant for higher exhaust temperatures, putting it out in the sun, degrading it instantly, and then putting it on our trucks and venting boilers and hot water heaters and furnaces.
Are outside in the UV again.
What will happen with that? Follow that for a second, right? What do you mean with that?
It's going to collapse the flake up.
Well, it trickles down. That temperature transfers, right? It's radiant temperature, right? It transfers down the pipe, right? So just because it's the piece outside doesn't mean you're not getting extra heat on the pieces inside, right? It's what we talked about with radiant, right? That's why radiant floors work, right? It transfers, you know, directly through. So.
I was referring more to the UV degradation of the termination.
That also, but you know, so this is one of those funny ones because I argue this point kind of counter to the Centrotherm thing. If the pipe falls apart outside, who cares? You're already putting the gas out there. So like it's not really that big of a deal other than just looking ugly, you know. But it's, again, kind of doing my being fair thing, right? So, yeah. Elevated temperatures. So we actually, for UL 1738, part of the requirement for polypropylene, you have to test 70 degrees above your listed temperature. Our listed temperature again is what?
230.
230. Cool.
Test the 300.
Test to 300. I think actually, if I remember correctly, our actual like softening point is 304 degrees.
Correct.
Is that correct? I've been saying it for so long now. I hope it's correct. Oh my God. I just got checked on something the other day. I got to tell you about that later. And I was like, ooh. I am always happy to admit when I'm wrong, just so you guys know. Like I'm just like anybody else. I make mistakes. So yeah. And again, we got 40 plus years experience of making this stuff. That's just kind of like a little fun note. So let's talk a little bit about product, right? So we have UL 1738. Our product carries all of the ratings that are out there, all of the listings for venting. So here in the United States, UL 1738. In Canada, ULCS 636, and then European standard CEEN 14471. Everybody got all those numbers? Didn't see anybody jotting them down. Nobody really wants to remember? No. You're never going to need to remember these numbers. We have 2 to 12 inch diameter. You guys got to see the scope of that back there, right? Everything up to 10 inch is extruded right here, which is kind of nice. We are bringing back injection molding. We have a roadmap for how that's going to go. We had to move our tools over to Europe like post-COVID, right? This is a little bit before my time here. So we are bringing that back hopefully end of the year, maybe beginning next year, something like that. So, which is nice. So we'll have everything back in-house being manufactured right here in the States, which I think is cool. The thing that you have to get used to with our product is the different lengths that it comes in, right? So it comes in 1 foot, 2 foot, 3 foot, 6 foot, and 10 foot lengths, okay? Everything that you cut off of the pipe is effectively scrap. Again, most recycled plastic in the world, so if you're eco-conscious, you don't really have to worry about that. It'll get made into like maybe an Arizona iced tea bottle or something, or maybe a car battery holder, I don't know. The thing that we get from people very often, right, and I like to address this right at this point is, man, that means I gotta think about my venting? Which one, shame on you if you're not thinking about your venting when you're going to look at a job and size it up, because it is literally holding the thing that can kill someone from breathing it in their house, right? Like, you should be thinking about this first. Not to mention, we've got a job going up in a particular area of this state that there are maximum venting lengths for, and they piped in the boilers, and now they're trying to run venting, and they're realizing they're 165 feet away from the termination point, and they can only go 100 feet, according to the manufacturer, which might give something away. Who determines the maximum allowable vent length?
Manufacturer.
Boiler manufacturer, right? The equipment manufacturer. All of our fittings, right? Fittings have an equivalent foot. Who determines that?
You do. No.
Equipment manufacturer. I just learned this the other day too. I was actually shocked by this. This was a thing. Literally didn't know that. Literally, been working here 2 years. Yeah.
Is the 95 feet?
What's that?
Is the 95 feet? Is your 90 equivalent 5 feet?
We don't determine, manufacturer determine. It'll be different by manufacturer.
manufacturer,
Yep.
okay.
So the manufacturer determines that. So we don't actually do that. So, so good thing to keep in mind. And again, I didn't know that till later than I should admit, live streaming to all these people. Shocking. So when people will come and tell me and talk to me about like, oh, now I got to think about my venting, right? So I say this, right? You're doing a wall hung unit, right? And then one of those nice NTI units I saw before, right? It's going to be, you know, let's say this is our unit right here, right? Where are we going with our venting? Typically, most times,
If at all possible, up and out.
maybe up, over, and out, let's call it, right? So if I'm going, better example, let's use this right here, the table, right? Here's our PC unit. We're going to go up, we're going to go over, and we're going to go out. We're going to do this real time, right? About how high is this?
That's a 2 foot piece.
Cool. How far over is this?
That's a 3 foot piece.
How far out do you need to get out the block wall, cinder block wall?
Another 2 foot piece.
Okay, so this comes down to a simple question, right? Would you buy 3 10-footers to do that run, knowing now that you have to cut these and everything off this end no longer has the hub and it's scrap? You wouldn't, right? That would be kind of stupid. You can do it, and you can use the scrap as intake pipe if you want, because there's no regulations on intake pipe. I wouldn't do that way, right?
Can you glue the scrap?
That's a great question.
Will your pipe take PVC or CPVC or multi-purpose glue?
Why can't you?
Well, it's a matter with the pipe reactor because it's got a bond to the pipe.
We're gonna go on record and say glue our pipe.
For intake?
The Wild West is what Matt likes to call it, so.
Yeah. So there's no rules for intake, right? There's no regulations for it.
That's true, 'cause you can pull from the inside the building.
That is
but-
a fascinating question.
But you know, if I was going to recycle my scrap and use
I understand.
And use a.
Jot that question down. Remind me afterwards. We'll talk to our head of engineering and find out.
Burnco adapters.
Burn coat.
Yeah. I'm just curious as to what would happen. Yeah. Yeah. I don't know. I'm curious. again, Fernco would probably be the way to go. I would just figure out your vent lengths in a way that makes sense and not have to run across
So
that
if
at all.
you're cutting pipe to make the vent fit the building, and there's an issue down the road, the installer will cut the pipe, is that an issue? Does he cut your 1 foot, 2 foot, 3 foot section?
Nope. Nope.
As long as he left your factory end
Yep.
and didn't monkey with that.
Yep. We're going to talk about the cutting part in a couple slides. So, yeah, it's made to be cut. So we'll talk about that in a second.
What's stopping you guys from making a coupler with the silicone gas?
Man, great question. Great question. Does anybody know the answer to this?
Because the hub is in direction of flow.
Correct. So, gold star. So we are a directional pipe, right? So if you look at it, it'll say flow. What flow do you think we're referring to?
The exhaust.
The exhaust. Stop answering questions. It's some other, some other guys, you know. Spread the love. Spread the love. So we're a directional pipe. So it's referring to the way the exhaust gas is going to go, right? On the intake, again, it doesn't matter. Multi-directional, people will flip things around. It doesn't really matter. There's no take there. So if you take it like this, condensate just runs seamlessly, right? If I go the other way now, right? What? The other way. So you'll get condensate. It'll get down into the hub here, right? Underneath. And then will sit against the gasket. Now, the gasket is intended to hold back combustion gas. It is not made to be liquid tight. You can get seepage there. I had a guy from New York City recently. I'm not taking a poll on opinions on New York City. I have very strong opinions, and they're not particularly good ones. Don't judge me. And he sent me this video, because I was like, yeah, they're not watertight fittings. They're not made to hold. So he put together this whole like U-shaped thing and then capped it off, filled it with water, and he shook it around and he goes, see, man, it doesn't leak. And I'm like, okay, cool. Like, I don't know what you're trying to prove to me. It's holding water, that's great. I'm just telling you that it can leak. It's not made to hold water. Like, cool that it's doing it, but like, that doesn't mean anything. It is made to stop gases. So just be aware of that. That is why there's no coupling, right? So you can't actually do, because you'll end up with a leak, potentially, right? Like, so, good question, though. We have a 10-year warranty on our product. No solvents, primers, or glues. That is standard. We're going to ask about whether you could or could not do it, hypothetically. We have an EPDM gasket. No? Oh, man. Okay. EPDM, ethylene propylene diane monomer. An extremely corrosion-resistant material as opposed to silicone, right? You can sit it into like a jar of condensate and it'll just sit there, right? It's made to be in contact with acidic condensate and not actually degrade or like destroy the gasket or dry out, right? The brand stuff, which we already did. You guys got to see this firsthand, right? So we're an ISO 9001 facility. We have processes for processes. As you guys were going around and seeing the welding stations, you saw little scales at the end of them. Those scales are used to weigh the product to make sure that the right amount of plastic was used when they're hand welding, stuff like that. Like, I think that's just really cool, right? It speaks to the quality. And again, the fact that we go out and we get every certification for wherever we're going to compete, UL 1738, ULC, et cetera, just speaks to the quality of the product. So again, different lengths, you got to think about this, right? I point this out multiple times on purpose, right? Multiple lengths, you got to think about what you're doing when you're doing your venting. It's not really that complicated. It took us, 30 seconds to talk through it, and you don't actually have to do the talking. When you get onto a job site, think about where you're putting it, buy the pipe accordingly. It's not terribly complicated. I don't think so anyway. If you think so, cool, we can have a debate about that later. So, male end is field cut to length. You cut, you deburr, and you assemble, right? We all got to see that off our product line. Everything comes off with this nice little chamfered piece, right? As that machine was going through the extrusion process, that guy that was cutting it and then chamfering and sending it out, and then it goes into the green machine that gives you the hub, right? All you have to do is cut and deburr it, okay? Don't have to chamfer it. That's it. You just cut and deburr. The only thing, we're getting to that. So cutting and deburring, the only reason we have to deburr it is we just don't want sharp edges, right? It's a gasket that's holding back the combustion gas. You don't want to cut that, right? So just make sure you're not getting anything sharp there. We have everything you could possibly need in the entire world as far as venting. We've got some of these things up here. You guys can play with this stuff. You guys can hang out. There's boxes in the back of a ton of stuff we can play with at some point. Bird screens, terminations, condensate management pieces. We're going to talk a little bit in depth about some of these a little bit later on in the commercial. Spacers, siphons, drains, et cetera, et cetera. Everything you need for venting, we're going to have it. I'm fairly confident saying that. We are approved, industry-leading approval for manufacturers. 100% of boilers, water heaters, tanked and tankless, category 4. We have 80% of furnaces. That's kind of an interesting one because people are like private labeling furnaces and they don't have enough market share for us to pay for testing or for them to pay for testing, so we're not really approved. I say this kind of also tongue-in-cheek. You guys will notice this is a running trend with me. You're already using unapproved venting material if you're using PVC or CPVC. So even on the furnaces that we're not technically approved on, it wouldn't really change anything about what you're doing except for you're using a safer venting material. We can debate that as much as you guys want. You guys can decide that for yourself, but just know that that's the reason that those exist there. We have this very handy link. This is the one time I will ask you guys to write or take a note. Centrothermadapters.com. You can spell adapters O-R-S or E-R-S. We're going to have it come up again later. Save it, get to know it. You go there, you can look by manufacturer, you can look by model number, you can look by our part number and see all of the things that we are approved on and what adapter you would need to get started. In some instances, we don't need adapters. In others, we do, right? We'll talk about that in a bit. So we have, these are the adapters. Yeah, I just talked about that, right? Got a little bit ahead of myself, I guess. So this is what it looks like if you go to Centrotherm adapters, right? So you'll just have a little search bar here. I think this is a really cool thing. We used to have this as a spreadsheet. It was a pain in the butt. Now it's searchable like literally every other search bar on the internet. So if you got, has everybody been on the internet before? We've all, I'm on there fairly often, every once in a while. So you can look up, so if you wanted to look like an ISAFLG04, Carol, what's that?
It's a flange adapter.
This is ISVIB06.
So adapter with a bib on it.
You cannot stump her on a part number. It's like insane. I have no idea what half of those letters even mean. So,
Acronyms.
yeah. Why were you yelling? We have a wide range of fittings, right? So we have increasers and reducers, right? I like to stop and point this out. I actually stole this from when I was presenting with Kara. Increasers and reducers are different, right? Based on flow direction, right? It sounds stupid, but like when she said it at a class, I was like, oh yeah, that kind of like does actually make a difference. And it does come up enough down in our customer service department where people are returning it. In order of flow, it increases or reduces, okay? Combustion gas flow, okay? Keep that in mind. It's important because we are directional fittings, right? It's worth pointing out. I know it seems stupid when you like say it out loud. It's like, yeah, duh, no kidding, sales guy. Like, we know that, but like, trust us, it comes up enough. We have test port pieces, right? So they look like this. They've got a little test port for your combustion analyzer probe to go in. Anybody want to take a guess why? No answers. Anybody want to guess why you can't find a piece like this made in PVC? My guy. There you go.
What was it?
It's not designed for venting. PVC, it's only made for liquid handling. Like, it's legitimately the reason they don't make a piece like this. Why would they make something for testing combustion? They're not made for venting combustion equipment, right? Like, kind of makes sense. And again, you see all of our termination pieces here, right? So we've got everything that you might need to kind of cover any B-vent or any chimney caps, right? Connector rings, these are required on 2 to 4 inch. So 2 to 4 inch, you have to put a connector ring on. I'm going to go ahead and put one of these pieces together so you guys can see. I might be getting ahead of myself. To put the pieces together, a little bit of Centrotherm. It's a water-based lubricant. Slide it around the fittings, right? Just take it. Where was the fitting I was using before? So I'm doing this without the gasket just so you guys know, because here's what happens. So put the water-based lubricant, you'll put this clip on. When this clip goes onto the pipe, I'm not going to do it right now because it's made to hold 100 pounds of force, remember, right? You'll notice it slides freely, right? You'll notice that there is just one little lip on the bottom of the clip, and then the other side doesn't have something. It almost looks like it's broken. That is made to create that tilt, and once you create that tilt, you've got enough friction to stop that from moving. 4-inch diameter and below, this is a requirement of UL 1738. Larger diameter does not require it. We recommend it in case you have incomplete combustion or something like that. Plus, you know, we sell them, so why wouldn't we recommend them? You know what I mean? But larger diameter doesn't need it. Anybody know why?
You can make the 100-pound test without it.
Sure, but why?
Friction on the gasket's big enough.
Increased surface area. So increased surface area, so you get the 100 pounds of pull without needing that. The nice thing about putting the water-based lubricant on, and the reason that you guys see me take the gasket out before I do the demos, you can reactivate the lubricant later with water. So if you put it together and you wanted to take it apart down the road, you just get a bunch of water down to the fitting. Again, it is a gas-type fitting, not watertight, specifically designed that way. Get water down there and you can take it back apart. The reason I do this test without the gasket is because I was doing a class similar in size when I first started, and they were like, yeah, just put some water on there. So I go over, I got my trusty water bottle, it had been sitting over here, the lubricant had dried. Well, it's setting up. You know, you can kind of take it on and apart. We're going to get to this in a second. I kind of jumped ahead. But I tried to put a little bit of water down there, right? I was just like, a little bit of water. And I'm trying to take it apart.
All over the front of you?
Well, no. It just, you got to get water in there, man. It's not like just like a little drop of water. Like, you got to put some water on it to get it to go apart, right? There's not many cases where you're taking it apart. And let's face it, what are you doing if you got to do PVC? You got to cut it, right? Like, this has the ability to do it, has the ability to come apart. The larger the diameter, the more difficult that comes. Again, more surface area. But just understand that it is something that's available to you as an option. So I do it without the gasket now because it'll always come back apart and I don't look like a fool in front of 20 some odd people. I do that enough on my own. Condensate management, so we have drain fittings. So if you need to do condensate management outside of your unit, specifically stuff like that in the back, common venting, that's where you see that mostly. I recommend doing condensate management outside of the unit if you can. Why not? Unless, you know, you need it to clean it, you know, kind of one of those things. Condensate running in boilers is a good thing. Siphons, base supports, all that fun stuff. We make concentric pieces, pipe in a pipe. Does everybody understand concentric venting? Show of hands, understand concentric? Get it? Show of hands, who likes concentric? Not a, oh, you do? I hate concentric venting. So my philosophy on this is just an opinion, right? We do a great job of trying to keep it separated. I am of the mindset, and I hope maybe I can kind of talk you into thinking and changing your mindset a little bit. And I don't mean to call you out, sorry, but you raised your hand. The farther within manufacturer's recommendations you can split your intake and your exhaust, the better. The less likelihood of cross-contamination. I've seen cross-contamination kill so many boilers that I always recommend separating them as far as you possibly can. This is what an ideal situation.
The only reason I like concentrics is because I go into houses where a fly-by-night guy goes in and it's just hanging right there.
Yeah.
Dirt basement.
Yeah.
I'd much rather just get it outside.
Yep. Yep, I get it. Also, I used to get homeowners, you know, they're like, I only want one hole in the wall. I'm like, every window's a hole in your wall. Like, what difference does it really make? Like, we're going to seal it. Like, people would ask me that. Are you going to seal those pipes? And I'm like, no, I was going to just let all the rodents come in. Like, come on. Ridiculous. This is the way I like to see it. This is my preference. I don't know if you guys saw when you were walking back through the warehouse, the coils of flex on one of the back walls in the warehouse. This is the flex pipe. We have 2-inch, 3-inch, 4-inch, and 6-inch diameter. Keep in mind the 6-inch diameter is modular. It comes in pieces that snap together, okay? It is not coiled like the 4, 3, and 2, right? You got a chimney or a chase of any kind that you need to go up, go through there. B-vent, you can snake it down that. Takes no time to snake it down. Check out our YouTube channel. There's a guy who does a better explanation of it, a contractor down in Jersey. Explains it way better than I ever could. So, as we went through, measure, cut, deburr. I knew this was coming. It came a little bit later than I thought. Put it together with a small amount of Centrotherm. That's so you can take it apart. You can just do it on commercial projects. If you guys get even into light commercial, larger diameters, guys will just put a bucket of water. They'll dunk the fitting and then put it together because they're not really worried about ever taking it apart. It just helps slide the fittings together. You can dry fit them, but it's a little bit of a pain in the butt to do it. So, we're getting to kind of an important piece here. I'm running a little bit over, but I don't think Jason has shown up yet, so I'm taking some of his time. So, we are designed with a hub, right? Obviously, we've shown that. The reason that we do this, right? We are allowing for expansion and contraction, right? So I said you're going to put this lubricant on and you're going to allow for this to dry, right? What is the significance of allowing for expansion and contraction? So, well, your pipe is, you guys remember The Rock? Right, everybody? Not the actor? The joke gets less and less laughs. I think I'm going to stop saying that joke. So, a rock in the desert heats up during the day, cools down at night. Eventually it splits, right? We've all seen a rock kind of like this, right? That is because of the heating and cooling, expansion and contraction. Eventually you get a weak point and that splits, right? With PVC, when you guys are putting in your venting and you're using PVC, CPVC, I don't care what it is, any glued product, you're creating a chemical bond at that joint, right? Right? What is the set time for PVC? It's like a gnat attacking me.
Even quick sets, even fast sets says 24 hours to fully cure.
Fully cure, set time though.
Anywhere from 2 hours to 6 or 8, depending on which type of PVC.
And depending on,
Temperature.
that's one, depending on,
Probably humidity.
that's two, depending on. That's also a part of it. That's actually a good one. People don't mention that one very often, but yeah, you got to make sure it's clean before you put the glue. But
Primer, cleaner.
diameter of the pipe.
Okay.
I recommend very highly going to Odie's website and taking a look at this. I like to ask this question a lot because I learned this much later on. This is significant. So what I'm going to tell you guys again, this is the last time, not to be scary about this. You guys are venting product and not knowing what the dry time on that was. When you go to fire up a piece of equipment, I did my venting at the end of the day. That's typically when I did it, right? I was not waiting no 2 hours for it to set, let alone 24 hours for it to fully cure before I fired that piece of equipment. While that is taking that 24 hours to chemically bond those pipes together, how many times is that piece of equipment firing on and off in the first 24 hours? As it's reheating the home that cooled down, especially in the winter. You're getting expansion and contraction at that joint and breaking down that chemical bond from day one. You've essentially started the small split in your joint from the beginning. So you remember on this slide that I told you it was 9.5 years before the failure. That just created more break over time. That's where I think most of the failures come in. Because of that, we allow for that expansion and contraction at our joint. Our pipe can move freely with the gasket. It can move, no big deal. And you can fire right away because we don't have to wait for this to set up. We don't have to wait for this, I often, guys tell me like this, they're like, oh, we just run the blower for X amount of time so that way we get all the, the gases and everything.
I've had customers not do that.
That's
blow up the
to
boiler.
blow it up, yeah.
That's because of the solvents on the intake air.
That's enough of a reason not to use PVC and CPVC for me alone. So everybody got that? Everybody kind of understand that? I think it's really important to make sure everybody's good on that, right? Cool. This is what it looks like if you use the wrong type of glue. You guys know there's different sized daubers for different diameter pipes? Yeah. I didn't know this until just recently. Crazy. And again, our gasket keeps it nice and airtight, right? And allows for that expansion and contraction. So we are introducing a new product. I'm not going to say a ton about this. I bring this up just to kind of let you guys know we're in some test markets across the US. We're bringing in our European standard product, listed to CEEN 14471. I'm doing that a lot to memorize it. I almost did it again. Remember it. We only have enforcement in a couple states. Massachusetts, New York City specifically has code enforcement. We've got some movement in code enforcement in Tennessee, Alabama. As you heard, Wisconsin has changed. We've brought over Inaflu Light, which is the European standard. It is basically everything that is in this. I said UL 1738 was the most stringent. Again, we're not going to spend a ton of time on this. There's a flame retardant that goes into this that adds expense to our pipe. Right? And this is going to be a good point to point out, people will say that our pipe is more expensive, right? And some guys will go, your pipe's double the price of PVC, okay? I always ask this question, and I've been using this kind of line repeatedly recently. Double a dollar is very different than double a million, right? That little example that we did earlier where we went up 2 feet, over 3 feet, and out the wall 3 feet, let's say, right? We're about, in most markets, $1 a pipe difference, $1 a foot difference, and maybe $2 per fitting, right? Just to kind of put things in perspective. It fluctuates, PVC is volatile, it changes, it's a commodity. But on that install that we were just talking about, it's $2, $3, $3, so we're at $8, quick math, and then $2, $2, and maybe a 90 outside, another $6, so we're at $14. So even if you did your intake and exhaust, we're $28 more than PVC. And we are designed and UL listed for venting. We are the safe option. We're faster to put together. Whether or not you realize the labor savings on it can be debated. But no set time for sure, right? Especially with the set. You add set time into it and we kill it. But most people aren't waiting for that anyway. So this line is effectively going to come in, new clamp style that we're putting together that we're launching in all markets sometime next year. A new clamp, and then just this is our product without the flame retardant that we need for UL 1738. So in markets where we don't have code enforcement and we don't see it on the horizon, this product is going to start to become available. And when code takes over, this will be a great option for intake air, right? You'll just be able to use it, and then you're going to not have the need for glue or primer or any of that in the house at all. And then that gets away from that clearing problem that you were talking about, right? So it'll be a good option for that. And this product, because of getting rid of the flame retardant in there, in just about every market, we are cheaper than PVC. 1 or 2 markets, we're kind of like right there with PVC because it's regionally priced. And then there are a couple markets where we're like double digits cheaper, percentage-wise. So just to be aware, this is coming out. This is what the new clamp is going to look like. Again, this is going to start to come into the markets sometime next year. It's the Octo clamp. We can show you one of those. I got some downstairs. Basically, it's going to wrap around its clamshell. So instead of going on before, anybody ever flare oil lines before? Anybody ever not put on a flare nut? I did it 3 times on one job. 3 times. That's why I'm selling, right? Like those who can't do teach. Yeah. So if you ever forgot to put this clip on, you know, the clamshell is going to alleviate that, receives threaded rod. Again, this stuff is going to be kind of coming. You'll see this coming.
Dual hanger and
Oh yeah, yeah. So it's basically this little piece works like a J hook hanger, except without the J, like you cut the J off it, and it's mountable in multiple different directions. These are pretty snazzy. They're going to change our product line drastically, right? So this is a couple different illustrations of like in line, off to the side, or up that way.
Will that clamp be certified with the gray and black pipe?
Yep.
Okay.
Yep. Measure and cut for Interflu light. We're going to skip over some of this stuff. So commercial product. When anybody do commercial work? Okay. So commercial product. What I like to point out here is the weight. A 12-inch diameter by 9-foot piece of Centrotherm, which we had to adjust because it's the only thing that is in our line that is not full length. The hub is added, right? So if you get a 1-foot piece of Centrotherm, it's 1 foot of pipe and then hub, except for the 12-inch diameter 10-footer, which is actually only 9-footer. Thank you, Kara, for correcting that. Weighs only 34.7 pounds. You guys already got to feel the pipe. I've gone a little bit out of order on some of this stuff, so you know that difference. But you can grab, what is that over there? 8-inch diameter. You can grab that pipe when we're done here if you want and see the weight. This is the coolest thing we do. Everybody pay attention. This is it. If you are ever doing something where you got a common vent, if you're doing light commercial, anything like that, we will draw the venting for you. Kara was in the back making venting diagrams, working feverishly to get them back to people. We turn these around. Full disclosure, we had someone leave for a little while, so things are slow, but our target is less than 24 hours to turn them around. We have been hitting that mark pretty religiously, but we just had a guy leave for a little bit for some family stuff, but we're getting back on pace with this. The nice thing about this is you can take literally everything, right? Anybody ever do this on a job site? My favorite, ripping up the box and just like drawing stuff. Graph paper, we can get more sophisticated with it, or full-on plans. If you got drawings, that's cool too. We'll take any of these, right? And we turn it into a full-blown drawing just like this. 3D rendering of it, common venting, we kind of demystify it, right? Because I will tell you full on, I had no idea like how to, you know, if I'm coming off of an NTI unit and I'm common venting 4 of them, And what's the exhaust? What's the diameter? Is
3 and 2, depending.
okay. So let's say it's a 3-inch one, right? What does the branch of that need to be? What does this need to be if I'm doing 4 of them? What does it need to be if I'm doing 2 of them? What does it need to be if I'm doing 8 of them?
Yep.
I don't really know that. Guess what? Kara does. Our team downstairs does. We can make that work for you, and you guys can come out and instead of having 8 units individually intake and exhaust, you can have it look more like those units that are mounted back there. This is the most underutilized thing that we offer to people, so please, please take advantage of it. This is what it looks like when it's all said and done. Isn't it pretty?
But the manufacturer does have to allow for common venting.
Correct. They have to have approved it. So we have an OEM guy who goes out to manufacturers and gets approvals on it. There's a grand majority of them, I would say, do approve it. There's a couple out there that don't.
Read the manual, will tell you.
If all else fails, read the directions.
That's where we first start. We look right in the manual.
Yeah.
See if it's even allowed to be common
Get,
venting.
get off take it out from underneath your knees where you're kneeling on it to keep yourself to bed.
So take a picture, write it down, whatever you want to do. These are some helpful emails for you guys. If you want someone to do one of those drawings for you, it's going to be quotes@centrotherm.us.com. Spoiler alert, all the emails end with that. Hope everybody knows that. So you really only have to write down the first bit and you'll have the rest of it. Quotes is where you send any kind of information. So those drawings that you have, send them over to Quotes. We'll turn it around for you. Like I said, we try to commit to less than 24 hours, and we've been pretty damn good about that. Order status or price and availability, customer service. That's kind of our catch-all. You know, if you got something that you need to get an answer on from Centrotherm, start with customer service. You know, if you don't remember that you need to send it to Quotes and you send it to customer service, Kara's going to call and yell at you. But other than that, you'll be okay. You know, we'll get it over to Quotes. We'll take care of you. We'll get it out for you. We can make technical marketing documents for you. We have submittal documents all on our website, centrotherm.us.com. Marketing documents, you guys all got to see Matt Price, the insane person running around like a furnace, like shaking the whole time, thinking it's 9 million degrees everywhere he is. He can make specialized markets. We got Jordan back here. Jordan has been crushing it in my estimation. He makes a lot of cool stuff for us. We can customize stuff. So if you want to go, we have like some PVC versus polypropylene documents. If you guys want those, if you think they're useful when you go and talk to a homeowner, let us know. Reach out to us. We will happily share that stuff with you. We can get your company logo on it if you want. Really utilize us for that stuff, because here's the thing. You're all competing against people in your market, right? Imagine this. You're going down talking about a boiler saying, hey, listen, here's the difference between PVC and UL 1738 product, polypropylene. I'm going to use the polypropylene. Ask your next guy if he's going to use PVC. Explain those differences to them. I bet you win that job, right? Simple as putting something down there. Let us help you with that stuff. Kara, in the back of the room, is your dedicated commercial sales manager. C. Rupp at centrotherm.us.com.
Everyone should have my card, correct?
Yeah, I'm going to drop off my cards. My cards are just sitting on my desk right now, but I'll get those over to you. And I am Rob, as I mentioned, so R. Mahoney at centrotherm.us.com. If you need anything, again, I cover the entire East Coast. The best way to go is start with the customer support. If something isn't working or things are a little bit slow, go ahead and reach out to me. That's when you say, hey, Rob, you know, you would never say this, but you could hypothetically be like, hey, Rob, you know, Kara's not getting back to me, which would never happen, but that's when you come up to me. So that's it for me, in perfect timing.
Fucking good like that.
Yeah. So we're going to move to combustion analysis. Do you guys have any questions? Hit me with it.
Now, most furnaces we install, like Lennox and Concord,
Yeah.
they have a glue fitting for the exhaust. Do you guys have an adapter that accepts glue and primer?
So we don't do a glue or primer. Our fitting is a gasketed fitting.
That would slip over this, that we could, okay,
So centrothermadapters.com.
all right.
Is it US.com?
We could
or
probably-
just
Just.com. Hold on.
Kara?
Let's do this one for fun, actually.
Centrotherm 2 AL29C.
Nope. Can't mix and match materials for a UL listing.
I've got a whole bunch of AL29C already through roofs that I don't want to replace. It's
Through it?
Hit me with a model number.
Bends and
Oh, it's a Lennox?
finish these.
Lennox,
It's 3, but I don't know if I can get a flex.
What do we got? Like an EL 195E?
Yeah, we can talk later.
It's like a
Yeah.
ML193. Oh, you guys can't see that. My bad. It looks really cool up here. Hold on, let me. Yeah. I'll get it. Stand by. I'm not as think as I dumb I am. There we go. Now we're talking. All right, so.
A95U or 95G1U.
Are they furnaces?
Yes.
So maybe we don't have a listing on those.
Okay.
We'll take a look at
A
them.
lot of those are glue, so they've got like a female where you've got priming glue and then you stick it in and then it's PVC. So if you guys would make a glue adapter for that, I could probably.
So we will never make a glue adapter, but the gasket will fit in it. We'll take a look at that one special. If it's not on here, it might be one of the furnaces that we're not approved on. It's wild that we wouldn't be approved on a Lennox one, but.
Necessarily, if it's not on there, doesn't mean necessarily we're not approved, it's just no one's brought it to us yet. We
Yeah.
have to look through to see and get the correct adapter
Yeah.
on there.
And
So-
the other side of that is a 6-inch piece of CPVC 80 and
Well,
then adapt to that.
no.
No?
From Centrotherm, no.
Okay.
So as Kara mentioned, sorry, I don't think that I mentioned this, but UL 1738 and actually most manufacturers do not allow for mixing of venting materials. You are not, it is a venting system, right? I said that a couple times, right? It starts at the termination of the unit to the termination outside. You cannot change materials. There are, in fact, manufacturers who say in their venting manuals, if you change materials, it voids the warranty of their product. That would be a foolish reason not to get a heat exchanger replaced if you ever got called out on that. So just keep that in mind. And I recognize, guys, I'm going to tell you guys something just real quick. Jason, you can go ahead and get set up here when, yeah. I recognize that there is a difficulty in this, especially now that high efficiency combustion equipment has been on the market for a while. You're going to start running across jobs where PVC is run. You're going to run across where, stainless, any of those types of things. You're going to run across them, and it's going to be an absolute pain in the ass to change it out. You still have to do the right thing, right? Like at the end of the day, we are talking about CO, and Jason is going to, he did this at our last one. He talks about all of the stuff that's in combustion air, like not intake, but exhaust air. You gotta take this seriously. You don't want to be mixing vent materials. That is just a potential spot for you to have a problem, right? I get this in Massachusetts where we have code, they have a lot of PVC through walls for venting. And they ask me every time I'm in Massachusetts at a show, they're like, can I just adapt to that PVC? I'm like, I'm gonna ask you the more important question. Do you trust whoever put that PVC in, that they glued it properly, that they took all the steps, they waited 24 hours for it to cure before they fired that up? And everyone says, shit, no. And I'm like, well, then why are you adapting to it? That just sounds stupid to me. And they're like, well, it's hard to do. They don't want me to open the sheetrock. And I said, okay, then kill them instead. That's fine. Like, again, I'm being slightly ridiculous about it, but like, that's the reality, right? So, yeah. Thank you, sir. Any other questions for me? Every fitting. Yep. Every fitting. You guys can go ahead and take, take 10 minutes if you need it. Not an adhesive, just a lubricant. That's just to make them fit together. Yeah, I mean, you really can dry fit them, but it's hard. Because if that sets up, again, it's even. Oh, hold on, I ran it down. Oh yeah, I did a whole thing. So. Driving me nuts being there. Look at this. What do we got here?
Oh, crap. I thought I put the presentation up. My bad.
She was plugged there.
I think I plugged it in.
So even on the small
together with the gasket in it, it's still like 80 or 90 pounds
Oh, yeah.
to get it apart. Like
This is new.
we gotta complete that have been together. See if I
No,
can
no, no, no. You guys do
figure it
a
out for you.
fantastic job.
I take it out because without the gasket in it, it'll just come back apart. So for demo purposes, if that had been sitting there for I don't even know how long. If the gasket was in there, like I'd have to get
What the hell?
pull on it to try and make it work, you know? It would be a pain in the butt, for
So
sure.
what happens if someone puts a piece without the analog
A little bit real quick history about myself, and I'll get into the company a little bit. I've been teaching combustion for 24 years now, so tons of fun. This is what I do for a living. I'm late today. Late, not really. Started right on time because I've been on the road for 3 straight weeks. I travel the country. I've seen 48 different states doing this. I was coming through Baltimore on my way up here, and I'm stopping at home. So I stopped at home yesterday, saw my kids, saw a football game, and then came up this morning. So right on time. I've been teaching this, like I said, for a while. I'm from North Jersey originally, so every time I go to a different place, I pre-warn all my classes. As some of the guys in here have probably heard me before, this is how I fucking talk. I don't know what to tell you. Like, this is just how I speak. By the way, when you call me and ask me fucking tech support questions and stuff like that, no one ever goes, hey, Jay, I'm just calling you because I love your fucking analyzer. It's always, what the fuck does this mean? What's going on? What is that? So I hear way worse on rooftops, boiler rooms, and basements than anything I'm going to say here today. Okay, but this is just how I am. And by the way, it works for me. I'm not trying to toot my own horn by any stretch of the imagination, but I want to give you a little bit of a background on myself. Last year, if you're familiar with OESP, which is the oil heat organization on the East Coast here, I was the instructor of the year. On top of that, I was also one of the top 25 most influential trainers in our industry. Take everything you got. Refrigeration, electrical, everything. Combustion, not the sexiest fucking thing. So my method kind of works sometimes. The goal here is to have fun, right? I don't come up here to talk to myself all the time. I can do that shit at home. I'm here for you. So if you have a question, you've used an analyzer, you have a question about what's going on with it, please feel free to stop me at any point and ask me the question. I'm here for that, right? So just so I get a kind of a feel for the room, has anybody currently used or at least have used an analyzer in the past, just so I kind of get a feel for it? All right. How many currently, regularly use them now? All right, so good. So we got a good room. This is gonna be fun. Okay. Oh, last thing. If you notice, and nothing against anybody else, I don't hand out catalogs because every time I do, I always get, especially when it comes to a testing tool, they think it's going to be a sales presentation on the tool. I don't do that shit. I will talk about my instrument when it's relevant to what we're talking about in combustion and why it's different, why we do certain things the way we do them. Because there's going to be features and capabilities on here that you've never seen on an analyzer before. I don't give a shit what make, brand, or model you have. I know them all by heart. This is all I do, right? So there's going to be different things, and I'll talk about it when it's relevant. But my goal here today is to kind of go over what combustion is and all that kind of stuff. So this is my most favorite slide of all fucking time. I saw this years ago. This is probably going back 8 or 10 years at a contractor in New York, in the Bronx, and went in there, saw that, and I go, fuck, can I take a picture of that? I got to use that shit. Because if I had $1 for every time I heard that shit, I wouldn't have to do this anymore. By the way, when I was young, I was 21 years old teaching combustion. You want to talk about getting your ass kicked for a couple years? That's how you do it. Stand in front of a room full of fucking oil guys who've been doing combustion by eye. Son, I've been putting in boilers longer than you've been alive. And I go, fuck. Now I go, I don't fucking care. Because I'll ask the question. Anybody ever been to a boiler room and go like this? Man, who the fuck installed this? Then it's you, motherfucker. That's why I'm here. That's the point. And my problem is, even with a room full of technicians who might use the analyzer, because I'm going to ask it later. I'm going to give you different models of equipment, and I'm going to ask you for what you're looking for oxygen, for CO, for CO2, for stack temp, for draft, all of it. And if I get answers, I'll be fucking shocked. Okay? So there'll be some things we go over, but I love this stuff. That is just, oh, my other favorite is, well, we've been told. Like, I don't really care. That's another favorite phrase. So that's myself, Jason, my partner in crime there, Dan, and Kevin. We have 3 of us full-time doing training. This is pretty much all we do. We rarely do any kind of sales calls anymore. This is what we do for a living. Train, train, train. We're a part of every almost organization and association. We're partner up with manufacturers like this because we are on the training front. Okay? I know many of you right now go, who the fuck is Citron? No problem. I've heard it my entire career. It's okay. But that I don't care. I'm not going to be the one at your biggest supply house. I'm not going to be the one that's advertised anywhere. That's all right. I put my money and our resources into doing stuff like this. Going out, seeing the world, seeing the guys in the field and training. So our advertising and marketing dollars go toward travel expenses. Right? So that's how it goes. We are, by the way, I gave you my card, and some of the guys here learned this today. I do not put my personal cell phone number on the card. As a general manager, I have to sign paychecks and also deal with CPAs and lawyers and stuff like that. So if you want it, now's the time. Take a picture, write it down, do whatever you need to. Dan and Kevin are much, much nicer. They will put their cell phone numbers on the card. I ain't doing that. But I always give my cell phone numbers out to guys I train. So if you want to call me, email me, text me, go ahead. I'm here for you. By the way, as a testing manufacturer, as long as I'm the general manager, we will have 2 things. Number 1, live people answering the phones. Oh my God, what the fuck is that like? There's nothing that pisses me off more than calling somebody and having to press 2 for this and 1 for this. And I'm sitting there hitting zeros until I talk to somebody, right? My guys in the field, you're my end user, the customer. When you're standing in front of a boiler, the last thing you want to do is go through this rigmarole at 7 o'clock on a Friday night. We are the only manufacturer of testing equipment that have 24-hour, 7-day-a-week tech support. We are on call. Everybody understands what that shit means, right? We do it too. Call fucking Testo at 7 o'clock at night. See what happens to you. We do that. That's why I give you my cell number, all right? You call me, text me, anytime you want to, if you just want to talk, I love to talk, okay? I am 2 things.
Just put the kids away.
Yeah. My own kids know. My wife is a teacher, and she's about as Catholic as it comes. She teaches CCD, she does all that. She always gives me shit about the way I am. Too bad. She's like, yeah. She every Sunday, she's like, you going to church today, please? Like, yes. She's what keeps me grounded. But if you ask my kids, does Dad curse a lot? Like, all the time. It's 2 things. Number 1, I'm from Jersey originally, right? So that's kind of just a personality thing. And number 2, I'm Portuguese. So I know how to curse in 2 different languages. And I shit you not, my mom just got home from Portugal on Thursday last week. And I called her the next morning just to be like, hey, Ma, how was Portugal? She was like, it was fucking fine, but I'm tired. And I looked at my wife and I go, see? Exactly. Hey, Ma, that was all Mom. All right, we're based in Newtown, Pennsylvania. For those of you who don't know where Newtown, Pennsylvania is, that's where we did the last training. That's about a little northeast of Philadelphia, so that's kind of where we are. So we have a live fire training center. That's why we did the last class there. Excuse me. Guys come from all over the place. That's where units go in for service, for calibration, and all that kind of stuff, which we'll get into in a second, okay? I know it's kind of a little old because it was last summer, but this is a proud dad moment for me. But also Newtown was the home of last year's Little League World Series representatives. Yes, that's my kid on ESPN, representing Newtown. So that's it's where we're based. It's where my son played. It's not every day you see your kid there. Now, being Portuguese, I'm going to tell you how you win fucking Christmas every year. Somebody took this screenshot of my kid on TV. Well, because I didn't see this shit on TV. I'm actually at the fucking game, right? So ESPN, Pennsylvania, his name, his favorite vacation spot, because we've been to Portugal. I took a snapshot of that. My wife is not Portuguese, and I gave that to my dad last year for Christmas. And I looked at both my sisters and said, beat that shit.
How'd you like Williamsport?
I hated it.
Hated it?
I hated the
Lived there.
yeah. I hated the World Series experience as a family being there because they treat you really well when you're there, but outside of that, you're kind of fucking on your own. It is, and hotels there were $500 a night. I know.
Jack the prices. It's bullshit.
I've been to Williamsport many, many times over my career. We have a lot of oil guys that we deal with out there, and it's funny when it's $99 normally the rest of the year, and all of a sudden you're there. Every step of the way when you're going through districts and states and all that, even regionals, when you're in Connecticut at Bristol and Connecticut, they kind of like, hey, families are going to be in this hotel. They give you a block rate and all that kind of stuff because you're part of the ride. Like you have no time to think. And then you get to Williamsport and they're like, we got the boys, fuck you. Like you're on your own. I think my wife and I moved around to like 4 different hotels during that time. So I got a chance to take him back this past summer to kind of see the from the different view, you know? It's a totally different experience when you're not in it. And no fucking white glove service. You can follow us on LinkedIn, social media. We do all types of things, podcasts on, we just did one on carbon monoxide safety, actually, with these guys on heated conversations, right? So this, now, see, it's part of my spiel. You guys see that one? I'm just too lazy to fucking put it up, but I just, do these 2 or 3 times a day. I'm like, fuck, I'm not gonna go in there and change that slide now. A little bit about Centrotherm, just so you're aware. We are an Italian manufacturer. We've been around since 1981. I've been working with the company in some facet for 24 years, my entire career. Everything we make is made in Italy, even down to the electronic board. So we have complete control over quality and sensors and all that type of stuff. So I learned a lot by working for a European manufacturer and how kind of sometimes far behind you see we are in this side of the world, right? We are. One of the fucking biggest things we talk about in our industry and what I talk about in every class, because it's going to be right here when we get to, I'm not going to talk about any instruments here, but why are we here? Why do we perform an analysis? Why do we need to measure? And as soon as I mention venting, it sparks the conversation. And I'm sure you've heard it because you've gone through a lot of it today, but it's so amazing to me. Just fucking yesterday morning, I'm doing a training class in Baltimore, and I go, guys, what's the max temperature? Schedule 40. It still fucking amazes me that you get 280, I don't know, 200, 300. I go, it's in the fucking name. I go, somebody take your fucking phone out and Google it. Shit. We have this perception that it's able to withstand higher temperatures, but it's not just the temperatures that concern me. It's the acidity in the combustion process that you're creating. So I'll ask the question sometimes, right? I'll go, well, you guys ever see PVC turn like yellow or brown or become brittle, right? And I always ask the question, well, what is creating that shit? And the best answer I get, or the most common answer I get, is heat. Oh, nope. It's the acidity. It's not the heat. Heat's part of the problem. The hotter the temperature, the more acidity you create. But we're running equipment on material that's not made for that shit. And then my Italians see pictures of us and they go like this, Jason, why do you shit pipe on the exhaust? And I go, because it's fucking cheap and easy. That's fucking why. Welcome to America. And then they'll ask me the question, because over there they have laws. So like my grandmother is 95 years old, lives alone in Portugal, but not alone, she has help, okay? But she was going to die in that house. So we usually go once a year because she has to have her equipment tested every year by law. And if not, they'll come out and rip that shit out of there. There's no red tag in there. They're very stringent on efficiency because guess what? They have no fuel, right? And there's a lot of laundry list of things. But that's why I learn a lot, and then they see this kind of stuff, and it just amazes them. And then I'll go, okay, what aisle at Home Depot you picking that crap up from? Plumbing. Oh, shit. It's for water, ain't it? My favorite one was last week in Jersey at a company called Pipeworks. One guy actually said, in the PVC aisle. It's not a fucking aisle, man. Learn to read. Anyway, so we'll talk a little bit more on, I know you guys spent a lot of time on venting. I'm going to talk about the combustion part of what's going on in that venting, right, material. recirculation, all that kind of stuff. So what is combustion? What's oxygen? What's CO? What's CO2? What are these things that these analyzers are reading? NOx and the like. And then if you're working on furnaces, I mean, there's a real quick, easy way to check for a cracked heat exchanger. Real simple. Anybody want to know? Fuck it, let's do it now.
Combustion analyzer in the air duct.
What am I looking for then?
You're looking for CO or CO2.
Okay, in the air duct? That's one way. Anybody else? Come on, I've heard them fucking all, so tell me how you check for a cracked heat exchanger, please.
I mean, I've also been.
No. You're right.
I've also been known to light off a smoke bomb and throw it in.
Smoke bomb's another one. Smoke bomb. What else we got?
Oxygen when your blower kicks on.
O2, blower. Anybody else? How much?
Less than 21.
Well, you're right.
Like 2%, I think, norm.
Blower off. Right?
Yep.
Okay. There's only one king in combustion. Only one. It's O2. That's why every fucking analyzer, it's the first line.
Yep.
Okay? It's the king of combustion. O2. So my blower off, let's say my oxygen is 5.5%, just to say something, right? Because the burner's running.
You're talking about the supply.
Okay, I got you. While it's combusting. Got it.
While it's doing its combustion with the blower off. Okay? Now the blower kicks on. What does this change to?
Better not.
Better not. So if I see 6.1, 6.2, what do you got? Did I mention CO at all?
Nope.
That's it.
So any type of rise on that would
Nope. 0.5%.
0.5%.
5.5 to 6.0 or greater. Let's say your reading is 7.2. 7.7 or higher. It's 0.5%. Because what's happening when the blower kicks on, there's a crack. And O2 is all around. It's pulling it in, pulling it up, and your analyzer is showing you the increase.
Talking about the combustion blower or the combustion blower?
Yeah.
No.
No.
No,
The furnace. Furnace blower.
You just said blower.
Sorry.
Said that either.
Well, you travel the country, people call it different things, okay? So when the air starts moving,
Thank you.
this shit should be exactly the same. To the point where I love you, I just don't trust any of you for shit. So, because I used to teach this shit for years. But guys see a difference and maybe it's less than 0.5% and they're calling for a cracked heat exchanger. I go, no, it ain't. O2 changes. It does. Your analyzer, every fucking analyzer, if you look at the spec sheet, has an accuracy level to the sensors. Because it could be plus or minus. Because if I'm reading 5.5, the actuality could be 5.7 to 5.3. Right? There's a plus or minus in all accuracies of all sensors, of all types. So what we did was we took the guesswork out of it for you. So on this unit, I said I would talk about it when it's relevant. There's a measurement button here. It says cracked heat exchanger. And it walks you through the process. Step 1, blower off. Do what it says. Save it. Step 2, blower on. And then your result says that it will tell you on the screen and also on your printout if you have a crack in the heat exchanger or not. How much time did that save you?
You can do that with any analyzer, just if it's a big enough change.
It's just a matter of knowing it, right? You can do it with any analyzer, because obviously I have older models, right? And I've been teaching it for so long, but a lot of times when I teach a class, I get 3 or 4 different, or 4 or 5 different answers.
Just print out from that, it's like, here, Mr. Homeowner, done.
You can tell my personality already. Pretend you were at my house telling me I had a cracked heat exchanger.
As I was driving away, I'd say, you got it.
Or your mother's house.
I would be like, man, fuck you, show me that shit. That's what I would do. That's what a lot of people I know would do. Okay? I go, okay, can you read?
Yeah.
It's on the screen. Here's your printout, by the way. Here's covering my ass.
Yeah.
Yep.
Because what happens is, the smaller the crack, you won't see CO in the plenum or in the airstream, but it's there. The problem you get to where you're looking for CO is when that thing's already way past where it should be. So if you have a crack, that shit ain't gonna heal It's only gonna get worse.
How long after the burn of fires you take your first test?
A minute.
Gotta let it heat up.
Yep. Steady state combustion. So about 30 seconds to a minute is enough time. Plus, now what NCI, which is one of the biggest training organizations in the country, the National Comfort Institute, actually my partner's down at Lakewood in New Jersey right now going through a 3-day combustion class. You think I'm long? 3 fucking days. They are teaching now to do combustion, which these units can do at light off. They want to see what's happening at light off. And what happens with many analyzers, you can't use them, or they tell you in the manual, or they teach you, I used to, please do not have your analyzer in at fucking light off unless you want to send that shit in for service. Because if you've ever done that, you have the oh shit moment in the boiler room where all of a sudden you watch the CO go from 0 to 4,000 and pin your CO sensor, right? So, oh shit!
Yep. And go replace the CO sensor.
And because guess what? That shit ain't covered in a warranty. Didn't you read the specs? Yeah. Your test though says it's 0 to 2,000 ppm. UEI is the same. Backrack was a little bit different. This unit goes up to 100,000 ppm with an automatic cutoff. So if you try to do that shit, it shuts you off. Again, I love you, but I don't trust you.
That shuts off.
If it goes at 2,500, sensor stops.
I've done a combustion test on my UEI, crack heat exchanger, knowing I have a crack heat exchanger, and it passes.
Okay, because your UEI does not have an oxygen sensor.
Oh, what's it doing? Calculating from the CO?
It is the only analyzer on the market, only one, that uses a CO2 infrared sensor. Awesome technology. If they launched it 10 fucking years ago, you don't think that if that was good, me, Testo, everybody fucking have it? And you know how they sold it? No more O2 sensor replacements. And everybody's like, yeah, shit, that's great. I don't have to do shit. Yeah, I got a 5-year warranty. Did you read the fucking thing where it says it's got to go back to UEI every year for the warranty to void? I know you do, but not everybody does, brother. You understand? I know, because it's CO2 infrared. You ever seen an infrared gun? Yeah. Right? Everybody seen one of those? And they go, by the way, if you know sensors and technology like this, right? That little infrared gun, they point that little beam over there and go, that's what I'm measuring, that's what I'm measuring. I go, no, it ain't. No. It's distance to spot. So if you ever look at the back of your package, sometimes it'll say 12 to 1 or 15 to 1 or 20 to 1. That means at 12 inches away, you're reading 1 inch around that little dot. At 20 inches away, you're reading 1 inch. But the further you get away from it, your area of measurement goes much bigger, right? So the cheaper they are, the shittier the range is. All right. My point being, there's also another problem in infrared where you have what we call emissivity. So every different material has different emissivity, meaning what the light bounces off of. So if you put that laser beam on a copper pipe versus a wood floor, it's going to be totally different because it bounces off the emissivity. Okay? Now imagine you have this fucking flue pipe that has condensation in it. Condensing boilers, furnaces, right? And you got all these water droplets inside. And you're trying to be, I could put 10 fucking UEIs with that shit on the same flue and they all read differently. Because depending on where it is, it could be bouncing off the light beam. The light beam could be bouncing off the water.
That explains a lot of the issues.
I know, I'm really fucking good at this.
You're screwed, sir.
No. I love this, right? Because this is, I didn't come here to talk to myself. So I love this kind of stuff because you're learning, right? Every sensor manufacturer under the sun uses electrochemical sensors. So there's a chemical component in there and electro, meaning it's reading out an output to give you a reading based on how much chemical it sees, right? Everybody uses that. The sensor technology has not changed in 50 fucking years because it's really, really good and it's really, really accurate, okay? Down to these guys. Same thing, electrochemical, okay? In fact, the funny part now is I see, you know those piece of shit kitty CO detectors you see in like Home Depot? Now I'm starting to see them advertise the more expensive ones. They're like $59. They'll be like, electrochemical sensor. You go, well, what kind of, okay, anyway. But yeah, that's the issue with the UEI units. So what did I say was king in combustion?
O2.
So they're using a CO2 infrared and calculating oxygen. So it misses it.
That explains why we're looking for a switch.
Made his trip worthwhile.
That's the only way, brother.
Yep.
I love doing this because when I go through this and I go through the, hey, how many times? I write them all down, and then I go back to that first fucking slide. Like, this is how we've always done it.
Yep.
I go, I don't give a shit. There's only one.
Yeah.
I put it in the system. And by the way, there's a company, we were just at the training last week in Colorado. There's one company that go around the entire country. They're called, and if you've ever been to one of their classes, I highly recommend it. They're called Heat Exchanger Experts. They come over with like, I don't know, 50 to 100 different heat exchangers. It's a full day class. They're really, really good at what they do. That's how they teach it.
CO experts is in Colorado too.
Yes, I know them very well too.
I've got several of them.
Yep, CO Experts, Ms.
I haven't
Eric.
listed, but they go off at 5.
Yes, so I'm going to get to that fucking point because there's 2 companies in the country I trust when it comes to, 3 now, there's a new one. There's 3 companies I trust when it comes to those personal, the home detectors. CO Experts is one. I've known Bob Dwyer my entire career. He kind of started that company. He is the guru on carbon monoxide in our country. I've been to many of his classes. He always reminded me he's a big fucking burly guy. All he talks is CO. And he's funny because he reminds me a lot of like Batman because he's always got like shit clipped to him everywhere. And he'll show you during his presentations of pictures of him like on the middle of the fucking water fishing with CO detectors on his fucking bathing suit. And that's just the kind of, but I learned a lot from him, but he'll scare the shit out of you a lot of times too. All right, so that's this part. So we'll talk a little bit more about carbon monoxide when we get there. And then the last thing we're definitely going to go over today is how to take a proper combustion analysis on a high efficient boiler versus a I always do that. A high efficient boiler or furnace versus an atmospheric. If you're just walking up to this same system, putting your probe in the stack, thinking you're taking a test, good luck to you. Because they run differently, they operate differently, they get tested differently. Period. All right, so do we really need an analyzer? Yes, of course. Come on, Dan puts these fucking things in. Liability. Let's talk a little bit about that. Because one of the things that guys ask me a lot is, just to go back here for a second. Dan, so my partner Dan, he does a lot more of the trainings than I do these days, and he likes to change the presentation sometimes, so I don't know where he puts shit, so I don't care. I could do this without it. So anyway, liability. Let's talk about it for a second. It's a little bad word when it comes to analyzers, I know. Calibration. It's always, every time I talk to guys about an analyzer, the first fucking, oh, that's nice, great. Number one, how much is it? And when I show them the cracked heat exchanger test, I go, all right, now you're going to fucking ask me? Because you just found the cracked heat exchanger in what, 10 seconds and it paid for itself? So shut the fuck up. It's an investment. It's a value. If you know what you're doing, it can bring you a lot of money. Liability. Then they'll ask me, how often do I have to get them calibrated as if this is fucking changed? Where does it go? How long does it take? And all that kind of stuff. I don't give a shit what make, brand, model you own. It's once a year. Call anybody. It's once a year. I got field replaceable sensors. The whole goddamn market went to field replaceable sensors because my competitors sucked at getting this unit in during the heating season and getting it back to you before 5 to 6 weeks. Okay? Everybody has them. It's not special. What you're doing is you're spending 3 times the cost on the field replaceable sensor for the convenience. And it's still not certified. The first question any lawyer asks is, when was the last time that unit was calibrated? Do you have documentation? Number one, you're dealing with things like carbon monoxide and gas pressure and safety and functions. It's like owning car insurance. Get into an accident the day after your insurance runs up. Oops. Same with these. I'm going to show you manuals of different manufacturers of equipment that literally say in the manual, use a calibrated combustion analyzer for your startup. Calibrated. They put it in writing too. Okay? You own an analyzer, it gets fucking calibrated once a year. It's $100 to $150 for calibration once a year.
Regardless of use?
Regardless of use.
Sit in the box for
Don't care.
11 months?
Don't care. Because that certification, I don't care.
Right.
It is what it is.
That's the law.
That's your insurance premium.
Yeah. It's $150 a year. Do you know how much I spent on baseball bats last year? A lot fucking more than that. Stop complaining about $150 a year to get your unit checked up, certified, and calibrated. And by the way, for us, it takes 24 to 48 hours. It's coming down to Philly where we are, gets shipped to me. It's UPS ground 1 day from here, gets to us within 2 days, it gets returned. You ship it to me on a Monday, you'll have it by Thursday or Friday. I charge you $150, and I don't want to fucking hear the bitching about it, because when we get it and we certify it, guess who takes the liability for the readings you're going to do? I do. That's why my cell phone ain't on my fucking card. Because I have to be the one in the deposition going, okay, when was it calibrated? And then I have to look at the data and decipher what you did on the test. Right? Let me tell you a little story. Do you know what the United States produces the most of, by the way?
Lawyers.
Both are true. Both are kind of in line. Sorry, do you mind if I just grab my water and drink back there? Sorry. Pause on the class for a quick sec. I talk a lot, so my throat gets a little. Okay. Yes, the United States produces the most lawyers. That's what we do for a living. We are the most litigious society in the world. Caution, hot.
Yeah, McDonald's case, that woman won a lot of money.
Do you know that last year when I was living for 6 weeks out of hotels during the summertime, going all the way to fucking Williamsport, and I had to do my own laundry, and by the way, I had to do my kids' laundry too, because they bring you out as dirty shit and they go clean it. They don't do that shit. And you go down to the lobby, you get your little Tide box and do the laundry, and do not eat. Like, yeah, I fucking know. But we don't. I'll tell you a little story. Just to kind of give you a background of our liability. I'm Portuguese, so being Portuguese growing up my whole life, my mom and dad came over when they were like 17 or 18. Being Portuguese by law, I was only allowed to play soccer. Okay? They didn't understand other sports, you know? So that's why West being in the World Series was really cool, because I go, Dad, look what I could have done had you let me play baseball. It doesn't work that way, but anyway. No, it doesn't. He's way better than me. Anyway, being Portuguese, I was played soccer my whole life. So, you know, when I grew up and had kids, I coached soccer. I'm not around a lot, as you can see, especially in the fall when it's fucking soccer season. So I had to give it up. But for many years, when my kids were growing up, they're teenagers now, I coached them in travel ball, in rec ball, and then I joined the board for our local soccer club, right, to help out even more. Like, I just want to volunteer, and people here who have kids, I'm sure you've done that shit in your past too at some point in time. When I joined the board as a field director, I'm not sure if you know what a field director does, but when you show up in the field with your fucking oranges and balls and go cheering on, there's somebody's job to make sure the landscapers cut the grass every week, to make sure that we have enough paint, that somebody goes and paints the lines, gets the nets for the fields. That was my job. I joined the board of this very small little soccer club in Pennsylvania, and the first fucking meeting we had, hey Jay, it would be a good idea if you get an umbrella insurance policy to cover your assets. Last year, one of our landscapers left a rake out in the field. One of the kids tripped over it, got hurt, got stitches, and the parents sued the board.
And the board doesn't carry the insurance.
Yeah, we do. We have liability insurance. We have to run in case kids get hurt. Yeah. We have liability insurance. But we're a 501c nonprofit fucking little small soccer club, and they sued us. They can. As a field director. Why do you think they had a fucking opening for a field director? So exactly. So I had to take out for $1,200 an insurance umbrella policy to volunteer for my kids' soccer program. And for a living, I walk into boiler rooms and watch guys go like this. Was the light off? Yeah, let's go. And go, yeah, no, I've been doing this a long time. Shut the fuck up. What are we doing? You're responsible for it, not me. If you don't know, I hope you know now. You touch it, you own it. I don't give a shit what analyzer you have. Make sure it's calibrated, put it on there, get a printout. Make sure you can sleep at night. I am a father of 2 kids. If you were to come to my house and touch my equipment and something happens to my family, me suing you will be the last of your concerns. And I got a lot of metal bats. Yes, many. Some broken. Guys, this is your responsibility. You don't like it? It's not my fucking problem. That's it.
Calibration is more liability than is of actually calibrating the instrument. I mean,
Sorry, say it again.
calibration is a large part of it is to get that certificate that yes, I had it calibrated this year. Not so much if you even needed it.
I don't give a shit if it needs it.
You probably get a lot of them that don't even, they're fine, right? Of course.
I wish I got more. If I had an analyzer come back every year as it should be for every unit we sell, I'd be doing very well. I don't. They usually come back, oh shit, it's been a couple years, it's been sitting in my truck, I don't really use it that much, or they fuck it up and send it in, or finally they wait for a sensor to die and now all of a sudden it gets sent in. That's when it happens typically. And for many, many years, technology's changed a lot now, and it depends on the analyzer you have, but for many, many years, O2 sensors only lasted 2 years regardless of use. I call them grenades. Pull the pin, put it in, I'll see you in 2. I only use it 1 time, not my fucking problem. Should use it more. Technology now has changed where you have 4-year sensor life on there. So technology's come quite a bit of a long way. It's just what, look for that. And most manufacturers now have longer life O2 sensors.
But the lawyer still wants to see.
First question.
Not certified? Don't matter.
First fucking question. When was the last time the unit was, I can't tell you how many times I get called and go, I'm going to give you a serial number. Can you tell me the calibration history of this particular unit? Because it's being brought up on
Whatever.
And if it's never been in your shop,
Whew, I go like this. Never been here. He's in trouble. I just went to do I was in Texas 2 weeks ago for the NCI Summit, which is, again, one of our biggest training organizations. And I was astonished by the fact that for the first time I saw, we did a combustion. It was like a round table. It wasn't like a training class like this. It was just a round table on the topic of combustion and analyzers and stuff. And I had my competitors there and everybody in that room. And there was about 30 different technicians, everybody in that room was in there because they were going through some sort of legal proceeding. Everyone. In Baltimore, when I was there this week, I had a guy come up to me after class and tell me he's being sued for a boiler they put in 2 years ago. Because somebody, this never happens, somebody else comes in, fucks it up, touches it. Homeowners never touch shit, ever. You have to, when you're there and you touch it, you put your fucking analyzer and you print it out, and this is what it was doing when I was here. Period. End of story. I don't care what make, I don't care what model. Call any manufacturer, they'll tell you the same. Okay? Period. I just want everybody to understand the liability and the reason we kind of do that stuff. All right. Yeah. We got it. Anybody ever seen one of these? I hope the fucking answer is yes, or else we're in the wrong room. Every day, right?
Hopefully not reading 81%.
Well, give me a reading, give me a efficiency of the last one you saw.
95%.
It always seems to be the same. 95. What does that tell you? 5% loss, right?
At whatever the design temperature was that they tested at.
It's a lot of that. Does everybody agree with that? 5% loss, 95% fuel usage? Yes? It's okay, guys. You could talk to me.
Yeah.
Thank you. 95% efficient. Fan-fucking-tastic. So when I have a 10-year-old F-150 at home and love it. And when I bought my truck, I always tell the story because it's true and it's funny. When I went to buy my truck, right, the guy pretty much asked me, like a very nice salesperson, what do you do for a living? And I go, look, I'm looking for a truck, 4 doors, what I want, F-150, a little bit longer bed. And I knew all the things I wanted. He goes, well, what do you do? And I said, look, I go to Newark and Philly Airport. That's my travel, right? Now, my family's still up in North Jersey, and my wife's family's in LBI down at the beach, so that's, instead of this way, now it's just like this way sometimes, but it's only pretty much 3 fucking spots I go. All right. So when I talked to him about this, oh, check it out. Look at this F-150 XLT. It's got 35 miles per gallon on the highway. Yeah,
You ever drive on the highway?
yeah, I do, but I barely go 35 miles an hour, let alone 35 miles per gallon. I've had that fucking truck for 10 years. You know what I've never seen?
35 miles per gallon.
Fucking kidding me. But 95%. That is just like Ford did and just like a manufacturer has to do. At sea level in lab conditions, this is the peak it sees, not your running efficiency. And what nobody ever fucking reads is the little star next to it going AFUE. There's your annual fuel utilization efficiency. In peak conditions over the course of 1 year, vented properly with the right gas pressure and all. Who the fuck, none of this. Who the fuck installed this? None of that shit? That's the peak it'll see. And then they get amazed when they put their analyzer in. They go, oh, fuck, we can't. Look at this. It's 89. It's supposed to be 95. And then they call me and they go like this. Hey, why is it 89 and 95? I think something's wrong with your analyzer. I go, it's 10 fucking degrees outside. It's working. Is your heart rate the same when you're sitting on the couch versus a treadmill? No. It's working. Ta-da! So you need to know what the difference between what an AFUE is and what your actual combustion efficiency is. And what combustion efficiency, what your analyzer is telling you, and I'm going to go through some of this, is that you have to know the chemistry of the fuel. It needs to know it too. That's why you have to tell it what fuel you're burning, right? It takes that, it calculates, it measures your oxygen, takes your CO2, it takes the temperatures between the stack gas and all that kind of stuff, and then it spits out how efficient you're reading right now under these conditions. It might not meet the sticker. It's okay.
I'm doing CO2 and O2, and I'm not even looking at that percentage.
Well, that's my other concern is we might not be looking at things like draft and temperatures and all that kind of stuff too, right? So this is why I'm here. So there's a lot that this analyzer does. By the way, I don't know if you guys ever saw some of these little wet kits. Anybody ever seen one of these little jars? Yeah. This is red for. Oh, you brought it up. Red was for what fuel?
Oil.
What was natural gas?
No idea. We don't have.
Blue. This is how I used to do this. This is how some of us used to do that. How old are you? 25. You ever seen one of these fucking things? I fucking knew it. He's like, what is that shit? What's your name, brother? Sorry? Jared. Jared. You won't believe this shit. We used to take a fucking jar of liquid, right? And sometimes we'd have to fill it with, that's you're fucking up the calibration. Yeah. Water was not calibration fluid, but we used to have to take this, Jared, right? And you would have to put it into the flue and hand pump it. Suck the gas into it. And then it was called a wet kit because it was liquid, or a shaker because then you'd have to shake it. Hold up, Jared. Put that shit down. Wait for that stuff to bubble. All right, now write all this down. Okay, that's my CO2. Then you take your temperature gauge, get real nice and close to the flue, put that shit in, right? And then take that out, make sure you get your temperature, go over to the wall, take your ambient temperature because your primary air is coming from the room, do that delta. Then you take your draft gauge and you put that shit in. And it took me 20 fucking minutes when I got good at it to do one test. Then guess what, Jared? Make your adjustments and do that shit again. Maybe again. Holy shit, Jared. That sucks. You don't. Jared, I'm going to tell you how easy combustion analysis is now. Compared to what I used to do, all you have to do is set the fuel, put this fucker in the stack, hit the pro mode, choose what type of equipment you're running. Let's say I'm going to do an 80% boiler. Go back and put that shit in the green. You don't even need to know what you're doing.
Which is good.
I love you, Jared, but what? I don't trust you. Do this shit my way.
That's liquid filled, right?
God damn, that was how you got a live action movie camera right now. How much is it? Shut the fuck up. All right. So, this is kind of a nice little cheat sheet that you're always, it's always nice to kind of have. Guys ask me a lot about, I think analyzers are a great sales tool. You want to differentiate yourself? This is kind of one way to do it. What's your name, brother? John? All right, John. John, let's just pretend for a second that you don't know anything about this industry. Okay, usually somebody says something, or they do it themselves. Good on you. All right. Let's say you don't know shit about this industry. You call me to come out to your house because you got no heat or whatever the case may be, right? Okay. You see me outside your house with my big-ass machine here, my analyzer running. Hey, John, I walk into your house, right? What do you think the first thing you're going to ask me is? What the hell is that thing? It's amazing how no matter how many classes I go to, everybody says the same fucking thing. What is that? Now, different variations of it, okay? If I'm in the Bronx, it's going to be a little bit different than when I am here, all right? But the question is, what is this? Well, John, this is a certified testing instrument that right now is measuring the air in the room because I don't trust the little kitty detectors, and half the time I go into, they got the batteries fucking out of them anyway. So I don't really trust it. For my safety and for yours, this is just detecting the air in the room. What we're going to do now, John, is we're going to go down to your boiler. I don't know if there's anything metal or metallic around here. Nothing? I'm going to stick this up on your furnace right here. We're going to plug it in. We're going to check your cracked heat exchanger, see if you got anything, and then we're going to see how safely and efficiently your equipment's running. What the fuck do you think I just did?
Sure know what you gotta do.
No, I just gained credibility. Between anybody else who ever walked through their house, they're going to go, holy shit. You know why I have the same mechanic? It's because the one time I went to this motherfucker and he's like, let me show you something here. And he plugs stuff in and he's explaining to me what's going on. I go, dude, nobody's ever done that shit. You got my business. I trust you. You have to gain some trust with your customer versus anybody else who's going to walk in there and go, yeah, that shit's old. Here's my quote. I'll beat it by 10%. I won't.
Let me hang a red tag on this first.
Yeah. What I'm doing is using my analyzer for two things. Number one is safety, and number two is a differentiator and a sales tool. The more you use your units and understand the readings, the more equipped you are to have these conversations. And I'm going to tell you, if I'm in front of a homeowner doing that shit, I'm going to win the job every time. Period. Right? And I'm going to save myself a lot of heartache and time because I know what I'm looking for. Just on the heat exchanger part alone. Okay, so let's just say, John, I walk into your house, I put in the probe. John, my God, man, your furnace is running at 75%. What does that tell you, man? You own a house, you're a consumer, anything?
I'm losing 25%.
That's what it tells me. You mean for every $100 I'm spending on fuel, 25 is going right up the flue? Is that what you're telling me right now? It's exactly what, yeah, but my sticker says 88. Well, it's 10 fucking years old. No, I'm not giving you a break. I am fucking educating you on what's going on. So, here's your break. Instead of running at 75% where you're losing $25 for every $100 you're spending, why don't we start talking about some of these new 90, 95% systems where you're going to gain back about $22, $26. My job is to educate you and train you, and also how do I differentiate myself from anybody else who's going to walk through the door. The more equipped you are with understanding stuff like this, that conversation piece becomes a lot fucking easier. And by the way, at the end of class, I have these little sign-in sheets. If you want to, you're more than welcome to sign in if you want a copy of the presentation. I don't hand out sign-in sheets because I can't read your fucking handwriting. Okay, so the one good thing COVID brought us, QR codes. So you're welcome to use it. Steal my shit. It's all educational stuff, man. Take this, use this, just like I'm showing you, right? You have to, whether we like it or not, that's how we differentiate ourselves. I've had guys build companies on the way they do these things, where they send out these things in the mail and the flyer. Believe me, I know this shit works because, sometimes I come home and there's some guy cleaning out a dryer vent for $99 because my wife gets the Newtown looking thing, and all of a sudden she's like, oh, I got this guy to come over and do it. Okay. And then it's always something else that needs to be fixed, right? But that's sales. So for $99, $100, all of a sudden we're walking into somebody's house doing what I just did with you, and then we find the cracked heat exchanger. Then we got a different situation. But it's how you get in the door. So why do we use an analyzer? Carbon monoxide safety, and we're going to talk about that in a second. Checking for proper fuel pressure. Most analyzers now have a manometer. This one does it simultaneously, so you can do your gas pressure at the same time. Because my favorite fucking question, if you fucking call me for tech support and I ask you what your gas pressure is and you tell me it's good, you ain't gonna hear fucking shit all after that, because I'm gonna hang up. I promise. Or if you tell me the color of the flame. Oh, if I even hear the buh, like you're gonna say blue, oof. I hope you call the office and get somebody else.
I think you put the FU with AFUE.
That is a new one and a good one. I'm gonna fucking use that a lot.
Just a guess.
True. All right. So venting and draft we'll talk about. Cracked heat exchange we went over a little bit. Maintaining equipment warranties, that's gonna be a big one, man.
How long has that cracked heat exchanger feature been on there? Is that
About a year. Yeah, it's because we developed it to put it on this particular unit. About 2 years ago, this particular unit's been in the market for 4 years. 2 years ago, we loaded that Pro mode. We call it combustion assistant, where you literally tell it what system you're running in it. And what's nice about it is if I'm working on a particular boiler that might have a tighter range. Usually it's a tighter range. It's not a wider range, right? They usually want like a tighter range. I can go to choose equipment, add here, put in, let's say, NTI, whatever model, and then I can adjust it based on their manual so that every time I go back to that particular boiler, it's done and set. I know. It's fucking good. I know. It's fucking awesome.
You put in the efficiency of the equipment.
No, I don't care about the efficiency, though.
Did you key that in at one?
No. I don't care about efficiency. When you go to the Pro mode, it doesn't even show you efficiency. O2, CO, CO2, stack temp, draft.
No. When you were going through the steps,
Oh, yeah. Sorry.
what
There's,
if you have no idea, how close you gotta be to?
if you have no idea on the efficiency part, it's
The difference between 80 and 95.
It's-
You know,
that, yeah, it's real hard. It's real hard to not know the difference between an atmospheric and a condensing unit, right?
How much is that, if you key the wrong number, how much is that gonna affect?
Oh, it can change. I mean, if you're running on an atmospheric boiler or furnace and you don't know, go by the 80%er. If it's really old, I'll tell you go by 70, right? But you know if it's a condensing boiler or high efficiency, then go by that, right? Your selections are pretty simple. They're 70, 80, 90% boiler, 70, 80, 90% furnace, atmospheric water heater, condensing water heater. You can add as many as you want, right? But anyway. So the warranty part is a big one because manufacturers are making it a requirement. In fact, some are actually voiding warranties now on equipment if you don't. Because everybody's getting sick and tired of who the fuck installed this question. We see it every day.
Came out of the box, should work.
Oh, Yes, for the most part, equipment that come out of the box works. But when they ship it to Albany or New Orleans or Denver, you ever been to 2 fucking basements that were exactly the same? Not much. So you have to know the different applications and what's going on, and you might need to make adjustments. Where Steve and I come from out in the Philly area, there's a wonderful little town there called Levittown, and everybody who's around that area knows how much of a bitch it is to work in that town. Because everything is, gas pressure sometimes I've seen set at 2.7 inches instead of 3.5, because that's what the combustion calls for. I love the fact that no matter where I go in the country, 3.5 is the fucking number I hear. So why the fuck am I here then? Set it at 3.5 and see what happens. If that's all it needs, that's all it needs, man. It's not. You get out to Utah and Denver, it ain't 3.5, I can promise you that. It's not, they're coming off an assembly line, they're being tested in the lab, but when you get there, it's your responsibility, or else they wouldn't have the fucking startup in the manual. There's nothing in this world that's plug and play. Nothing. So you need to know that kind of stuff. And to give you kind of, we talked about the liability part of it, and that's your CalCert. That's what it comes back at. But here, regularly calibrated combustion analyzer, telling you at the top of the fucking page in the warning box. Analyzer, 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 analyzer. Here, 2025, here's a brand new, here's a recall. Carbon monoxide poisoning that had to be recalled. Out of the box. So you don't always trust it. Trust yourself in doing the actual test it's asking you to do. So let's get to what combustion is. Now, this is my favorite part of the presentation. My wife is a 7th grade science teacher. God bless her heart, because now I have a 7th and 8th grader. Oh my God, what she has to deal with, I finally understand. You guys are puppy dogs compared to what 13 and 14-year-old kids are like. And many of you who have had kids understand that. But everybody always talks about, when it comes to combustion, fuel to air ratio. And I hate that fucking terminology. I hate it. Because nobody can tell me what's in the air that you're using for combustion. Yes, you're using air. I get all that shit. So let's go back to 7th grade science. By the way, just so you know, when I leave here and I call my wife and just say, hey, I'm leaving, I'm on my way to Connecticut for tomorrow, her first question she always asks is, how many got it? Sometimes it's none. Nobody remembers what you're fucking teaching, Ash. I'm sorry. Let's talk about air. Oh, for fuck. How much oxygen do we have in air? Your analyzer might need fucking calibration if you're getting 19. 23? Yours too.
21.
Close.
Okay.
Dude.
Hold up. There's a reason I'm writing it down. You said 19.
Oh, did I?
You-
I'm sorry, I meant. Okay, never mind.
Dude!
I meant 21, sorry. 79 nitrogen, 21 oxygen, a little bit of shit.
A little bit of shit is right. Okay.
No, you're right. You got it. My bad.
A lot of paint fumes, kerosene fumes, and other shit on that floor.
This is the makeup of air that you breathe. 20.95 is oxygen, 78.8% is something else we'll get to, and 0.004% are what we call others. CO2 and all types of other things, yeah. Depending on what city you're in, could be different. Okay. Think about this. The reason why it's 20.95, if you turn your combustion analyzer on, it should be between 20.9 or 21. Yep. The reason why it's jumped sometimes at 20.9 or 21 is because it can't see 20.95. So if you turn your fucking analyzer on, it says 20.9 or 21, we're good. If you see 19 or 23 or anything, that shit needs calibration.
Or don't go in the house.
Or don't go in the house. What makes up the most of the air we breathe? All right, we got one. Thank you. Because when she asks, we got one. Think about that for a second. Take a breath. Less than a quarter of the air you're breathing is oxygen. Less than a quarter. More than 3/4 of the air you're fucking sucking in right now is nitrogen. By the way, it's the same fucking air that we use for a boiler or furnace. Right? The problem is, what do you need in order to burn?
You flow the nitrogen so that you don't screw up your copper when you're raising it.
Well, what happens to nitrogen when it burns? Because you're burning it.
Not burning. Or maybe it's
Then what the hell is this? Is that real acidic gas that's in the combustion process?
got it.
Okay? That is what's discoloring the PVC and turning it yellow, and that's why we have to be real careful about how we vent and all that kind of stuff, right? So one real funny part that I see is, anybody ever seen recirculation?
Oh yeah. That's why we love concentric vents.
I want to show you something. No, I have a few pictures I just want to show you, but I got to skip through some of these that aren't relevant to some of this stuff. Come on. Here we go. Oh.
Yeah, we got that picture.
Sorry guys, you might not be able to see this. I got this in the PVC aisle at Home Depot. It's called Natural L. It's in the back.
Yeah.
Back in 2019, Schedule 40 do not meet UL 1738 safety standards. That's when a lot of the market started really changing dramatically, especially from the manufacturer side. Okay, this one I'll give to heat.
It was foam core.
I love this one. This is just fucking, let's just vent everything together. Okay. Here's my problem. The acidity that you have in the air, what happens when we recirculate? When you see shit like, oh, I'm going the wrong way, sorry. When you see shit like that. Exactly. Not only are you pulling the carbon monoxide that we're supposed to be venting back in, so we're creating more of it, you're also pulling that acidity from the gas and coming it back in, right? And what happens to the equipment? Start fucking up the igniters and the heat exchangers and shit like that, yes?
Yes.
Yeah, but that Schedule 40 on the exhaust side is going to be real good, though. This is something I never fucking understood. Venting this shit out and it recirculating back in will fuck up the equipment, but that plumbing shit is good, yo. What are we talking about? And do you know where it starts breaking down sooner than later? Is at the joints. Yep. That glue and sealant that you have start fucking eating away, and all of a sudden I'm walking in and there's carbon monoxide in the room. Then I'm going to be pissed. So a real easy way to check for recirculation, and I tell every fucking installer to do this too, don't leave without do all your combustion analysis, do everything you need. Have that boiler or furnace running, put your probe in the air intake, and you should be getting 20.9% oxygen and 0 CO, because that's what you have outside.
Yep.
If you that oxygen starts coming down and the CO and CO2 start coming up, guess what you got?
Recirc.
It's that simple. It's a real quick, easy way to test with your analyzer, just to make sure you're not recircing, because you might have vented this thing, you think perfectly, but maybe there's something else going on that you didn't see. By the way, this is my hotel at Williamsport, Pennsylvania.
We'll take them.
You see the bank there as you're coming
I have too many, and this is what usually happens right after a class like this. Check this shit out, right? Look at what we saw last week.
Yeah, exactly.
And I go, great. Stop sending them to me because I have too many already. There are 3 colors of PVC, famously. White, brown, gone. Put it in, it's white. It'll start to break down, become brittle, yellow, brown, and then all of a sudden, what happened to it? You go to touch it, and all of a sudden you're like, oh shit, it's off. Yeah. So there's certain states already that have outlawed it. It's coming. Just a way to test for recirculation and crosstalk. But what happens in the process in combustion? You only have 21% to play with. And that's what you need to combust. That's what you need. That's what fire needs. So when you're burning it, right, and you're getting, the reason why your analyzers you see 4, 5, 6% oxygen when you have the probe in the stack is because that's the extra air that's got to be in that process. Your analyzer reads this thing called excess air. And a lot of guys go like this, what the fuck does that mean? I don't know. Excess air is exactly that. How much extra air am I using that I need for good combustion? And there's 2 sides of that fence that you could be on. Too little excess air, that's when that's that oh shit moment in the boiler room where you're starting to see the CO climb up because you're burning fuel rich. Too much excess air, and you got the opposite problem where all of a sudden oh my God, my CO's reading 0. This is so clean. I go, what's your fucking oxygen? 12%. No!
What's your efficiency?
I don't give a shit at that point because you're not efficient. Right, you're running too air rich. Combustion is like landing a plane. You need to know where you are. You decrease the fuel, right? Let's say you're playing with the gas pressure. Decrease the fuel, your carbon monoxide is going to go up because you're introducing more carbon in the fucking fuel. You decrease the fuel, you're decreasing the carbon, sorry. Decrease the fuel, your oxygen goes up and your CO comes down. Increase the fuel, your oxygen goes down and your CO comes up. Your job is to land it within the green area for every different piece of equipment. You have to know what ranges you are. So I'll do this. You're running a 90% boiler, okay? You're running an 80% atmospheric furnace, okay? You're running a condensing water heater. Where should your O2, your CO, your CO2, your stack temp, and your draft be? Anybody else can help them.
RTFL.
Anybody?
Manufacturer's spec.
That's a great fucking answer.
Mine would be the
Well, let's say you walk up to something that's 10 years old. There's no manual there. So how do you know where you should be?
call a really good wholesaler who looks it up online and tells me.
Yeah, I know.
Pull out the number 1 tool that's in your pocket.
I mean, yes, that's one way, right? What should atmospheric furnace? What should my combustion readings be?
And better yet,
However,
the Olsen atmosphere.
my fucking problem is you start getting onto these fucking message boards. There's other fucking knuckleheads who think that they know the ranges.
Oh, I don't Google I Google manufacturers, the installation manual.
I'm glad you do that. You are a different breed. That's why we put those ranges in here. And when you leave here today, what we used to do for guys, because obviously none of my, been doing this for 2 decades, not all my analyzers had that capability. So we gave this little cheat sheet that I'm going to give you that showed different boilers and furnaces and where your reading should be for that equipment. Yeah, you're welcome. This is it. This is combustion, man. Make it as easy as possible. Just all I'm asking you to do is fucking do it. Because you're responsible for it anyway. Right? That's it. But I want to give you as much help as I can. So you have 20.9, that's all, and that's what I need, right? So I need more air than is necessary. So, what does that do with my clicker? Ah, thanks. I'm pretty notorious for that. All right, so let's go back to, because I'm going to go back to, we were talking about, oh, yes, before I do that, this is a good relevant point. Where should you turn your analyzer on?
Outside.
Okay, you notice how I asked that shit? Now let's ask the real question. Where do you?
Outside.
Don't believe it. I don't fucking believe that for shit. I'm sorry. No, I don't believe it at all. I asked the question, where should you, where do you? Okay? Because where should you? Outside in the boiler room. 90% of the time, because I'm out in the fucking road with the guy who just told me he always does this, and I go, okay, so let's go through this, and then he brings it into the fucking boiler room and turns it on.
And if I don't see 21%,
No, that's the problem.
it's, cause it's what, heat and what?
No. I don't. You have to zero it in fresh air.
Okay.
Because every time you turn an analyzer on, it's going to set to 20.9 or 21. But it's going to do, or my biggest concern, it's going to set your carbon monoxide to 0 based on the room you're in.
Okay.
Here's the difference.
But the little thing on your hip's not beeping your blood.
I would only allow one of my techs that I work with to turn a fucking analyzer on inside if I had one of these and it showed me 0. Okay, then I know I got nothing in the room. Here's why. Look at this particular picture I have right here. This analyzer here, the one on the left, turned on in the room. The one on the right was turned on outside.
9.4 parts per million.
So this guy turned his analyzer on outside, walked into the room, and already saw 9.4 parts per million in the room. If my levels for carbon monoxide in the stack should be 100 ppm or less, you're already off by almost 10%. You know what the biggest problem is? What is the maximum level for ASHRAE and every requirement we have for residential? I'm going to ask you residential and commercial. What is the maximum level of carbon monoxide that's allowed in the air in an ambient application?
No clue.
9 parts per million.
Okay.
30. I said I was going to go residential and then commercial. 35 ppm is the commercial requirement because it's an OSHA requirement for an 8-hour period. Okay, so if I'm doing a commercial like a school or a hospital, 35 is the maximum in the room. Still don't want it, I want 0. But by law, I'm allowed up to 35. In a residential, you're allowed up to 9. That's it. So in this particular application, I turned my analyzer on outside, I walked in, I'm already above the allowable in the room. I already see a problem before you do. That's why you have to turn it on outside. And by the way, without the probes or hoses connected. You don't want to pull moisture or fuel from the last test you did into the unit while it's going through the calibration. When I was at your house and I'm out in the driveway, I'm turning it on, I'm standing right here with it. Now I walk into the room because I'm trying to look for that. Because your residential little shitty $20 kitty detectors, do you know what they go off on?
33.
Where the hell did I put it? It's here somewhere. I passed it?
Keep going. I think keep going the way you to the right.
I'm telling you.
Next one.
Next one? Thank you. You know my presentation, but there we go. Here's your first alarm level, 70 ppm for 3 hours. Next time you go to Home Depot, read the back. 70 ppm for 3 hours before that fucker will go off. 150 ppm for almost an hour.
When do you start passing out?
When you start getting above 400 or 500.
Okay.
What kills me is back in 1998, the government did the smart thing of changing the UL standard and code so that we can sell these cheaper units at 70 ppm points because they wanted to stop having calls to the fire department at low level. They didn't want to pay for the fire department to keep going out. Mm-hmm. It's crazy, right?
Does that level affect you?
Yes.
It does.
Yeah. So in our industry, there is a huge growing concern of early onset dementia, Alzheimer's, Parkinson's, because of low levels carbon monoxide detection over time. You don't have one of fucking these? You better get one.
I do. I got it yesterday.
Good.
And your tester.
Oh, good, good. Doesn't need to be, like on the CO detector, obviously, it doesn't need to be mine. I would have something. I preferred mine because I know what the fuck we're doing, and we're the first ones to have it set at 9 and 35 alarm levels. Go on Amazon, go buy yourself one, or go to a supply house, and every one of them, read the thing. The first level is 35, and the next level is 200. Everything is set at 35 because these are 95% of the time sold in commercial. So we're the only ones to do the low level for both residential and commercial. It's amazing, right? This kind of stuff. So, yeah, I mean, yeah, so your analyzer has an ambient CO detector, all that kind of stuff, but these are the levels we talked about. 9 ppm is the maximum over a 24-hour period. 35 ppm is the 8-hour OSHA requirement, also a U.S. federal law, just in case you didn't know that. So if you're working on commercial, you better know that fucking number. That's usually why somebody always says that number in class, because we've heard it. And what scares me sometimes is when I ask the question and I go, hey guys, what should it be in residential? And I get 35. And they go, no, that's just the fucking number that everybody talks about. That's not it.
So commercial detector would go off 35? Should?
If you're using those detectors, no. The reason why we were talking about CO Defender, CO Experts, and some of those other ones is because they go off at 5 to 9 ppm.
UL won't put their stamp on it.
But UL won't put their stamp on it because they have an agreement with other ones. And guess what? I don't give a shit. You know what I have in my house? 2 CO Defenders. One at the bottom of the stairs next to the utility room, one where my kids sleep. They are $150, and they die every 4 or 5 years. Right? They're because the sensors need to be changed. Like I said, I spend a lot more on fucking baseball bats and gear than I do. I think $150 every 4 or 5 years to protect my fucking loved ones is something I can fucking manage.
No, my question was, in a house that would go off at 70, if you have one in a commercial setting, would it alarm at 35?
My problem with they don't even make a detector for. You won't see a detector here like that. We make like they look like this. It's a 24-hour. It actually, a lot of buildings, what they'll do is it communicates with the boiler, and it communicates with the building automation system that shuts the boiler off and sets off alarms and all that kind of stuff. It's a commercial side is going to be totally different than residential, right? NCI, which is one of those guys. Now we're getting to a point where this is that third one. I said it was new. They have this little detector that you put in your house. And if this thing goes off at 9 ppm, it'll actually signal the technician that an alarm's going off. Signal them and the homeowner, just in case. It's kind of cool, right? New technology. I don't make any money from this kind of stuff, just like every time I go around, I show this stuff. I don't make money doing this. It's just a matter of there are other options available out there. So just so you're aware of it. But I can't tell you, I'm sure you guys have seen it too, how many places you might go to and the batteries are fucking taken out. So what's the fucking point of this thing? Kept chirping.
Duh.
I did it.
I had someone call me and said, the CO detector went off, and I read it, it said, move to fresh air, so she put it outside.
English language.
Yeah.
That's what it said to do.
Gotta love it. So, you asked me, right? So 400s when you start getting into some real shitty areas there. One, to give you an example, this is Schedule 40 on the exhaust. This is out in Colorado.
That's the exhaust side?
That's the exhaust side.
Oh.
You could see where the acidity ate away at see the sealant that was there? Boiler lit. Guess what popped off? Killed 2 people. Couple was found dead. 1,800 parts per million in the basement.
No detector at all, it says.
Yep. This is why I don't give a fuck where you go. You should have one of these.
Something similar happened in New Hampshire. It was up now, they had it sticking out like 2 feet.
Mm-hmm.
The boiler was up against that wall, snow
Yep.
came off the roof.
Yes. You'll know. You know, it's not funny, but it's funny to me because during the heating season, when it starts like getting snowy, you see all these like social media kind of email things and stuff like, hey, make sure you check your venting outside heating. You go, yeah. It's because we're especially on the intake, or it could starve the intake. You can do a variety of different things, right? The worst I ever saw was, because I can tell you right now, I never walk into anywhere without, for years, it was turning my analyzer on outside and walking in before I walked into something. Now, I don't go anywhere without one of these. The worst one I ever had was out in Minnesota, where my CO detector was going off at 200 parts per million at the front door as I was walking in.
Get those people out.
That's what we did. We called.
I went to this house, they say you can't smell it.
You cannot.
Smell when a unit is not running right.
Yes, but you're not smelling the CO.
No, I walked in,
Was it oil, by the way?
it was gas, but what happened is, it was in this area where they changed from propane to natural, and they didn't convert.
Yeah, that happens quite a bit.
So, the furnace was in the crawl space, and regular galley smoke pipe. But I walked in, I could smell the fumes.
So what you're smelling, by the way, I'll give you an example. On gas or propane, what you're smelling is the NOx. That's what you're kind of smelling, right? You can't smell CO2, oxygen, and CO. I don't give a shit how long you think you've been doing this. You can't. Yeah, but that's what you're smelling.
The reason why it wasn't running right, in the house, it was 600 parts per million.
Fuck.
I told, and she wasn't feeling good. I was there to just do a cleaning. I said, you want to grab your cordless phone and your coat, and let's come outside. We called the ambulance, they took her away.
Yeah. I've had.
Did you go and finish the cleaning?
I went and shut the thing off.
Oh, okay, just one goes.
I have 1,000 of these fucking stories, man. Thousands.
In the basement, where the pipe had rotted out, I think it was like 1,800.
You never know what you're walking into, so the idea is to kind of protect yourself, right? Okay, so that's one. By the way, on oil, what you're smelling is sulfur, right? Because we always know when the units come in for service, you're like, oh, my oil guys are here.
Which one's worse, oil or gas?
Doesn't matter.
They both kill the same amount?
Yep. Carbon dioxide is made by anything combustible.
I know, I just figured oil.
Nah. You can't. Again, you still can't smell the CO. You could smell. Oil has more of a smell. You have to remember that oil's only in the New England to Virginia area, right? It's Maine to Pittsburgh to Virginia. That's it. There's a reason why the national OESP shows are in fucking Atlantic City or Connecticut. Now Connecticut and Connecticut, which is fine by me. But the rest of the country is natural gas or propane. Like when I travel out to Chicago and I go, yeah, because I have heating oil at home, and they go, what? The fuck is that? Yeah. What do you mean, from like your car? Anyway. So those are the levels and why you want to have protection, right? Let's see. So let's go back here for a second, because we'll talk about excess air. So when you have too much oxygen to go around, that's why you have to have a specific range, why every manufacturer, and I give you this little cheat sheet with specific ranges for O2. Too much excess air, that starts to decrease and cool the flame, and you're kind of, creating some not so much unsafe, but really like very inefficient capabilities, and you're wasting a lot of fuel. My biggest concern is when you don't have enough excess air, where we're running really high on CO. That's when oil is soot, right? So. Where's my water trap? When I see this shit, this is what a filter looks like.
Oh, okay.
That's what you used to use.
Yeah. That's what I used to use. But
What's wrong with, why isn't it white inside?
oh, but because he was an asshole.
Oh, okay, just wondering.
Yeah. He didn't do a smoke test, obviously. Or he just put his analyzer in, and all of a sudden he sends it back like, the analyzer's not working. Yeah, I know why it's not fucking working, right? Or my personal favorite is when guys change this shit before they send it in, and I open it up and I can see the pump, I can see the sensors, everything's sooted inside. I go, come on.
Stop it. You can only yell at me once.
I know. Everybody gets one from me. So. So yeah. I'm going to show you, this is called a combustion curve. It's a stoichiometric curve. It is probably by far my most favorite slide in all of combustion. This straight line is what we call stoichiometric combustion. It is perfect combustion. You don't get that shit. That is 100% pure oxygen with the perfect amount of fuel, and you have perfect combustion. There's only two sides of the fence that you can be on, excess fuel or excess air. We want to be on the excess air side because that's where our highest efficiency is. And what, like an example here, what's your name, brother? I'm sorry? David. Let's do a 90% boiler there. I think it's like the third one down, right? Where should my oxygen be, David?
5 to 7%.
That's the 2 points that they're looking for. Depending on the type of equipment, it changes, right? So don't pay attention to these numbers here. You should be between 5 and 7. Where should my carbon monoxide be?
Less than 100 parts per million.
You see that little teeny tiny curve? That's it. That's how much good carbon monoxide there is. So if you read 0 and you tell me you got 12% oxygen, I'm going to tell you you're running way too air rich, and look at your CO2 and your efficiency drop too. Right? It's all relative. Now what happens is if you start turning up the gas, and this is where we get into that oh shit moment, you go from 100 ppm, look how much that CO sensor fucking spikes. And you go from 100 ppm to 5,000 before you get a chance to pull the probe out. You go, fuck! And my personal favorite is when I watch guys like that do this. Because has anybody ever done that? Anybody ever overranged their CO sensor? Yes? Yep. Okay. If you're not shaking your head like, yeah, I've done that, you're either not using your analyzer enough or you're fucking lying to me. Because everybody does it. Okay? It's your probe, right? Oh, yeah, because you guys are the most delicate creatures to ever walk God's fucking green earth. This is my favorite. Guys overrange your analyzer, right? And I watch them do this. And they take the probe out of the stack and they go outside and go, give me one of these. I go, what the fuck you doing? So I'm getting the CO out. I go, no, you're not. Keeping it in. That unit has a pump that's pulling at a particular rate. You just pulled it out and now you're outside and you are fighting the pump. So what you're doing is you're keeping all that CO on the sensor, and then I got to send it in because I fucked it up. If you ever overrange your sensor on any other analyzer that's not this unit, disconnect it immediately from here. Get air to the unit immediately. That's the trick. Okay? Please don't go outside and wave it. I always laugh when I see that shit, and you don't want me laughing because then I just start going. Remember the CO2 sensor that we talked about before that I said was shit? Okay? Yeah. If my analyzer is only reading CO2, I could have the same CO2 number running at 0 CO, and I can have the same CO2 number running at 50,000 parts per million. Which one you got?
You don't know?
Exactly. That's why every fucking analyzer outside of the UEI have an O2 sensor and a CO sensor. That's why every single one does. Not a unit has a CO2 sensor because CO2 is calculated, man. You tell it what fuel you're burning, it calculates. I don't give a shit what CO2 is. I really don't care. The only reason we know CO2 is because this is how we were all taught. Back to my first slide.
Don't some of the manufacturer's directions still have
Yeah, but if you looked at the
8 or 9 they're looking for?
yes, the reason why they always have two numbers in the manual. CO2 and either O2 or CO. They won't just have CO2. Right? They'll have that because they're kind of looking for this too. The reason they have CO2 in the manual is because that's what we all fucking know.
For us old timers.
Not just for me too. I'm not that old, motherfucker. I still learn on this. But we as an industry just know that terminology, right? So what they've done is they go, okay, they'll either say between this and this, but give me this also. Or this and this, and give me this too. Just to make sure, because if your CO2 looks good, but your oxygen's 0, God knows what the CO is, right? But there's also a reason why we don't do this anymore. There was no CO taken into account. There was no oxygen taken into account, where we know combustion is oxygen. So you can turn the screw just a little bit, and all of a sudden, bam! What's nice about these is you could just take the probe out for a second, set that shit back, and put the probe back in and go back to your work. I'm trying to minimize the amount of downtime and calibration that the unit might need because I love you, but I don't. Say it out loud. Anybody who's been to my class will know. And they'll call and be like, Jay, I know you don't trust me, but I got a question. That's my problem, is that you don't know what side of the curve you're on. And this is combustion. What you're doing is you're telling your analyzer what fuel it is so it knows where to set these numbers, and then the manufacturer gives you this, and that's where you're going to set it at.
And on the oil, your smoke test will tell you which side.
My God, would it please? You wouldn't see this?
Yeah.
That was the only thing with oil that was actually kind of helpful. That's how I learned. I learned on the oil side. Yeah. Why? Because that's kind of where combustion got started. There's a reason why Bacharach was in Pittsburgh and Tesso's in Jersey and we're in Philly and Woller's in Mass. Why? It's oil country, baby. That's where combustion analysis started. How many trade shows I used to go to when I was younger and be like, oh, I do a gas. I don't need that shit. But yeah, that technology hasn't changed, right? We developed a digital smoke gun years ago.
Cool.
Yeah, nobody fucking bought it. So we stopped developing it because it was $400 or $500 and guys were like, oh, fuck it, I'll just grab one of them things for like $80.
Yeah,
So,
now 30 or 40 bucks.
Well, they're trying to, you know, especially Bacharach's gone, right? So Bacharach is gone. I know they fired all their distributors, all their sales reps. MSA took over and they're wiping out pretty much all the Bacharach business, and it's sad to see, but they're not making a lot of that stuff anymore, right? Surprisingly enough, they still sell the wet kit. Yeah. When guys show up to my class in Newtown sometimes and they show up with their wet kit, I come the fuck on. What year is this? Please. You know what? Fuck it. Now you're going to show us all how to do this shit with this, and then I'm going to let Jacob over here do it with the electronics. Let's see who's here faster.
Yeah.
And by the way, I can't tell you how many oil burners I would go to, and they'd all have because it was all handwritten. It would all be the same fucking numbers for 5 fucking years in a row. And all of a sudden you walk up and it's fucking sooted. You go, yeah, that shit don't work anymore. But to go back, because I want to show you something, because you made a mention of it, right? Here are manuals: natural gas, propane, CO2, oxygen, right? Here, CO2, CO. They'll always give you both ranges to be in. We know that we should be 100 ppm or less in the stack for the most part, but you have to follow your manufacturer specs, because that's why I even give you that ability to put in the specific range they want to see. Because look at this one. CO on high fires, 200. I don't want you to think that, oh shit, there's a problem, when there might not be. Okay. Let's talk about two more things. Let's talk about draft for a second. One of the most overlooked things in combustion, yet so important. Let's do atmospheric first. Nice 80%er. Where should your draft be? Give me a range of where draft should be. Don't look at, yeah, I know, don't even fucking do it. What's your name, man? Me? Yes. Jerry. This is the same fucking thing. Same problem with my guys who say 3.5 when I come to guess. Because I asked what the range is, and we gave me a number, and you get it right in the middle. That's what I was told. The range, sorry. So guess what the target is?
Okay, right in the middle. Yeah. Cool.
When I ask guys on gas pressure and they say 3.5, you want to know why? Because the range is 3.2 to 3.8. We all landed at right in the middle. Do you know what negative 0.04 feels like?
Okay.
Right? And I've been doing this a long time. When I was young, I saw all the tricks. Jay, look at this. Drafting. Well, hold on, let me get my matches. Piece of paper. Lighter. You've seen them all. That shit's drafting good. And then you get to a point, you go, is that at about a .02? Where we at with that fucking match? Because you could fuck up combustion from to too much draft, you're going to pull it. Too little draft, and you're going to get backdraft. Or it's not drafting as fast as it should be, and it starts to build up. Any analyzer you have should have a draft gauge already built into it, right? The problem is, a lot of guys don't know, in order to do draft, you have to take your analyzer, zero it outside, go inside the room, zero the draft sensor in the room because the draft could change in the room, then put the probe in, save the draft, and then do your analysis. I could fucking bet almost all of my money that shit ain't happening. That's, again, love you, don't trust you, but this unit's on that combustion assistant I told you, draft is one of them, and it's doing it in real-time live fire. Because I don't trust you to do that procedure, so we piped it differently, where you walk in, you put the probe in, you're measuring draft. Okay? Let's do a condensing system. What's your draft? Don't do it. What's the draft on a condensing system? You guys touch this stuff, you know, you should know it. Shouldn't be positive. It's forced. It's sealed combustion. The reason why it's atmospheric, and we call it atmospheric, is because you're taking it from the atmosphere and going up from your primary air in the room on up. Whereas a condensing system, a concentric or two-pipe, you're venting out, coming in. Sealed combustion. So this shit's going to be positive. And by the way, the range changes to about a .08. Remember I said that these things run differently? So when you tell that unit you're running a 90%er, it's going to change the draft setting to positive because that's what it wants to see.
No, it's just draft. This is draft under fire. Or is it draft?
No, yeah.
before?
No. You draft in the process while it's firing.
Okay.
Okay? Over fire draft, if you were to put this in, because of course you could do over fire draft too, it might change a little bit, but it's not going to be outside these ranges. It's so overlooked, yet so important. Now,
How do you, okay, here's a dumb question, but how do you
there's no dumb
move
question.
the draft in a sealed combustion?
It's all venting then.
I mean, if you said equally distant vents with, like, and you put them in the same pressure.
The biggest problem we see is when it's vented from like a high efficiency condensing furnace or boiler is vented the intake air from the room.
Okay.
I laugh at that shit because I go, okay, you didn't want to put the other pipe in here, so we're taking the primary air from the room. I'm sure you guys have seen this. Okay?
And you've sealed the room.
And you've sealed. You want to know how to fuck up draft? That's one way, right? You got 70 degrees in here, let's say. Say 100 degrees in the stack, just to say something. It's a condensing system. What's a delta? 30. Okay, so how exactly are you condensing? I'm up for the conversation. Anybody know how you condense at a 30 degree delta T?
You could have a 70-degree day here outside, you're sucking it in.
Yeah, but it's not condensing it that day. Remember that efficiency I told you about is over the course of a year. When it's working harder and it's more efficient, it's when it's colder because that's when it condenses. So if I have 10 degrees coming in and my stack is 100, your delta is 90. That's when you start condensing.
And according to Steve on his boilers, at 30 degrees, you don't have to clean that sucker.
Yeah.
If it's fire.
But nobody can still answer the question of, if you're venting from in here and this is your exhaust, you're not condensing. All you did was sell some, first of all, you're going to fuck up your draft. That's how you do it.
Yeah.
And number two, all you've done is sell somebody a really expensive atmospheric furnace.
You're sucking conditioned air out of the house.
Yeah.
You're paid for it, you're sucking it.
Yeah. When my wife and I moved 3 years ago now. Wow, that was fast. We moved, right, and we were looking at houses at the time and wanted to stay in town, whatever. So we went to see this one house where we that didn't even hit the market yet. The couple was retiring, and they knew us from baseball, so they let us come in. And of course, you know, my wife, we walk in the foyer, and my wife goes immediately through the hallway into the kitchen and looking at stuff. And I go, oh yeah, babe, I'll be right. Yeah, I'll be right back. I'm gonna go downstairs. Only thing I really wanted was a finished basement because I did it in my old house. Didn't want to go through that fucking shit all over again. So I went downstairs to the basement and took a look at the, you know, so I was like pissed and happy at the same time because I go, oh shit. I looked at the furnace that they had. It's a high efficient oil furnace. And I laughed because it was only like 3 years old. And then I got pissed because I could see the air intake coming from the room and I could see the PVC going out the exhaust. Motherfucking bitch. It's always the fucking same. And these are local fucking guys. So, of course, we ended up buying the house, but the first day after we closed, I had, you know, one of my guys that I know in town, hey, yo, please go over there, drill the hole from the intake, use the PVC on the intake. I don't really give a shit about that. That's just air. And vent that shit with Centrotherm. Please. Get some polypro in there because I can't see that shit. Here's another reason why. This is the third reason why I don't like PVC. We talked about temperature. It's not rated, right? The acidity that breaks down the equipment. The third one, which annoys me the most, is the basement was for the kids, right? So, you know, that's their fucking area. Like, get the fuck downstairs. Just like that. Especially when I'm annoyed or I'm tired. Yo, get the fuck downstairs. But the reason we did that is that's obviously their playroom. They have sleepovers and shit. They're in the basement, right? So why would I ever want to put my children in a situation where we're using this piping material that's made of plastics and chlorine, sealing it with glue, and then fucking heating it up for 6 months? What do you think you're fucking breathing in? Carcinogens, man. It's cancer. Period. It's material not made for that type of application, and you're warming it up, and it's connected with glues and sealants and all this shit. Nah, not gonna happen. There's a reason why on this stuff you don't see any glue or fucking primer or anything, right? Not gonna happen. So, and then we wondered during COVID why people were stuck in their house and we make houses nice and tight and why people are getting sicker and sicker. Jason, why are you using shit pipe on the exhaust? My other favorite one, because it's by law over there, right? That not only do you have to pipe everything, vent everything properly, but you have to get it tested every year. And I told you about my grandmother, right? They don't play. They'll come and tear that shit out. Germany, Portugal, Spain, Italy, no matter where you go over there. And then they'll ask me, because they come over where I go there, and they'll go, Jason, why don't they do that in the U.S.?
I mean, in Germany, they also, the guy who installed it all.
That's my answer. I go, we got guns, motherfucker.
But in Germany, they'll also make the guy who installed it liable for it.
Yes.
Lifetime. I mean,
Yes.
Touch my furnace.
Yeah, I go, you can't do that shit over here. We got guns. We don't play. Try taking my fucking furnace out. It's hard enough when we have to red tag something, and I've gotten into I love to argue though, so I'm all for it. And I go, I don't give a fuck what you do when I leave. This shit is, gas is off, red tagged, I'm leaving. Here's my printout. Here it is. I had one situation in Jersey where it got into a pretty heated conversation, like, fuck you, not leaving this like this. I don't give a shit, I'm not signing shit. I go, no problem. You want me to call the fire department or the fucking police? Somebody's getting a fucking report that I was here and I told you. One or the other. I'll leave when the cops get here. But it's in the report.
Yep.
You have to know what you're liable for. Jersey's a special place. It's a very, very, very special place. All right. Let's go over one last thing here. And that is how to measure using your analyzer on a high efficiency versus condensed. Motherfucker, do it all the time. An atmospheric versus a condensing system. I hope on your video that you got a lot of beeps. Like, beep.
It's live.
Oh, shit.
We do not.
Well, is what it is.
But you're not the first.
I'm not the first, won't be the last. I promise you that. All right.
We already looked. We
Yeah. You have to. We have to warm everybody up for me. Okay. Every single combustion analyzer under the sun measures combustion efficiency to tell you how efficient a piece of equipment is running using 3 factors. We used to do it this way. What's the first thing you have to tell your analyzer? It's really hopefully the only thing you have to tell it, right? Okay. We're going to do an atmospheric 80%er first. So I put my probe in the stack. What's king? What? Thank you. My wife doesn't like the fact that I call it king. I go, yeah, but you're the queen. Your CO is the queen. That's right underneath, and it could kill you silently. She didn't like that one. She's good. We've been together since we were 15 years old. We were in our mid-40s. Absolutely not. My mom, when we got married, she literally sat her down and go, there are no fucking returns. So, you tell it what fuel, it measures this, calculates this, right? So every analyzer that gives you O2, in this order, by the way, O2, CO, CO2, set that shit to number 2 oil, look at your readings. On the same boiler, set it to kerosene for all I care. O2 and CO will say exactly the same because it's reading those directly. It will change this, thus changing your efficiency. What do you think the last thing that we're looking for? Starts with a T. What kind of temperature? No. Net stack temp. Room minus stack. Everybody gets a fucking paycheck. Everybody understands what net means. So if I have 300 degrees in the stack, 70 degrees in the room, what's your delta? If I'm off by 5 or 10 or 20 degrees, who gives a shit? You got a delta T of more than 230 degrees, right? But that's why every single analyzer you own, you see TF, T-air, and delta T. Every reading on your analyzer means something. If we only cared about stack temp, that's all we'd take. So your analyzer, you tell it this, it measures this, calculates this, the probe is in the stack with the thermocouple taking this, the ambient sensor's on the unit taking this, it calculated the delta, and all of a sudden, 82.5. And your losses are 100 minus 82.5. It does that for you, right? Okay, now let's do a condensing. Go ahead.
Are you actually measuring CO2 and CO?
Yeah, I am, but
Calculated it or actually
CO2 is the only thing that's calculated.
CO and actually measured?
That's why you have an O2 sensor and a CO sensor in every analyzer. Remember that stoichiometric curve I showed you where CO2 could be the same on both sides? Right. That's why I don't care what this is. I look for this to make sure I'm on the right side of the curve and the CO to make sure I'm on the right side of the curve. If I'm on the right side of the curve, then I'll trust whatever this fucking thing is. Believe me, when guys call me and they ask me questions and they'll go, my CO2 is, I go, shut the fuck up. Don't care. What's your O2? What's your CO? Now it's easier because if you're using this unit and you're in the combustion assistant, I go, what's in red? Just tell me what's in red. Right? But now let's do a condensing boiler or condensing furnace. You're going to tell me what the 2 differences are. I'm not going to. So tell me what the 2 differences are on a condensing system. We spent a lot of time over the last few hours.
Stack temp is a lot smaller.
Why though?
Efficiency ratings about different.
Of course, but why though?
Because it's taking and burning more efficiently.
How? One of the reasons. What are the 2 major differences? Looking at that guy, looking at that guy.
Outside here versus inside.
That's one. What's the other?
Force strap?
Yes, but uh-huh. I know, but we're missing the big one. Do you think that if we were running at 300 degree stack temp, we would be even having talks about PVC?
No, because everybody be dead.
Because that's the other major difference. Your stack temp is way different. It's all part of it. These are the two major differences. Your stack temperature is way lower. Your intake air could be way lower or could be different by the day.
It will be.
Of course it will be.
100.
Exactly.
Where if it's in the room, it's 70. I'm not saying take it out of the room, but.
Again, but you
gotta
won't
take-
condense.
You gotta take in consideration the outdoor air when you're.
You're
Well, the
reading
outdoor
my
air
mind.
Or the room air if it's.
So let's do it this way. Remember I said before, if you take your analyzer and you go up to a condensing system, right, like that one, right? You got two pipes. Fuck it. No, I'm gonna do it anyway. I gotta move around. I'm gonna put this up here, right? Probes in the stack. Yes? This is what I watch guys do all the time. They walk up to a condensing system, put the probe in the stack, not taking into account what? There's your primary. Not here. So if my analyzer is reading 72 degrees and my flue temperature is 100, it's a delta T of 28. So there's two ways to do it. You can rip a door off. So, sorry, I'm going to go back. There's two ways to do this.
Already linked to the internet, has the internet web.
I wish it was. We'll fucking get there one day. I know. There's two ways to do this. Number one, the units, if you don't have one, we have them. It's a little thermocouple, type K. There's a thermocouple connector at the bottom. There's a particular brand out there, I won't say their name out loud, it's black and orange, that have a thermocouple that is outside the bottom of the unit. So it's always taking ambient. So we're going to be wrong. You take this thermocouple. I love you. I don't
Trust you.
Don't press any buttons. Just plug this in. It shuts off my T-air, starts taking it from here. Intake, exhaust.
Nice.
Now, I don't have one. Fine. Go here. There's an air temperature button. Switch it from automatic to override it to manual mode. And now I can put in 25 degrees outside, go back to my screen, and my T-air set to 25 degrees. So look at my phone, see what it is outside, plug it in, print. So when I get the printout, right, that's what I'm looking for. So we'll do a little, what's your name, man? Jim? Jim, we're going to role play for a real quick second. Okay? My name is Jay Esquire. You know what that means? You know what Esquire means?
You're one of those a-hole lawyers.
Lawyer. Attorney at law, right? So that's why on the, oh, fuck. I dropped this thing. Yes, print. So you have, we see a lawyer's card, it says ESQ, right? Esquire, lawyer. So you're in my office today, right? And you installed, what's your name? David. You installed this high efficient boiler at David's house. Yes? That's why you're here today, right? It's a little deposition, seen this done, so it kind of. So before we get started, do you have the calibration certificate for your analyzer before we even get started?
I do, it's in the truck.
Thankfully you do, but it should be here in the deposition, right?
Right.
All right. But I'm glad you do. When I get pissed off when guys go, no. Didn't you just fucking hear me before? So, all right, so it says here, now you're the certified technician and that installed this piece of equipment, so I have just some combustion questions I'm sure you'll be able to answer pretty quickly. This is a two-pipe high-efficient equipment? Yes. And on December 1st at 8:30 a.m., the temperature was 73.2?
That would be inside temperature, ambient temperature.
Oh, so it wasn't the actual air you said that was on this two-pipe system? Yes? So I'm going to just scratch that out. I'm sure that's the only thing that's wrong. Let me just scratch that guy out of here. Well, if you're primary, then your delta T on here would also be incorrect? Okay, so I'm going to scratch that out too, okay? I'm not a combustion specialist by any stretch of the imagination, but I am led to believe that how a unit gets its efficiency that you gave to David here is based on one of the factors that's calculated is delta T, correct? So if I'm led to assume that if delta T is incorrect, then the efficiency would also be incorrect? Yep, that's another one. Now, if your efficiency is incorrect, that means the losses calculation on here is also incorrect. Yeah, you see where I'm kind of going. I've seen this shit happen, and I've not once. And when somebody asks, "Oh, on this date at this time," I go, "Oh fuck."
Yep. Some lawyers been prepped.
Well, yeah, because before they do, they talk to guys like me who go, "How does this calculation work?" And by the way, we didn't even talk about CO or O2 yet. All I did was, you have 7 fucking things on this printout. I just scratched out 4 of them. We're more than halfway there. All because we didn't do that.
How much, 10,000?
It's a lot more expensive than a fucking little thermocouple probe and a little fucking holes. There's a reason why on this stuff here. By the way, this is just to show you. The nice part about having the combustion assistant mode is a situation like this where they're testing gas pressure. They get the gas pressure here, and then you go to your, as you make adjustments to gas pressure, you could literally watch it on the screen to get it into green. Right? So that's why having the built-in manometer is really nice. But to go here, look at this one here. You see 2 test ports, don't you? They're not there for no reason. There's 2 reasons for that intake test port. Number 1, what's your true delta T? Number 2, recirc. Right? I don't care.
So when I run the, no, it won't give me that because it's only a probe. Scratch that.
No, go ahead.
I was just going to say, how do I get the printout that shows the recirc had nothing in it?
Had nothing in it?
Yes.
One way would be to put your probe in here, right? And if you see fresh air, 20.90, print that out because that's your intake.
Yep.
And then you have your printout from here.
Sure.
And you give, there's your air coming in, here's your exhaust. By the way, here's your heat exchange. There's all different types of things that you can do.
And all this,
Right.
and all this, of course, is uploadable to some digital platform.
Yeah, I mean, nowadays, man, I mean, look, you have a built-in printer, which is still kind of popular for us. We also have an option without a printer. But just to go back here for a second, let's say I'm doing a test and I don't have a printout. I hit the snapshot button, I hit QR code, and now I can just go to my app, which is free. Where is it? Here. And you could either Bluetooth it, pair it to here, or you hit the QR code button, and it just pulls up all the data.
Nice.
Now, when I hit save, you got your client information that you can fill in as much as you want or as little as you want, equipment, notes, model serial number, and I can email it as a PDF or an Excel. You could, on the app, you could load your fucking company logo on here, so when you send the report, it looks like comes from you, your information, right? Because there's a reason you fucking slap a sticker on the side of a furnace or a boiler in it.
Yes.
So what do they call? It's the same kind of idea. It's just that as we're starting to move away from printouts, it's digital.
Don't want to keep a whole shitload of paper copies in some filing cabinet.
I know, and I get that, and that's why like there's two versions. There's without a printer and with a printer.
Right.
The only reason the printer one is popular for us is because guys still are used to the printer. We're the only ones who have it built in, so it runs on the same battery circuitry and everything, and you can't. It's a lot easier that you can't fucking talking to a guy today. So my guys won't fucking lose this or break it, and you go, yeah. Okay, what else was there? Oh, right. I just want to show you one last thing here. So like I said, I'm going to hand out this sign-in sheet. If you guys want to sign in, I'll be happy to send you what you're going to get is an email from me probably later on tonight or tomorrow just saying thanks nice to meet you. Here's my contact information if you ever want to reach out to me with any questions. And if you want a copy of the presentation or any of the training materials, like we have wrote a book on combustion and stuff, you're more than welcome to have it. But this is what I kind of wanted to show you. Come on. Just different pictures of different boilers, where to test, do all that. I'm not going to go through all this today because we'll be here all goddamn day. But there is one section here. Oh, so you see, this is what the heat exchanger test looks like. So you can see the result there. And here's your printout, blower on, blower off. The difference here, by the way, is this is my older unit that doesn't have this kind of cool feature on here. So you mentioned before about you could do this with any analyzer. Watch this. 8.9% oxygen, CO 29.4, right? Nice and low. Blower came on, 11.1% oxygen. My CO increased, but not to a real alarming level that I would notice. But it's got a crack.
It's more than 5.
More than 0.5% for sure. But remember, I said at low things, you won't get a huge increase in the carbon monoxide. So that's what I'm kind of.
Which is enough to prove a crack
0.5%
of the original.
of the original. So if you're at 5.5 and you're at 6, it's going to show up as cracked.
On the CO or the O2?
Oxygen, 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 oxygen. There's only one king.
Yeah, your wife.
Queen.
Silent but deadly.
Silent but deadly. I told her
The CO went up there, but
it did, but still not above 100 ppm. So if you're not trained on how to look at the numbers, you would go like this. Okay, well, it still looks good because I'm under 100. When I'm showing you, no, you got a fucking crack in the heat exchanger. That shit's gonna get worse because look, when the oxygen came in, the CO went up. What do you think is gonna happen 6 months from now? It just keeps getting better. Better.
Got it.
It's a cool little trick though, right? Using an analyzer in order to do that. But this is what I'm talking about. We come up with all these different types of systems, give you the ranges. If you want a copy of this, guys sometimes print them out. Look, fuel pressure, 3.2 to 3.8. Guess what I hear all the time? 3.5. Drafts can change depending on the type of system. So 90%ers, all types of stuff. So where you put your test ports and all that kind of wonderful things. Sure.
Condensing boiler. That little trick you just showed, the crack heat exchanger.
Mm-hmm.
Well, you got a crack heat exchanger on the boiler, be leaking, but you can't do that.
On a boiler, no. Furnaces. You're moving air, right? A boiler,
You got
You
water.
have water on the
got water.
Water coming out the condensate drain, and you got
You kind of have a little bit more visual than you would on. Remember, 90% of the rest of the country is literally furnace. Almost exclusively. This is why the Northeast is not only oil country, it's hydronic country. There's very few. I have a pocket in Michigan. I got a pocket in North Dakota. I got a pocket in the Colorado. Does a lot of boilers. Don't get me wrong. The boilers are everywhere. But
You know the System 2000 boiler?
yeah, of course.
The guy said he sells a lot of those in Alaska. I said, oil?
Yeah.
Oil.
Uh-huh.
I said, how come? He goes, well, propane won't vaporize above -4, below
And you can
-4.
store a lot of BTUs in a
Yes.
small square.
Right, you get bigger bang for your buck with oil, but
You know, one of our
vaporize in Alaska.
Our two biggest markets, because I know EK very well too, is the Fargo, North Dakota area and Alaska. I'm not shitting you. I'm going out to Fargo in November.
For oil or just for
No, so they do oil. They do it, yeah.
vaporization rate?
So it's already fucking snowing there, by the way. Fucking Fargo. And I get asked all the time, even by my wife, why do you keep going to Fargo every year? I go, because they sell more fucking analyzers in Fargo than I do in New York City.
Or Virginia, or
Yeah.
pick one.
And the beauty, when we do a class, right? Minimum 80 technicians to each class. Minimum. Because nobody fucking goes there. So when I do a class,
You are the
they come from South Dakota, northern Minnesota, and guys around here are like, oh, it's cold. Shut the fuck up. No, it ain't. Please. These guys, I was there doing one in RHA Supply in North Dakota in Fargo, and it was fucking snowing. I go, yo, I'm not even going home. Like it was a Friday morning. I knew just based on everything, because nobody flies from Fargo to Newark direct. It's
That'd be a very popular flight.
no, you have to go to Minneapolis first, right, to connect. And I go, well, I'm fucking stuck here for the weekend. Awesome. And I go, dude, it's fucking snowing like hell. Like, are we gonna cancel the class? They're like, no. We had fucking 50, 60 guys at that goddamn class. Like, it's life, right? The world doesn't stop because it's snowing in Fargo. They're used to that shit. Hey, guys coming in shorts. So they do drink a lot after the class. I'll give them that. We do have a lot of fun. But anybody learn anything today?
Definitely.
Yeah, you put the FU in.
AFUE, I like that one too. I appreciate everybody coming today, listening to me. I'm going to hand out the QR code. So if you want to sign in, I will make sure you get a copy of the presentation and all that kind of stuff. If you're interested in taking a look at the units, I'm more than happy. Before everybody asks me, how much is it? Typically, the unit with a printer sells about $2,100. That one sells about $1,900. For coming to the class, you get $500 off.
Wow.
Plus a free carbon monoxide detector. What'd you pay?
$14.50.
So 15. You got it for better.
I got it from Dan.
You got it from my boy Dan.
Yeah.
Yeah.
I saw him at a trade show.
So this motherfucker just told the price out. So I'll tell you what. I will honor that same price of $14.50. That is like $650 off the unit with a free. Did you get your free detector?
Yeah.
Okay, so we're men of our words. $14.50, normally $21.50, but that's if you buy it through us. Okay, so reach out to us. Yeah, that's with the printer.
Ours was with a separate printer. We didn't get
Yeah, because some motherfuckers asked for the separate printer. I never understood that. Dan loves the separate printer. I don't know why.
I didn't realize how good the magnet would be on there with all that weight, extra weight on it.
Yeah, well, it's
I
that.
saw it back there.
Yeah, it's good.
Now I want to send it back.
Yeah, if you send it to us, or you don't need to send it back to install the printer. If you just get the printer, like if you want the built-in, all you have to do is take these 6 screws off. Takes the back off. There's a little kind of here.
Oh, so the printer I got will go onto this?
No, not the printer you have. If you have a Bluetooth printer, it won't. This little housing pops off, and you just literally plug this thing in and put the backing back on. Now, if you wanted to, God damn it, I will swap the printer. Okay, we're pretty good like that, man. I mean, if you send us that printer, say we talk, remind me because I see a lot of guys every week, so just email me and go, hey Jay, can you give me an RMA? Because I have to send you an RMA to send that thing in, so my guys know what the fuck to do with it when it gets there, and because I do this all the time, there's always somebody I offer something to. So just email me. I'll get an RMA and put the note in that when we get that back, we'll send you that printer and we'll swap it out for you. You got it. So I'll hand these out. If you guys want to see them, play around with them, please don't walk away with these. Scan it and pass it if you don't mind. Just leave them on the desk or hand them back to me so nobody walks away with these things. That would be great. If you want literature, our catalog, because we don't just do combustion. Obviously, we do all types of personal monitors. We do manifolds, refrigerant leak detectors. We're just coming out with a new manifold coming out next month. That's going to be on MeasureQuick. That's one of the other platforms that we're going on to with the analyzer next year. But we have manifolds, manometers, leak detectors, the whole nine. So appreciate you guys.
Another handout there,
Sorry?
something else you flashed.
Oh, yeah, the cheat sheet. My bad.
Is that a sheet you got to hand out? Or?
Yes, I'm going to hand everybody out a cheat sheet, okay, with the different systems and typical ranges. So you have.
Do you certify other people's equipment?
Yes, so we can definitely calibrate and certify any competitor's unit. The only thing we can't do is repair them. Because
Last question. Can you use would you recommend having two testers, one for oil and one for gas?
no, No,
It's fine.
it's the same thing.
As long as she's not pulling smoke.
The only thing I would tell you is just do a smoke test on oil before you do that so you don't fuck up my filter.